Hello, DataBash. I'm Arthur from the DatenWG core team, and we are a bunch of dedicated Power BI, Fabric, and Copilot experts who are really enthusiastic about Microsoft Data Platform and all the community stuff. This is B5. Humbly, we call us the Avengers of Power BI, and this is how we really look like if you want to see. Just feel free to contact us on anything about the Microsoft Data Platform and have fun at DataBash.
Okay, welcome everyone, and welcome to DataBash 2025. We're going to be starting in a few minutes, and we're looking forward to seeing you all very, very soon. We have on our agenda a great set of sessions and topics. The first one starting up today will be Steve Campbell giving a great discussion around Delta Parquet, demystifying Delta. A no code, no jargon introduction, which will be great. A lot of people need that given the state of the union at the moment, where everything is running in the cloud, in data lakes, and so forth. So Parquet is the basis of that, and we're looking forward to seeing Steve talk to us about these sort of things. Coming up as well on Room 3, we have sessions from Warwick Rudd, Ginger Grant, Edward Pollack, Maya Spanik-Kazan, Gilda Alvarez, Frank Giesler and Marcel Frank, John Miner, Hugo Cornelius as well, back basically for a very good action-packed set of topics in Room 3. I'll remind you all that we have several rooms going on today. We have rooms 1 to 4, all of them having their own topics, all of them with their own speakers, all of them are live. So definitely log on to the different channels depending on the sessions that you want. Go to our databash.live website to see what is on the agenda and which topics you want to watch. So we'll go back for a couple of minutes. We have 3 minutes left. Steve, I don't know if you would like to start a little bit earlier or if you would like to wait until our schedule starts, maybe to introduce yourself. Let me just see how many we have online. So yeah, let's just, given that it's morning, let's give everyone a chance to log on. But let's at least put us both onto the screen and see how we can do that. And just say hello. How are you doing? Good morning, Steve.
Good morning. Yes, doing well, thank you. How are you?
Very well, thanks. Where are you shouting out of today?
I'm in London in the UK.
Oh, lovely. Lovely. I lived in London for quite a number of years.
Yeah, very nice place. Used to live over in the States, actually,
Okay.
but happy to be back here in London.
Okay, how long were you in the States for?
About 8 years, maybe just over.
Oh,
So
lovely. I was in the UK for just going over 4 years myself before I came to Switzerland.
Excellent. Very cool.
Great. And so what do you do? Do you have your own consultancy? Do you work for a company?
Yes. As I'll introduce myself, but I work with my own consultancy, co-founded with my business partner, Reed Havens. We are Analytic Endeavors, so we do consulting and training and all that fun kind of stuff.
Great. Right. Looking forward to it.
Yeah.
So we do, yeah. Please go ahead.
No, me too. Yeah, I'm looking forward to a very, very fun topic, this one, I think.
Excellent. Excellent. So I take it then that, does that mean that Reed does the front end stuff and you do the middleware back end sort of engineering?
Pretty much, yeah. So I tend to look after the team who does the back end, more of the data engineering. We do a lot of sort of data platform stuff. And Reed does a lot of that. He's moving into some of the AI stuff as well, working on that kind of thing. So yeah, it's a good split that way.
Oh, good on you. That's great news. Okay, so what I will do right now, as we're waiting for a couple more minutes, I will put the website up on the page, and this way we can, I can let you do your final preparations, and we'll see how it goes from there.
Sounds
so I'll
good.
be back with you in about just over a minute.
Perfect.
Excellent. So welcome everybody. We are now getting into our first session for DataBash, and we have with us here Steve Campbell, calling out from the UK. He's going to be presenting to us Demystifying Delta Parquet, a no code, no jargon introduction. So Steve, please introduce yourself.
Yeah, thank you very much. Thank you for having me on. So my name is Steve Campbell. Welcome to the session here, Demystifying Delta. So we're going to be talking through Delta and as Microsoft seem to love to call it, Delta Parquet. We'll see why this may be a bit redundant, hopefully by the end of the session. But we're going to go through a very sort of no code, no jargon introduction. I do lie a little. We're going to show a very little bit of code at the end, but you don't have to understand it. Don't worry. This is really looking at sort of the theory behind Delta and Parquet. If you use Microsoft Fabric and any sort of data lake platform. So a lot of this will be quite transferable to things like Databricks as well. But if you use these platforms, this is sort of the underpinning of the whole thing. So if you use Microsoft OneLake, excuse me, this is what goes in to OneLake and is just so important. So with that, let's go through. So my name is Steve Campbell. So if you heard a bit earlier, I am the co-founder of Analytic Endeavors. We're a data consultancy, actually based in Seattle, Washington. We do sort of data platform stuff for the most part. We hope to get good data and make nice usable data, do a lot of reporting, BI, this sort of stuff, as well as training. I'm also a Microsoft MVP on the data platform side. If you like this and want to talk to me or have any questions, connect on LinkedIn. That is the best place to get me. Also got our company website there if you're interested in anything we do. With that, let's sort of introduce this session. So we're going to do a bit of a deep dive into Delta here, Delta Parquet. Very much, this is going to be theoretical, and this is a visual representation, sort of the underlying storage of Fabric. And again, not just Microsoft Fabric we're only talking about. We'll be focusing on Microsoft Fabric today. This does apply to things like Databricks or anything that uses Delta. I'll say some concepts may be simplified. You know, we're just here for an hour. I want to get a very good sort of good breadth of stuff we're going to cover. That said, this isn't an IT lecture. So we're going to kind of visualize some things in how we want to see it. So when you deep dive, you might kind of see some more nuances. But I think this is going to give you a really good overview of how things work. And again, it's really important to understand sort of the theory when managing Fabric items. And I put this point a lot more with the things like generative AI helping us write a lot of code. So with that, I think that's very, very helpful. And it's great that we can write such volumes of code. I think that's an even more important reason to sort of understand what's happening underneath the surface and a bit of the theory and make sure that we know what's going on and how things work under the code that AI is giving us. So, Microsoft Fabric. When we talk about Fabric, what we interact with is these items, or previously in other tools, they're often called artifacts. These are sort of UIs. These are the assets that we're using, and this is how we interact with Fabric. So, we build warehouses, lakehouses, things like that, notebooks, data flows, pipelines, get data in, semantic models, plus a ton more. Underneath the surface of this, we have four main compute engines. And so these are the engines that take our code or take what we've done in the UI and actually run what we're trying to do. So when you're ingesting data, when we're using Power BI, there's an engine underneath, which is doing the compute. And then underpinning all of that is the storage. And this is in, for the most part, OneLake. And OneLake is a data lake at its heart. So really, for pretty much everything we do in Fabric, we're storing all of our data in a big data lake. This is quite different if you've come from a SQL world or even many other worlds. Things work a bit differently in Fabric than they would, for example, in a data warehouse in a different tool. So OneLake is where we store the data, and this is what uses that Delta format. So this is going to be the agenda that we're going to talk about this morning or this afternoon, depending where you are. We're going to go through a couple of concepts at the beginning. And these aren't really tool specific. They're just some concepts and theory. Then we're going to start at the end talking with Direct Lake, OneLake, a bit more Fabric specific. So let's start with some theory and talk about column store. So before we talk about column store, let's think about how we can store data. And the easiest way we can think of storing data is something called row store. So one thing about the data that we're storing is we're always storing data in files because we're in a data lake. So the easiest way we could store data, imagine we had this table. And what we could do is when we open some data, maybe we have a CSV. We're going to see a nice table with rows and columns. What the computer is going to try and do under the surface is store this in the most efficient way possible. Now, what it might do is sort of store data like this. Instead of doing, every row in a big square that's going to take up a lot of space, we're just going to store things row by row by row. We pretty much just flatten it out, makes it a bit easier to store. So you can see this is row by row by row. This is very easy to store, right? And this is how we see the data. This is how the data is constructed. And in a CSV, it's just comma separated values. We'll kind of squish everything together and we'll put commas between each of the values. And then we'll have indications where the new rows are. Now, this is good. It's easy because this is how we see the data. Yet when we're doing analytics, we probably don't do things row by row by row. So if you're going to do, let's say, the sum of the sales by the salesperson and the sales column value, these are columns. So instead of when we're using this data for analytics, we typically do things column by column. Let's say I just want to write a query against the row store data, and I just want to get the salespeople, the names of the salespeople. You'll see that the names of the salespeople are always going to be very far spread apart. That's just because we're storing this row by row by row, and we're looking at a column. So this is not so efficient when we're trying to read the data because there's lots of data, it's all spread out. So in comes column store. What we can do is instead of storing data row by row by row, we can store data column by column by column. And so even though when we read the data and we look at it on a UI, on a screen, it's going to show us in the correct way. But underneath, we're storing things column by column by column. And now if I said, give me a list of all the salespeople, this data is really close together. And it makes it a lot easier to do that for the engine because it doesn't have to search through the whole data set. It knows this is the whole column. So that's kind of cool. However, it gets really cool actually when we store data this way because we can do lots more stuff to the data. We can actually make this a lot more efficient to store. One thing that we're trying to do when we're storing data is be as efficient as possible. We want to compress the data. We have very big data now, and it takes up a lot of space. So we just want to do some tips, some tricks, and kind of stuff under the surface that we being the engine, right? When we save the data, we want to compress this data down. So one of the things we could do is something called run length encoding. If I said, read this number out, you might sit there and say, well, the number is 3333333, right? It'll take a long time. If I was going to say this number to somebody else, what I would probably say is this 10 threes and 5 fives. If I wanted to write this number in a more efficient way, what I could do is just do this. As long as the other person knew the notation that I'm using, I can say there's 10 threes and 5 fives. So I can say the first number here is 10 threes, 5 fives. Assuming we understood the notation that we're using, the first bullet point, the second bullet point, and the third bullet point all display the same amount of information. They all tell us the same number. However, the first bullet point, which is our uncompressed, the whole number, actually takes up a lot more space, right? There's a lot more characters involved to write it. So this bottom one is a better and more efficient way of storing the data. So this is kind of cool. And we can use this concept in order to apply this when we're saving data. So let's imagine that we had this table here. Because we're storing things column by column, now when we're not going row by row by row, we can think of each column sort of independently, because we know each column is going to be stored together, and column A, then column B, column C. In column A here, we have Bill. Bill is repeated 3 times in a row. Jane is then repeated 3 times in a row. What I could do is I could say, let's take the first value of Bill. What I'm going to do is next to the name in the first value, I'm going to write how many times in a row Bill is repeated, which is 3. I'm also then going to write just what row number we're on, which is just going to make it easier for me to keep track. Then next time this value changes, I'm going to do the same thing. So here, Jane is repeated then 3 times in a row. And we start on row value number 4. So Jane is repeated 3 times in a row at row value number 4. And Bill is repeated 3 times in a row at row number 1. I'm going to do the same thing with Sarah and Alice. So Sarah is repeated once, Alice is repeated once at rows 7 and 8. I'll then do the same thing in my second column. So every time I see a new value, I'm going to write how many times it's repeated, and I'm going to write the row number we're on. With that done, you'll see that right now I've actually added data, right? So I've made my data bigger. However, every value, every cell in this data set that doesn't have a red number attached to it is now not needed. So if I did this, I can still see the same amount of information. I know what the data looks like, this full data set, but I can actually remove these values that don't have a red number because I know what they're going to be, because I know, in the name, Bill's repeated 3 times. So I know the next to our Bill just by that number 3. And I can actually remove this from my data set when I'm saving it. So when I store the data, when I save it, I can actually remove these values. When somebody reads the data, when I see the table, we can rebuild the table on the fly with a compute engine. But storing, we can store data like this. So this is run length encoding. Now, this works because we can have repeated values in the data set. We use the word cardinality. And if you're Microsoft, they love to reuse the same words for different things. If you're from Power BI, it might mean something else. But in this case, cardinality means the number of unique values in a column. So the lower cardinality, the less amount of unique values, the better it will compress. And that sort of should be able to understand when you think through, because if we have less amount of unique values, we're going to have more repeated values, and then we can take away more data, right? Because the more repeated values we have, the better it's going to compress. And this only works because of columnar store, right? Because we're storing columns separately. So we wouldn't work in row store, wouldn't be able to do it. And so you can actually see that because we're storing columns a column away and separately, we have different amount of values in each column. So, and you may be thinking as well about sort order, right? Because at some point you will get the same value over and over again, depends how the data is sorted. The algorithm, the compression algorithm is going to do this for you. It's going to figure out the best way it thinks to try and sort the data to make it compress the most. Second thing we can do is something called dictionary encoding. Now, let's say we have this column, right? This is just a single column we're going to look at, and we're going to save this. Now, unfortunately, there aren't any repeated values, so the run encoding isn't going to do a lot to this column. However, what I've done is I've counted every character. So every character, that's any letter, any punctuation, any space. And in this column, there are 137 total characters. When we're storing data, we want to have the least amount of data, right? The more characters we have, that's more data that we need to store. So the more space it's going to take up. What I can do though, is I see that the data is actually repeated, but because of the sort order, it's not repeated in a row. So this is always going to happen, depending, because you have to sort your whole table. So because of this, we will have some repeated values. What I can do though, is I can just write down a list of all unique values in my column. So there are 3 different unique values here. And this is them. I think these are law firms that are our clients. And next to them, I'm just going to give them a key. And a key is just going to be an integer here. So I've looked at the whole column, listed the unique values, and given each one a key, and just written them once. Now what I can do is I can replace the values in my original column with that key. If you're familiar with dimensional modeling, I think of this as sort of a dimension and fact table, right? Giving it a foreign key over to my unique list. If you're not, and that doesn't make sense to you, don't worry, it's not important. But essentially what we're doing is replacing the original values with a key and then just listing out the names once. Now, if I count the characters, all the characters in my column, plus in my new dictionary table, this has actually gone down by 84. So you can see there's a huge compression there. That's 60% of what it used to be. So just by doing that, I've really taken out a lot of the data. So again, the more data in a column, the larger it is to store, which sort of makes sense. And this is hash encoding, which is another word for this dictionary encoding. This builds a dictionary and assigns the integers to the original values, right? And the idea being that in the column where the data is going to be repeated, we can just store this integer, which is going to be a lot more efficient than repeating the name over and over again. We only have to list the name once within the column. Again, high cardinality has a higher impact, right? So the more unique values, the longer our dictionary is going to be, which is going to make it more expensive to store. So column store then, let's run through the example that we had. The first thing that we're going to do is we're going to do a run encoding, where we're going to say, let's remove the repeated values and put a number next to them just to say, so that we can rebuild the original data set. So here we've added the numbers. So we know in the name column, Bill's going to be repeated 3 times, Jane's repeated 3 times, and Sarah and Alice repeated once. So we've shrunk our data set without losing any data. For every column, we're then going to build these dictionaries, just store the unique values once. so that we're not repeating over and over again, and then replace them with a key. And then we store this column by column by column. So our data looks a bit like this when we store it in a column store format. Again, I will say in real life, the data doesn't look like this because the data is actually stored in bits and ones and zeros and binaries, and computers don't use letters like we do. This is sort of how to visualize what's happening under the surface. If you open the file and looked at, how it read the uncoded data, wouldn't really look like this. But this is the theory, and this is what it's doing, just in its computer language of binaries and ones and zeros. Works on the fact that this only works because each column is stored independently. And you can see now that by storing these columns independently, we can get huge compressions. With such a small data set like this, it doesn't look like a lot. But you could imagine if you have, values repeated thousands of times and you have millions of rows, that really adds up. So running encoding reduces the amount of values in the column. Hash encoding or dictionary encoding builds its dictionary to reduce the amount of data in the column. All right. So that's column store. Bit of theory there. No, we haven't talked anything about Delta or Parquet yet. So let's get into Parquet. So why do we just talk for 15 minutes about column store? Well, Parquet is a file format. And Parquet is essentially a text file, like a CSV. However, Parquet stores data in a column store format. So unlike a CSV, which Parquet stores data in column store format, with one slight difference. Instead of just taking the whole data and storing it, Parquet can kind of break up your data into row groups. And so Parquet just takes the big file and it can break it down into different rows. We might say we break the data like this, and then each of these sections of the big table will be stored as column store formats. So this is column 1, column 2, and column 3. And each of these are stored as their own file called Parquet. So that is Parquet. All it is a file, a text file, sort of like a CSV. However, we store things in column store format, and it's also stored, broken up into multiple files. So the engine knows when it's reading the data, and we're going to look at, we say, let's look at the table in SQL or in Power BI, something like that. It knows how to rejoin these files back and make one big data set. And we can have many files. So Parquet is actually an open source format. So it's not owned by Microsoft. It's open source, and it's a very useful and helpful format to save things. I call this a hybrid column-based because it is column store, but it's sort of hybrid because it also breaks things out by row groups. Really good compression available. You store this through the column store. And then it's better at OLAP versus OLTP. We'll cover this more and more, but this means it's better for analytics rather than high writing and high transactional data. So as you can imagine, you lose a bit of time saving the data because what it has to do is it has to break out row groups. It has all these algorithms for the compression. So it's really good when doing analytics because when we're reading the data, when we're using columns, this stores it really well. However, when writing the data, it's a bit slower. One huge thing about Parquet, which I haven't said until now, you cannot edit the files. They're immutable. So if you wanted to change something in your data set, you don't edit it. You just have to insert and delete a new file. So this makes it very difficult to use, actually, because these files are uneditable. And this sounds like a management nightmare, trying to keep track, because now we've broken our our data into lots of different files. So what if we wanted to edit one certain row in the data? So Parquet is really good, has this terrible flaw, and not a flaw, but makes things very difficult that we can't actually edit them. And that makes it very difficult to use in a system. So what is the answer? Well, in comes Delta. So what is Delta? Delta simply is Parquet with an additional bit of data called the transaction log. So Delta, and this is why I think it's a bit redundant calling it Delta Parquet, because Delta is Parquet, right? Delta is stored as Parquet. It's just a format of Parquet, except we have an additional file that's along and saved with the data. So let's talk about this transaction log. Now imagine we're going to save this table, and we save it, and it might save into file A and file B like this. Now, instead of just saving this and being hard to manage, when we're using Delta, we have this transaction log off to the left here. And what we do is we say what we've done. So it's just a list of things that we've done, sort of like note-taking. So we say we've saved file A, we've saved file B here. And on my transaction log, I'm just going to write the first thing we did, task 1, is we loaded file A and file B. And this was on the 1st of January, 2023. Now, imagine I want to delete or I want to edit a row. What I'm going to do is I'm going to edit the row Laura with cells 19. I can't edit the file directly. So what I have to do is I will make the edit in my UI, and then the system managing Delta knows that the data is in file B. This is just one table, right? But we've stored them in multiple files. And so what it's going to do is it's going to say, I can't edit the data, so it actually has to delete file B and load file C with the corrected data. Right? I just wanted to edit the one row, but I had to delete the whole file and load a whole new file in. And I said Alice 17. Then I realized, nope, I edited the correct row, but the data was wrong, right? And it wasn't actually Alice. I really wanted to do a separate one. It's actually Sarah. So what I have to do is if I want to go ahead and make another edit, I actually delete file C again, and then add a new file in called file D. So what I've done, right, is I saved my data in task 1, load file A and B. And then 4 days later, I said, oh, I've made it wrong. So in my transaction log, I wrote load file C, delete file B, because I had to load in the new file and delete the old one, because that's the only way I can make edits. And I put a note on the date that I've done that. Finally, I said I'll make another edit because I did it wrong again. I realized this was 16 days later on the 21st. And again, I had to delete the whole of file C and load file D. Now, this is great. So Delta's just giving me a list of things I've done. What's the point? The beauty of Delta is when we're doing this, we never actually delete the underlying files. So I've had, there's one table with 4 rows. I saved it. It was originally 2 files. I've made 2 edits. So I have 2 new files. I never actually delete the old files. Instead, what I do is I read my transaction log. So if I wanted to load the table, I can look at my transaction log and I say, task 1, load file A and B. Task 2, load file C, delete B. Task 3, load file D, delete C. If I followed all those steps, not actually deleting things, but ignoring them, so I could say ignore, I would be left with what you see on the screen, file A and D. And this is what the data looks like now. And now I can get the table, and I can see my data in the most current form. What if I wanted to see what the data looked like on the 20th of January? What I could do is I could just read the transaction log and stop when I get to the 20th of January. So I could say, I would read through the transaction log and I could see load A and B. Yep, that's the 1st of January. Load C, delete B. That's the 5th of January. And then task 3, and if there was anything after task 3, that happened after the 20th of January. So I know now not to execute those tasks. So this is called time travel. I can actually see my data in the format that it was at a certain date I pick, whatever date I want. And so this delta log actually provides a lot of good features. We have something called ACID functionality. If you're not familiar with ACID in databases, feel free to go look it up. It's essentially just some governance and making sure things that we do is very complete. Because we have a list of everything we've done in the data, in the delta log, in this transaction log, we can actually have a full history, and it really provides some governance around what we're doing. It allows this time travel. So it kind of helps manage all of these files that we're saving, because we can't edit Parquet files. We have to delete them and load them. Instead of just deleting them out, we save them, or we've written what we're doing in the transaction log. And this makes it very, very easy just to check and go back and do all this stuff. If we did something wrong, we can undo deletes, right? It gives us this undo functionality. It allows data lineage and debugging. And again, this is because we've got every step, and we can see every time we made edits, we can go back, see what has happened, gives us a lot of control around what's happening. And then we have huge data optimizations. This, of course, the data optimization is because the data is actually stored in Parquet format, and the Parquet is this column store, which is really efficient. Cool. So that is Delta. Excuse me. So one thing now that I want to talk through is a few more optimizations that Delta does under the surface. And this is less about storage, but it's more about reading and making it quicker. So the first one we have is something called Z-order and optimize. Imagine we had this data set, and we might have split it out into these 3 different Parquet files, which are stored, column by column. Of course, it's compressed under the surface. We're just going to look at the data like this. I will say, in real life, if you just saved a small data set like this, it would never break it into 3 rows. How it saves the data can be influenced by a lot of things. How many files it uses can be influenced a lot of things. A lot of it is how you actually write the data. Because I can't edit, imagine I saved this data set in 3 different insert statements into SQL. So I made 3 updates. I did the first 3 rows one day, the second 3 rows the next day, then the third 3 rows. In that case, it's going to save 3 new files for each of the data, because I can't edit the old file. So if I insert data, it's just going to add a new file with the new data. So that may be why our files look like this, with 3 rows in each. If I wanted to write a query though, so now I want to query my data and I want to see, show me the sales when the sales is greater than 14. The most expensive thing for the engine to do is opening each of the files. Right? It's very optimized to kind of scan them, to do all of this kind of cool stuff. But opening the files is quite expensive. And if I say I need to get the sales column where all of the sales are greater than 14, it takes a long time, because I have to go into each file. I have to open the file, me being the engine, and I have to look at the data and see if there's anything greater than 14. And if you can imagine, you can have a lot of files if you do lots of inserts over time. So that becomes very expensive to do. and it's quite inefficient. And that's kind of the big downfall just of using a file system where we have so many files to store a data set. Well, we can actually do some optimizations on this. When we save our data in our transaction log, instead of just saving what we did, we loaded file A, we loaded file B and C here, we can also write for each column the min and the max of that column on our transaction log. So you'll see here that file A had the minimum 9 and the maximum 12 for the sales column. B has 15 to 20, and C has 10 to 16. Now, if I said, show me the sales where the sales is greater than 14, instead of having to open each file to look inside it, do this, to every single file, I can just look at the transaction log. I can see, well, file A has the maximum sales of 12. I know that there isn't going to be sales greater than 14, because obviously 14 is bigger than 12. So what I will do is I can actually just skip opening that file. I'll have to open file B and file C, and then find all the sales greater than 14. And this is called file skipping. So file skipping can really reduce the amount of files I need to open, which makes it a lot quicker to run. Also works on text columns because the alphabet, right, is an ordered, but it also save the min and the max of the names. So there's only Bill in file A, so it's between B and B. File B, the minimum is J and the maximum is S, right? So I know I only have letters between J and S. And then for file C, I have letters between A and S. If I said, find the names which start with D, I could then skip file A again, because I know there's no Ds. And file B, actually, because there's no Ds between J and S. I would only have to open file C. There isn't actually a D in file C, but without opening it, with only knowing the min and max, there could be, because I know the min and max is A and S. So I still have to open that file. But again, that's much more efficient, 3 times more efficient than having to open every file. So let's imagine, though, that we've saved data like this. And again, we may have how we inserted the data. We've got data and it kind of looks in this format. Maybe we've been editing this sort of stuff. What if I said now, select the sales where the sales is 14? Well, in my transaction log, I've done a min and max. And in this case, you can see 14 could fold in every one of these files, right? Because 14 is between the min and the max of every file. So that's not very helpful to me. This can happen, again, depending on how we save the data, how the data gets added. If the data got added in 4 different inserts like this, it would be in 4 files, and they'll be in that format. Over time, this file skipping becomes less efficient because the data is not very well grouped. So what we can do is we can actually run something called an optimize command. And within this optimize command, we say, resave the files into a new way. So look at all the data and basically take the data that we have from now, save the files in a new format, and we will order it by a certain column. So we can optimize it and resave them in the new structure. We're going to say Z order by ordering them, in this case, sales. So I might run this command and it will kind of do this under the surface, right? It's the same data, but now it's just arranged them into different formats. And you can see that the min and the max, when it's done, is it's saved similar values close together in the same files. Now the min and the maxes are much lower, which means that the file skipping is much more likely to happen. And 14 actually can only appear in this file. So this is an optimized command with Z order. So Z order and optimize make it much more efficient to save. The next optimization is something called vacuum. as you can imagine, there is something we have called the small file problem. Take this data. Imagine that we've had this and we've been doing lots of inserts, lots of updates, every day for several years. We're going to have millions of files and millions of old files from years ago, of how the data looked 10 years ago, that is no longer really relevant. So the data storage at some point is going to become really, really big because we have all this old data that we're storing because we never actually delete anything. Well, Vacuum simply says all of these files that we've said we've deleted, we can actually delete them. So I think of it, when we make the edit, it's sort of a soft delete. Vacuum does this hard delete. Vacuuming, I will say, stops your ability to time travel, right? Because time travel relies on us not actually deleting the old data. However, what we can do is put a date for the vacuum. So you can say only vacuum things older than normally about 7 days old. When we do that, that means that we still can time travel 7 days in the past. However, data older than that, we say we don't need to time travel on that anymore. We can hard delete that. That's good. Let's free up some space. Time travel is not meant to be used to kind of snapshot, historical data. It's really used for debugging. I think of it like having things in your recycle bin, right? So these files still exist and they're not in use anymore. And they're just there if we want to go check something. After 7 days, we might say, hey, we're good. We know this is correct. We don't need to roll back. We don't need to go back, debug anything, and we can vacuum them and hard delete them. Whew. All right, running through. The last optimization I want to talk really quickly is about codec compression. Not so important, but I think it's quite interesting. So really, as I said, computers store things as bits internally, kind of made from ones and zeros. And what we want to do is compress things as efficiently few bits as possible. Many algorithms that we want to achieve this, but the most common one is called snapping. We use Parquet. So we have this column here. We run our dictionary encoding, and then we run our runIC encoding. It doesn't really matter which order we do this. Now, the last thing we want to do is save it into a file. What we can do here is we take our data, how it looks like this, after compressed, after doing the encoding. And we notice at this point, this pattern is repeated, right? So we have the value 1 repeated 3 times and the value 2 repeated 2 times. And the value 1 and 2 refers to that dictionary somewhere. So actually what we can do is we might store data, and it might sort of compress data into bits and store it like this, and it kind of chunks up data. Don't worry too much about these words, but I might store the first 2 values together in a single bit, the second 3 values in another bit, and then the last one, I don't actually have to store that data. I can just store that as a reference because I know that this pattern is repeated. So I can say, instead of actually storing the data, I can put this reference. In the bottom right, I say, go back 5 spaces. So position -5, go back 5 spaces, and the length is 2. So instead of restoring the same patterns, I just reference where in the data this pattern happened and how long it happened. And then I don't have to store the data again. So very cool kind of little trick. Not super important to know, to be honest, because there's nothing you can really do to change it. But this is what it's called, and this is a snappy. And you'll see there's different ways you can store delta. Most common snappy, and this is one of the things it does among others. Cool. All right. And now one of the final things it does is something called VORDER. VORDER is a Microsoft. So everything I've spoken up until this point could be any technology that uses Delta. VORDER is very specific to Microsoft. What it does is it stores data more efficiently when writing and so it can be read faster. I think the official stats, it can take up to 15% longer to save the data, but it can actually be 50% more optimized. This is not open source. So they don't actually tell you the algorithms they're running, but they have their own algorithms that they're running under the surface. And this is Microsoft specific. So they just have another optimization. Can't really go into it because they don't tell us. All right. Wrap up the optimizations. So there's two. One is when we're writing the file, is then saving it for space. And the other one's just sort of optimizing the storage as we go through. So we have the RLE, the run encoding, dictionaries, other algorithms. Open source column store format allow us to make data smaller. The order is an optimization for algorithm specific for Microsoft tools. It will still, even if you save data with the order, it still works in other tools, but it's just a Microsoft specific thing. Pressure, finally, on choice how to save, and get a couple of options, codex of saving in Delta. Most common one is Snappy, and it's the default in Microsoft Fabric. Then, excuse me, we have the optimize in Z order, which is that reconstruct the files to better compress and doing better file skipping. And finally, we have the vacuuming, right, to free storage over time. Perfect. All right, into the end. Now I just want to talk quickly about Direct Lake, so your Power BI people. So very quickly, talk through when we're saving a semantic model. In a semantic model, we really have two assets. We have the data and the metadata. So the data is basically just the data copied from the source in an import mode. We don't actually directly edit the data. It's just in a model, it's stored there. We can edit the Power Query code, which tells the engine what to do with the data. We don't edit the data directly. And this is actually stored in a column store format by the Vertipack engine for import mode. The metadata, which is the TIMDAL file, if you're familiar with that, the new format, or it could be TIMSL, the old format. It's just code, and it stores things like our DAX, Power Query, hierarchies, all of this code, which tells the engine how to use the data, right, and how to aggregate it. So we have these connection modes there. Import direct query, and then I put live connect here just to kind of exclude it because it's not really a connection mode. Live connect just describes how a report is connected to a semantic model, and it's just that connection. We're talking about the connection mode of the semantic model to the data. Import mode, we can have many different sources in many different formats. Power Query is great, right? We have our semantic model. The data is copied into the semantic model, and the semantic model then consists of the data as well as the TIMDAL file, the metadata, the DAX and stuff. Direct query. We have several sources, things like SQL that we can direct query to, not that many. And then we have data in some formats, right? There's only some formats we can do direct query on. And no data is copied in. Now we can cache data and stuff, but we don't have a data set. So a semantic model for a direct query mode is just a TIMDAL file. It's just the metadata, right? And we read the data in real time on demand. Then we have Direct Lake, and this is the new format enabled by Delta. This works only with Delta files. And actually what happens is that the Delta in either the warehouse or the lakehouse is shared by both the semantic model and the lakehouse or warehouse in Fabric. And we have a TIMDAL file only in the semantic model. So unlike direct query, where it kind of reads data from a source, and unlike import, where it copies it, the lakehouse or the warehouse and the semantic model share the column store format in Delta. And it turns out that Power BI is very good at reading Delta files because it's the same sort of format it's used to. And so they say this is direct query benefits of having data always up to date from the source, but in poor performance most of the time. So sometimes it does fall back to direct query, but generally it works quite well. One thing that we can do in Direct Lake is we can actually refresh our data. Why do we want to do that? It might be that we're running an ETL pipeline and that some data is processed before other data. So maybe one fact table is processed 10 minutes before the second fact table. I don't want people to look at a report in this 10 minutes and have the data fully up to date all the time, because my numbers would be wrong, but the ETL pipeline is still running. So we can actually take refreshes in Direct Lake, but we're not copying data like import mode. So how do we refresh when we're not copying data? What we actually do is we use the transaction log. So when we do a refresh, we just look at whatever the current task is on the transaction log. Then the data might change. In an example, the data has been updated, but our Power BI was refreshed at task 2, and it uses the time travel feature to go and check and actually shows us data from that point in time. So it uses time travel. It just takes a state when we say we want to refresh it. That's our time travel point. We can go back in time. Of course, if you vacuum this, you're going to have adverse effects, which is why you tend to vacuum only a week old. So Direct Lake, stored data in one lake as Delta. We're always up to date with import performance. But sometimes, because it doesn't always happen, we can schedule refreshes to take us to the current state. All right. Now let's round out the last few minutes with one lake. I'm going to tie this all together. So I want to just talk through the lakehouse and a warehouse, right? Both warehouses and lakehouses offer SQL endpoints in Fabric. SQL is structured tables, while Lakehouse offers both structured tables and files-based storage. If you're not super familiar with this, you can go to the Microsoft Docs. Big difference is how you add data to a lakehouse or warehouse. You can only add data to a warehouse with SQL. You can only add data to a lakehouse with Spark. So lakehouse, we have SQL, warehouse, we have SQL write. Lakehouse, we have Spark write, we have files. They both allowed us to read data in SQL. The reason being is that when you use tables in either a warehouse or a lakehouse, so by default, everything's a table in a warehouse, they are stored as Delta. So data is not stored in SQL under the surface. It is Delta. So this is in a warehouse. Data is always stored as Delta, and that can be quite different for some people. So here, I want to kind of talk through a quick example medallion architecture. So imagine I have a bronze, silver, gold, and then a semantic model. Now you could store the data in any format. In my example, I'm going to store it in Parquet in the bronze. So it's stored as a Parquet file. Then I might change it to silver. I might restructure the data, but I'm just looking at how it's stored. And in this case, I'm going to save it as a table and store it as Delta. Really though, it's a table of Delta. Underneath the surface, it is still in Parquet, but with a transaction log, with the Delta log, just some metadata. Gold, all I've done in this case is restructured, so the data is the same. Then in my semantic model, I'm going to store it as a semantic model in Direct Lake. And here, if it's stored in Direct Lake, it's still Parquet. And with the transaction log to make it Delta, now with extra metadata of Timsel. So really, in this example, we've kept it in Parquet, restructuring it, we've just added metadata along the way. Cool. So I like to say this, when you're using a warehouse, unlike normal warehouses where it uses SQL and Fabric, underneath is just text files, right? It is really just this delta stored under the surface. So then to finish up, in OneLake, we have these items at the top, for example. We have OneLake. We have the option to store data in files. Most things can use Delta. We have things like SQLDB and EventHouse, which have their own storage. These aren't sort of the main things. They were just added to if you need something other than Delta. But let's look at the main things, right? Our main analytics workflow that we're doing. All of these items can kind of use Delta under the surface, and they all have their own compute engine. So you have Spark, SQL, Analysis Services, or KQL. These are the compute engines that the items use the data. Underneath, they're all stored in Delta format. With that, thank you very much. Please check us out at Analytic Endeavors. We do a lot of training if you really love this. If you wanted just to say thanks or wanted to talk to me or had any questions, check out my LinkedIn. So thank you so much. And I think we're right on time. So I'll let you take over. And I'm really excited to introduce the next speaker.
Thank you very much, Steve. That was great. A lot of interesting information about the Delta, more actually than I was expecting. So thank you very much for all of the internal information about how vOrder, zOrder, all that works as well. And great mapping back into the Medallion architecture and how the storage format helps from that perspective. So thank you very much, Steve. Very informative. I'm sure a lot of people have gotten a lot of benefit on it. And for everyone to remember, we will be sharing these sessions also on YouTube later on. So feel free to join us there. So thank you very much, Steve, for joining. And I'll take this chance now to start introducing our next topics and speakers. So have a good one, Steve.
Thank you.
And thank you very much.
Thank you.
Cheers. What we're looking at next is basically on the agenda, as you can see now, we now have Ginger Grant and Warwick Rudd, basically, who are going to be talking to us about how to decrease cost and management effort with Fabric SQL database. We have them both online, so I'll see if I can add them both and get us all three on the stage, which we can wonderfully. Hello, everyone. Welcome aboard.
Hey, Charlie.
Hey, Charlie. Doing all right.
Excellent. Thank you very much for joining. I can see on the screen here that we do have a presentation, so I'll add this one to the stage. If it allows me to, remove first and go this way. And I think we are 2 minutes before time, so we're looking forward to hearing all about decreasing cost management. Fabric SQLDB is a new player into the Fabric game, so excellent that you're going to be presenting to us about SQLDB. There's a lot of interest and a lot of questions around how it works, so I'm looking forward to seeing the presentation myself as well. With no further ado, I'll give you that extra minute to introduce yourselves and to introduce the topic, and feel free.
Thank you, Charlie. Okay, so welcome everybody. I hope you've had a fantastic first session at DataBash 25. It's good to be back for DataBash. So as Charlie mentioned, we're going to be talking about decreased cost and management efforts with Fabric SQL database. So what's that going to look like for today? Okay, so in our session, we're going to have a look at what is Fabric database or Fabric SQL database. Okay, we're going to have a look at when it's the right choice to choose this particular database, because we've got a number of choices available to us. We're going to have a look at some monitoring and maintenance on what we can do, how we go about doing it. We're going to have a look at some cost models, as well as some ongoing management. So with that, who am I? My name is Warwick Rudd. I'm a data platform MVP, and I'm going to be presenting today with my co-host, Ginger, who will be introducing herself very, very shortly. Okay. The most important part about this slide deck is my contact details. Okay. Feel free to reach out to me and ask me any questions about this session or anything else on the data platform. So with that, Ginger.
Thank you very much, Warwick. Looking forward to talking about this topic. My name is Ginger Grant. I am a data platform MVP, and I am from Phoenix, Arizona. And I am also a certified trainer. I put LinkedIn information up there because not only am I on it like everybody on the planet, but I've also got some classes on Fabric that, especially if your company's paying for it, you might be interested in. Let's go, Warwick.
Okay.
Well, looking at when is SQLDB the best choice for a database anyway, everyone thinks about Fabric and they're always thinking about the analytical side of it. Hey, I've got some data. I want to make sure that I've got it, ready for reporting for Power BI. But you know what? People still need to look at a database now and again, and they want that database performance. They want to be able to do the indexing. They're looking for something that does transactions really well, unlike the rest of Fabric, which is really designed for analytics. So if you're looking to store data, you want to be able to do ad hoc querying really, really fast. Perhaps you want to do an application. And maybe you don't have a lot of DBAs. One thing that I'm seeing more and more in different clients is they're trying to kind of cut back on DBA support. And so there's not a whole lot of people who've got that knowledge in-house perhaps. And if you don't have a DBA, you're not going to be able to do a lot of really clever management like what Warwick does and, make sure everything is working. So maybe you want something that just sort of happens for you. And you want that to work because it just does out of the box. So taking care of all that for you. And then again, nobody wants another Azure bill. So looking at perhaps rolling that into one place so that all you have to deal with is one bill. And that's another thing that Fabric in SQLDB offers.
So keeping it quite simple. Okay, so what are some of the use cases that we're talking about? So as developers, right, we want to be able to create applications that predominantly have that requirement to go and connect to a database, read some data, write some data, and do some stuff to display that out. Okay, so traditionally that's been really difficult depending on the environment that you're working in. Okay, so you as a developer, you go and create something, you throw it across the fence to the DBAs and they go, no, okay? Or you haven't got any DBAs to support you. And do you even know, are you doing the right things in how you're developing or building that database, okay? Are you gonna get the best performance? Well, SQLDB in Fabric is really assisting for you, okay? You get to be able to quickly and easily spin it up. We'll talk about that. But it takes away a lot of that database management side of things because it's just done for you behind the scenes, okay? Throughout this session, you'll hear both Ginger and I talk about there's virtually no knobs, no dials for you to play with and adjust with Fabric SQLDB. It just does it for you. Okay, so you can build your applications, you can build your database, connect, you're able to monitor it to see what's going on really, really quickly, and you haven't had to know how to go and set all of that up. Okay, so it makes it so much easier. We've got here, resolve common pain points because Fabric SQL database is doing it for you behind the covers, okay? The creation is so simple. Normally we do a demo, but I'll quickly touch through it later, but it is so simple compared to creating an Azure SQL database. For those of you who are on the call, if you've already done that, you will know what I'm talking about, okay? The other beauty of it is we've made it so simple for you, but we've got extensive support for KQL. So to make your lives easier, throw that into the mix and we're off and running.
So one of the other things, of course, Microsoft has designed it to work really well with AI. And when you're looking at AI, you're looking at how the data is stored. And it stores vectors and data together to make that AI implementation easier if you're trying to create your own LLM. And it's got built-in report for RAG, retrieval augmented generation, so that when you're creating your own LLM, It supports it natively. And it also has really good integration with Azure services like AI Foundry and other really popular frameworks, just to make it an easier transition if you're using it.
And talking about being easy, okay, we'll see this in the demos, but easily accessible real-time analytics or metrics, right? And there's a couple of ways that you can do that. And we'll touch on both of those down the track. Database tools to help identify and resolve bottlenecks, okay? So you can still connect to Fabric SQL database just like you would to an on-premise database or an Azure SQL database. But because we've got these tools out of the box available to us, we can quickly see what's going on with our workloads to identify, have we got a problem? Do we need to make a change to a store procedure or something, okay? Optimize the database performance. So behind the scenes, it's turned on, okay? Just like in Azure SQL database, you've got the ability to turn it on or not. This is turned on, right? So it's just done for you. So you create it and it's going to assist you in having that workload run really performant.
The other thing that they're really looking for is, like I said earlier, this is designed for places where there's not a whole lot of DBA support. So the idea is if you've got developers that are working on it and people who don't know a whole lot about how a database works, you make it easy to support it. So there's a lot of different built-in tools to see what's going on with it. Out of the box, you can take a query and you can look at how that query has been executing. So if that query has been executing 100 times, you can look at the average performance so that you can see how much it's generally running. You can see what it's doing now. You can monitor the increased counts of the number of queries that are being executed. You can see in real time which queries are being executed and who's executing them. You also, if you want to, in the giant list of all the queries that are being run, perhaps you want to look at creating favorites and tracking those. Not a problem at all. You can just put a little star next to them. And then the ones you're most interested in can be there at the top. So you can help you in monitoring those ongoing. And then you can look at doing troubleshooting. Maybe it automatically identifies some problems that you may be having, so you don't have to do a whole lot of work in that area. And it finds blocking queries for you and gives you solutions for what you can do with it. It also does auto indexing. We'll talk more about that. And you can make it send you an alert if something's going wrong so that you can immediately address it. And it'll show you what's wrong right there.
So with that, right, so we've got our difference in architecture. Okay, so we do need to understand what this looks like. Now, it's based off of Azure SQL database, okay? It is the same thing. It's just been moved and it's now available inside of Fabric, okay? So what does that mean? Well, it means that our data is seamlessly replicated to OneLake, okay? It's not a copy. So when you create a Fabric SQL database, and when we dive into the demos, we'll be able to see what this looks like. But when we create it, you have a SQL endpoint. Now, I'm not going to jump too far ahead because on the next slide, we've got some changes that we had to have. But we can see here our automatically created semantic model. When we first started playing with Fabric SQL database, this was the case. When you created it, you got your semantic model as well as that SQL endpoint so that you could connect and do whatever you needed. That's recently changed, okay? As of September 5, the semantic model is no longer automatically created for you. And the reason behind that is because Microsoft is sunsetting this behavior so that you want to create a semantic model and that it is not tied with your Fabric SQL database. This means that you're able to create those, manage those semantic models completely separately based on what your reporting requirements are. Okay, so this gives us more flexibility. So if you're like us, where we've already got a database that was created pre-September 5, over the next couple of months, you'll see some changes that this is going to be go from a default semantic model to a regular semantic model, giving you that flexibility, okay? And our compute is separate from our storage. So this means that with a utilization, we're able to work out what that is, track those costs a whole lot nicer.
Yeah, the other thing too is that if you're used to administering a SQL database, the SQL is the security is exactly the same. So you're not going to see any differences in how it performs versus what you would be expecting in any other SQL database. It works the exact same way. So it's got full transaction SQL support. And that's unlike also Lakehouse and Warehouse. Now I know a lot of people are looking to maybe do like a lift and shift. And that's kind of a problem if you're looking at doing a Lakehouse or a Warehouse. I was talking to Connor Cunningham about this a while ago, about some of the differences between what's supported from a full transact SQL perspective in a Lakehouse versus Warehouse, Lakehouse Warehouse versus standard SQL. And I'm like, hey, Connor, any chances cursors are going to be supported anytime soon? And it gave me this look like, no. And he said nothing. The look said it all, and it's not. And so that's not a problem if you're writing good SQL. But let's face it, a lot of times people have stuff that they've got out there. I've got talking to a client right now, and they want to decrease everything they got on-prem. They want to just do a lift and shift, and they're like, "Well, can I just move it to Fabric? It's not that big of a database. Can I just move it there?" And I'm like, "Well, yeah, if you're using the SQL DB." And he's like, "Well, can I use a Lakehouse or Warehouse?" I'm like, "Not with the SQL you've got." Because it wouldn't be supported because they do have some cursors and some recursion going on, other things that aren't supported inside of a Lakehouse. Also small money, other weird things that just, it's not there. SQL DB's got everything. Any roles and permissions you've got going on, they're there as well. Now, one thing that is different too, it only does Entra, which is kind of what you expect from a cloud application. So there's no SQL Server specific IDs that you can use. All the data is automatically encrypted and at rest, and the auditing is automatically enabled. So if you have interested in all that, you're set to go.
Yeah, so the big point that Ginger really called out there is that authentication. Okay, so if you are wanting to move, because you've only got the Entra authentication available to you, if you're doing legacy with SQL logins, you're going to need to do some work to make that be able to be migrated to a Fabric SQL database, which is great from a security point of view. Okay, where can you have it? Okay, when we first started talking about this, we've had some extensions on where you can get it. Okay, and when Ginger and I first started playing together with working on Fabric SQL database, I couldn't actually get a Fabric SQL database, and that was down to what region that your environment was first set up. Okay, so if you're not in one of these regions, okay, the likelihood is you won't see the capability of going create a Fabric SQL database. So make sure you're in one of these regions and you will be good to go. Okay, so, but always come back to this link that you can see up the top. Okay, so Fabric Admin region availability to check, has there been any changes to this where it's supported so that you can deploy this for your workloads. Now, some migration considerations. Unfortunately, with Fabric SQL database, we don't have anything in the migration services. There is no easy way to migrate our Azure SQL database, whether it's a on-premises database, to a Fabric SQL database. Now, you may have heard about this thing called mirroring, where we can go from an Azure SQL database. We've also got support where we can go from Azure SQL Managed Instance, but we can also go from a instance of SQL Server, whether that be on-prem, okay? There's some hoops that you need to jump through, and we're not going to talk about those, but that is not migrating to a Fabric SQL database. It's taking your existing and placing it into Fabric, okay, giving you a database, but it's not migrating. We can't use a backpack. So we can't just go, right, let's create the structure and use a backpack to import. We are limited to 4 terabytes, just the same as we are in an Azure SQL database, okay? But the things that we do need to look at, there are some table level considerations that we need to be aware of if we're going to migrate our databases to a Fabric SQL database, Okay, I'm not going to walk through those, but we've got them here on the screen. Now, the other thing is, if we've got table partitioning, there's some of the DDL operations associated with that we can't do, i.e. we can't do a switch, we can't do a split, we can't do a merge partition, okay? We don't have the partition compression available to us, okay? That last bullet point, check your location that we had on the previous slide as to whether it's been updated and it's available for you, okay? So you will need to think about how you're going to migrate that data, okay? So you might be able to use a Fabric copy job, okay? Or we could create a Fabric Data Factory pipeline to pull that data across into our environment, okay? We do need to take that time and work out what that's going to look like based on our requirements.
Another kind of cool thing is that, you know, there is no patch Tuesday in SQLDB. It's automatically going to be patching for you. What version do you have the latest? And you don't have to deal with that. It's like Managed Instance, but a little bit better when it comes to some of the things that it implements. So the other thing you've got is you've got automatic backups. Again, this is designed for no DBA around. So if you've got no DBA around, you don't want to say, oh no, what's my backup strategy? You don't have to deal with it. As a matter of fact, you can't turn it off. So you get backups whether you want them or not, and you want them. So it's automatically creating those for you. You don't have to worry about it. They're on, and they will automatically give you a full backup as soon as you have created data. After that, you've got incremental every 10 minutes. Excuse me, you've got transaction every 10 minutes. You've got a differential backup every 12 hours and a full every week. So no problem. Your backup strategy is automatically created for you. You're good. What that means that when you're doing that is that if you need to do a point in time restore within 10 minutes, you're back and running. Not a problem. And it does it quickly. And you don't have to worry about the storage that it takes to do that. Because again, that's managed for you and included.
So we talk about at the start of the session around that auto tuning. Okay, so we've got automatic indexing available to us. Okay, so what it's going to do is look at your workloads. Now, this is the same as what you've got available inside of Azure SQL DB. In Azure SQL DB, you can turn it on, turn it off based on what your workloads, what you're wanting to do, how familiar you are with your database environment. Fabric SQL database, it is on. We can't turn it off. Okay, so what's it going to do? Well, it's going to have a look at your workloads and decide, can this workload be improved by turning this index on or creating this index? Okay, it's going to continually look at that to see, is that making a degradation to your performance or not? It may then look at dropping those because it's like, hey, this isn't working. It's not giving you the performance that it needs. But you've got the ability. It's your database, just like anything else. If you know your workloads, you can create your own indexes. The automatic indexing is not going to touch your indexes. It's not going to say, hey, this is a bad index, I'm going to drop it, because it wasn't created by that automatic process. Okay, so we've got to take that into consideration on what that looks like. But what we're able to do is have a look at the tuning options as to what are turned on. And we can see here, we've just got a standard SQL statement where we're pulling data from a DMV, and it's going to give us what does the environment look like? What is it being configured with? Okay, so for our automatic tuning options, we can see what we've got. Force last good plan, it's on. Create an index, drop index, maintain index, they're actually turned off at this level, but as you can see, they're inherited from the server, which means we have no control. So with that, what does that mean from a maintenance features? Well, like Ginger spoke about, we've got those full backups, we've got the differentials. Now the transaction logs every 10 minutes, that's gonna be a little bit dependent on your workloads, okay? If your workloads aren't very frequent, then your transaction logs aren't going to run every 10 minutes because there's no workload to actually run them, okay? We can't change the schedules. We can't disable them. But how easy is it for us to be able to use those? So let's have a look at what a backup looks like in Fabric SQL Database. Now, I've already signed into the Fabric portal, and I've come into a workspace, and yeah, okay, you'll see here that this was Fabric Conference 2025. So that was not in Vienna, just happened, but earlier this year in Vegas. So I've already got a Fabric SQL database. Like I mentioned about the semantic model, it was already created, so I have that for us. Now, when you create a Fabric SQL database, you will just get your database and you will have the endpoint available to you. From your backups, for our database, if we come along and we just go more options, we can come down here, and if we have a look at, first off, just the settings side of it, we can come to our backup retention, and when you decide to play ball, it shows us what's our earliest restore point. And this is based on that retention policy. Now, if you're familiar with with Azure SQL Database, you can go in and you can change your retention policy from 7 days to 35 days. We can't. We have 7 days. That is it. So this is just telling you what you've got available to you. We can't change anything. To do a restore, it is very simple. We literally come down here and we choose Restore Database. We give it a name, and we'll just say FSDB Restore, okay? And what we get to do is then choose. Once again, it's telling us what our restore points are, when we can go back, and we only get to choose what they are. I can actually change it to one previous, but it'll throw an error for us. So if I just go back to yesterday, so there we go, 20th to the 27th, we'll just go back to yesterday, and I will go create. Okay, that's going to go away. There we go. We've started the creation of the database. That's how simple your restore process is. That's just running in the background, but that's how simple your restore process is inside of Fabric SQL. And the create is just like that as well. I'll let that run. We don't need to see it finish. It has started, so we'll come back to the slides.
All right, now this is my favorite feature actually with Azure SQL DB, and I really wish, as somebody who's not a full-on DBA, I really wish that this is the kind of stuff that would be put inside of every SQL database, because it makes it so much easier to figure out what's going on. There's no real thinking required. If you have something going on, those alerts tell you. Notice here we've got in this little screen sample they took, everything's normal. But if the consumption was, at peak, you'd see that as well. So it automatically gives you a status, and you're like, oh, well, I have to worry about this, or do I not have to worry about this? And you see your CPU consumption, not a problem. If you guys see your block queries, that's there. It gives you that high level view of what's going on. And of course you can dive into it. But if you're looking at this and you're like, well, my consumption's normal, I don't have any block queries. I had a peak, as I can see my trend over the last 24 hours, but right now it's pretty low. I'm good. I don't need to go for any further. And there's not really even an equivalent of this inside of any other database. It just gives you that information, again, trying to cater to people who don't have a full-on DBA on staff and they don't know exactly what they're doing. Just look at the little dashboard and see if you have anything to worry about, and everything looks all green, you're good to go.
So like Ginger mentioned, right? So if we are under a massive workload, it'll come up just like this and go, hey, your consumption is currently really, really high, and it'll give you those warnings, etc. Okay, so this makes it nice and easy for us to be able to get to that straight from that Fabric SQL database that we don't have, like Ginger mentioned, on any other environment. That's really cool that that's available to us.
So one of the things as part of this, like I said, you can drill into it. And so if you drill into it and you take a look at the performance dashboard, you can see what's going on, what is going on. Now notice here that the time interval we've got set is the past hour. You can change that. But you can see in the time frame where this was taken that there were some peaks, nothing going on. And then all of a sudden, we incurred some load. And we can see when the load happened, the peaks, the valleys of all that's going on. And look at the bottom there. We've got the ability to see the top CPU performing queries. So if you're wonder why this is wonder what's going on right now, you don't have to worry about wondering. You can see it. You can see the query that is the actual SQL text. You can see the object name, and you can see how much CPU that's taking and the number of at times it's being executed. And of course, all this is sortable. So you can change any of this if you want and see what, how to make it different. And automatically you've got a bird's eye view of what's going on inside of your SQL database whenever this is running. And you can change the intervals so you can look at a wider period of time and dive into the queries that are running as well. It's a really, really cool way. And again, something that I wish all databases had, because this is just a great overall view of what's going on. And you've got those other options at the top. This is just CPU consumption, but this is really powerful information that's going to be really helpful in figuring out what's going on in your environment.
And taking that a little bit further, because we're running a database inside of Fabric, okay? And so where's it residing? Well, it's sitting on your underlying capacity that you may be being shared with other resources that are happening. Well, we can go from the performance monitor dashboard straight in here, okay? We've got to do a setup, okay? But we can create a Fabric Capacity Metrics app. Yes, it's an app. So we've got to go and create it. We can only have one in our environment, okay? We will have a look at what this looks like, but it means that we're able to see what's going on at the capacity level, not just our Fabric SQL database level, okay? So we've got multiple layers that we're able to drill into to have a look at, well, what's our workload happening? Who's a bad actor? Who's got some bad code that is consuming stuff that is just smacking our compute, okay? So we can see down here, that sample demo that I did a restore of in this screenshot, okay? Look at this huge value, 260,000 K with a duration of 83,000 seconds of compute. So this is a really good way to see, well, that's a bad actor. And we're able to go and have a look at and correlate that across the board. Taking our monitoring a little bit further.
Yeah, the one thing too is that, if you're used to taking a look at query DMVs, that you've got all those query DMVs. I mean, they're still there. They're not going anywhere. Nothing new. And they've got all the ones that you would have, and you can look at, what they are. And for a full list, you can take a look at the system managed views for all the documentation. If you are basically anything you've been used to using is there in the future. You definitely want to take a look at this though, because you're still able to use, favorite resources like Glenn queries, diagnostic queries, and you can look at this latest update from the latest of queries available. Just to see, what's going on and use those as well. So if you, again, supports both sides, the people who don't have any database experience, but if you do, nothing's taken away there.
Now, we spoke about migration, okay? One of the things, and we've had to play with this when we first started, development pipelines didn't support Fabric SQL database. That's now supported, which is fantastic. And Ginger and I did testing on this last week. We got together and we did some testing specifically for you, everybody on the call. So it's now supported, which is fantastic. What you do need to think about though, is it only copies the structure only, okay? So when you're migrating from development to stage to production, yes, you can do this with your Fabric SQL database, but it's your structure only. You're going to have a different way of getting that data moved through those environments if you're using development pipelines.
Now, it's funny, I've been doing quite a lot with CI/CD recently, so looking at how this works. One of the things that you can definitely do is you can use all the Git features and functionalities as well. So Do you have to actually move things with development pipelines? No, because you can use Git, but it's not going to give you the data. And actually, that's all kind of on purpose. And the reason being is that just because you've got a structure and you've got your development data, when you move that to, say, Stage, you don't want development data in there. And you certainly don't want your development data when you move to production. So the fact that it doesn't include the data is actually a feature so that you don't screw up production when you're moving changes. You're going to need to figure out what you're going to do with different kinds of data and how you're going to load that. But generally speaking, you're loading it through another process. And so this is a test of that other process, making sure that it runs as well to load the data into SQLDB that you're going to be using for what you've got going on. So if you're looking to just, migrate the changes out because say you've updated, you've added some new tables or maybe a new view or something like that, this is going to provide all of that for you. So looking at this, it's really helpful. And using Git is really, really powerful so that it allows you to also, if you want to create a copy of a workspace, you can copy that with Git so that you've got a total copy of the workspace, which is good because there's really no other way of doing that other than source pipelines. And frankly, sometimes you just want one for another user branch. So it's great that you can do that with Git in Fabric SQL.
Okay. So Ginger, do you want to take us through?
Yeah. Want to go ahead and go to the next slide. So it's really hard to test performance. So we did have to script this so that we made sure that our database was performing badly or performing well enough so that we had some things to look at here. And so looking at what we've got performance summary. Again, all you have to do is click on an icon to find it, which is great. There's no hiding it, makes it easy. Now we can see here, we've got two cores that are being used. We can see the number of user connections, requests, and we can kind of dive into it as well. So, and this is all of the past 24 hours. We can see block queries, allocated size, and then any automatic indexes and how they performed. So diving into that performance, we can see what's going on. And now our time interval here is past 24 hours. Change that to past hours. We can go to past 30 days as well. And here we see the top performing queries. Notice these have got stars. And the stars are things that I want to track over time. So I want to always keep them at the top of the list. Maybe I don't remember which ones they were. So I just flagged them so they show up there top. So if we look, we can look at the CPU consumption and I can look at the user connections to see how many users are connected and what they're doing. I can then take a look at requests per second and taking a look at what's going on from a performance perspective here. And those can be favorited as well. Anything that was blocked, don't have anything blocked. So this is a good database from that perspective. And then the allocated size, giving you an idea of how much capacity that the database is using. And this is really cool. You can see the tables, the number of rows, and the size of each of them. And then automatic indexing, what's going on there, if it has created any kind of index by itself or dropped it. Now going back into the CPU, if I just want to go back and look at my favorites, I can look at the average CPU as well. So taking a look at average CPU, we can see that. And again, I just picked favorites because that's the one I wanted to look at. And if I click on the query ID, I can dive even deeper into it. So taking a look at that, I can see exactly what's run and I can copy that into Visual Studio Code or Management Studio. I can see the number of executions looking at the performance and saw that earlier I did have a performance issue, but it's gone down now. So there's nothing I currently need to work on. So we can see when it has done and I can compare like the past hour to the average. And then, look at the total for the phrases the past hour and see what I've got going on, see when it peaked, maybe correlate that with some other things that are going on. I can open it up in Management Studio and then automatically take a look at this query that was running, using that auto connect feature. Give it a minute here, scroll down to the bottom to where it was. And I can, take a look at my database here. It's loading up my Fabric SQLDB. By the way, it doesn't do the entire warehouse. Your entire workspace, you just get that SQLDB. So I can take a look at all the tables, everything that I have inside of Fabric SQLDB, I can use here. I kind of like this interface a little bit better anyway. So just because I'm more familiar. And I can take a look at that stored procs and then take a look at, what they look like. So I can go ahead and script this out. And this is not a real database. We did this so that we could get some performance. No judging when you take a look at those, because it's not necessarily something you've got going on, but you can just see what's going on with all of these. And all, so if they're using sort procs, fine. If they're using just a straight up query, you can see that as well. Of course, I can look at things that aren't my favorites, and I can see, hey, I had some problems, but it's really dropped recently. And I could copy this script just as query, see what's going on with it. And then I can go back to Management Studio, and then I can go ahead and paste that query and run it. So making just a query here that to take a look at performance, and we can see it's the exact same thing that ran. So if I kind of wonder, well, what am I getting from this data? I can take a look at that. So you can see if perhaps it's written right or not, because to be honest, I'm getting some weird data there. Maybe that query is not the most useful one on the planet. I've got options here for high CPU, and that's what I'm taking a look at here, but I can change that up as well. So taking a look at the past hour, you can kind of see things changing. And then we can take a look at, what's going on to see, how we can take a look at it, and looking at the queries that were going on there, see what they have going, what the query was actually doing inside of SQLDB, in addition to looking at it, of course, inside of Management Studio, kind of the place that I prefer to run, but you can go with either one. So really powerful monitoring tools. I really wish that they were available everywhere. So on that note, let's kind of move on to cost. Warwick, how can we compare this to what we might see in Azure SQLDB?
Well, so as we've got here, back in February, we started to get the cost and the capacity for Fabric SQL database, making it available so that we can actually have a look at what that is. Okay, so because it's sitting on the capacity, we need to understand what does that look like. Okay, so we had to do some digging. In simple terms, one Fabric capacity unit is the equivalent of 0.383 vCores for your Azure SQL database. Okay, so we're wanting to do a comparison between Fabric SQL database, running that, versus you running an Azure SQL database. Given that, what we've shown you so far, in that there is no knobs, no dials, it does all of this stuff for you behind the scenes, making your life easier. Okay, so our demo environment, okay, or our Fabric trial is a F64 SKU. Okay, so that's the equivalent of 24.5 vCores. So this is the comparison that we are having a look at to try and get that understanding. So Ginger, what does that look like between the two?
Well, if you kind of are looking at the two of them, of course, it's still in Fabric. DB is still in preview. That did not change, like everything under the planet, in last week in Vienna. So the preview is really designed for non-production. And Azure SQLDB, of course, you can put in it whatever you want. They both do zone redundant backup storage. The compute with Azure SQL, I don't want to get into all of the intricacies of Azure Compute, but with Fabric, you've got just the compute that you have, which does mean that you're sharing capacity with other things inside of your environment. So keep that in mind. It's considered serverless tier, so that's the same. And if you're using an F64 capacity, that's the equivalent of 25 cores on average. So that's the kind of database you need to compare to. And so you can look at that estimated monthly cost for what it costs for an Azure SQLDB. And inside of Fabric, it's just part of the overall Fabric cost structure. So you're not paying anything extra for it. And oh, by the way, if you want to have more than one Fabric SQLDB, you can. And it's still going to be included in your one monthly bill. Of course, if you create another Azure DB, yeah, you know how that works. You're going to be paying for that each and every one that you have.
That's right. So that comparison, what does it kind of look like? Well, if we come into the portal and we go and create our Azure SQL database, okay, so we're going to choose, we've got 1 terabyte. As we mentioned, with the number of cores to compare against that F64, 24 cores, okay? So average month, about $495 for that, okay? given we're going to have multiple environments, we're going to need multiple databases. So to get that same side of things, potentially we're going to be 3 databases by our $495, giving us just under $1,500 for the month. Okay, this is the type of comparison that you need to look at between your Azure SQL database environment and your Fabric SQL database environment.
Now, one thing to think about with Fabric SQL DB is your storage. That's basically in storage capacity, and compute is the charge for all user-generated and system-generated T-SQL. Kind of a little difference there. The storage is computed by workspace versus all workspace. I mean, really, to break that down, you can just take a look at the performance dashboard to see exactly what's going on. Love that tool. And see how much storage is taking. And if you're looking for compute, well, take a look at the capacity app. And that's going to give you an idea of the amount of capacity that it's using. You want to definitely keep a monitor on capacity, because that's one thing that is a common, let's just say, concern of different resources inside of Fabric is, what do I do if my capacity is getting eaten up by some random developer doing some strange thing? So take a look at capacity to make sure that you're not starving out SQL DB for resources. So taking a look at the different management, of course, with Azure SQL DB, you've got Database Watcher, but I don't think it's the same. I prefer Performance Dashboard because I really think that it's providing you much more detailed information, and you can get it at a really granular level. For the Azure SQL DB, you get the Azure Monitor versus the Capacity app. Okay, I'm liking Azure Monitor a little bit better than Capacity app if we're comparing the two, to be honest. With Azure SQL DB, you can use AutoTune. Serious DBA friends like Warwick can generally turn that off, but you can't do that in Fabric SQL DB. Hey, on the bright side though, if you have turned off, say Azure SQL DB's AutoTune because you didn't like it, it has gotten a lot better. They have improved it. And that's really helpful for the environment that is inside of Fabric, because they're looking at, not DBAs, no DBAs or very little DBA experience. You can add your own indexes too if you want, and they will never be touched. AutoTune will delete indexes that it doesn't use, but if you create them, they're good. Where you got RBAC versus SQL permissions, and in Fabric SQL DB you have the standard Fabric workspace roles, sharing SQL permissions. Again, only Entra, which is the difference. You can't change the database compatibility; it's fixed, which of course is different than SQL DB. And you don't get auditing inside of Fabric. That's not available. But the storage encryption is built in, so that is something else again.
Okay, so with the just in the interest of time, we won't go into the Fabric app, but we did in the slides. Okay, we did cover it. Just to quickly show it though, we can come into the Fabric portal. There's our performance dashboard. Here's our Fabric app that we were looking at and Ginger spoke through against the slides, and we just took some screenshots here. But this is actually live, okay? And you're able to jump around. You've got a lot of information that you've got. Once again, here's that bad actor, that sample database that we're running against, okay? We get the tooltips, gives us some fantastic information to jump into looking at the capacity side of things. So just so that we stay on target with our timing, some of the other considerations that we need to think about, okay? As we've mentioned, it's still in preview, okay? Like anything in preview, features may change, okay? So if you put this into production right now, it could change and break things for you. So just be mindful, great to play with and get it ready for when it does become available and goes GA, okay? Don't put it in those production workloads. How are you going to reserve your capacity? That's the other thing, right? So you need to have a look at what other things are you running in that workspace on that particular capacity. Are you going to cause problems with your Fabric SQL database, okay? not the same sort of setup as your Azure SQL database. Okay, so you need to look at those workloads. And the cost of the SQL database, it depends on your usage as opposed to that flat rate, which is what you're getting in an Azure SQL database. So with that, I think we've hit time, which is fantastic. So this is who we are. We've got our contact details. We've got LinkedIn. So if you want to connect with Ginger and I, feel free to use those QR codes. Ginger, is your green fabric one still working?
Yes, it is. And so if you take a look at that QR code and you are set it up, it gives you access to a free fabric class in LinkedIn. So take advantage of that. It is time boxed, but you can take the class for free with that QR code. So please take advantage of that and give yourself some more free fabric training.
So I'm just having a look at the comments. Okay, so if there are any questions, feel free. You can put them in the chat. But yeah, look, we don't want to overrun for. Oh, hang on, Charlie's saying we've got 15 minutes left. Charlie, why did I look at it and it was only 15 minutes? 45 minutes. That's okay. We can go back. We can fill that.
Exactly.
We will just come back in here to the Capacity app because we didn't spend a whole lot of time in the Capacity app, right? And so this is going that combined the Capacity app like we had it recorded, but we wanted to show some real time. If we go to the performance dashboard, so this was us running some workloads today in prep. Okay, and we can see those bigger spikes, and like Ginger mentioned, we've got the past 24 hours. Okay, now it's pretty difficult to on a single stored proc to get the core count utilization up close to that 24. I have actually flatlined it at 24, and you get a raft of red alerts. So the red dots are going, hey, you're overutilizing your performance. Okay, but if we quickly dive in and like we did in the recording session, we go to that past hour, we're able to see, there we go, just move it out of the way. We can see what that workload looked like. Okay, Ginger walked through all of this to have a look at, well, what are the statements that we are running? Well, this is where combining this with the Capacity app really makes your life a whole lot easier, okay? Because we can come in and go, what are the queries that we're wanting to have a look at? Why is that not showing for, because it's outside the past hour. So if I go past 12 hours, then we start to see what are the workloads. Now, this is contrived because I wanted to know exactly what they are. So I wrote some really bad stored procedures to go and run against our Fabric database to get that utilization happening. But as you can see, yes, high CPU workload. So I know this is going to absolutely smack our CPU. And you can see how much time of CPU on that capacity this one statement has run. How many executions? Very little. So this is a really bad actor that you want to dive in and have a look at, compared to if we have a look at, here's our general workload. Well, 1,800, very little. But look at this, 46,000 executions for that really small workload. Are we really interested in that? Maybe. We definitely want to have a look at this one because that's going to impact when we're running other databases on our capacity. Okay, so we can take this one and we can then go, okay, well, what's our overall utilization on our Capacity app? Now, as we mentioned, you've got to go and install it. You can only have one. You've got to then have your administrator set that up, give you permissions to gain access to it. Okay.
You know, one other thing that I noticed on this too, because I had a client and I had accessed the Fabric app and then it went away. The reason why it went away is because I did not have a Power BI license. I had a trial, and when my trial expired, I couldn't look at this anymore. So if you don't have a Power BI license and you're using Fabric, you can't see the app. So if you are working someplace and they say, "Oh, you don't need a Power BI license, do you?" You're like, "Oh yeah, I do," because I need to be able to monitor the content in the capacity app. So keep that in mind. I didn't realize that until recently because I always just have it all, but you do need Power BI.
But the beauty of it, right, is once you've got this set up and you're able to go and have a look at the underlying side of things, it's what's running on your capacity, right? So when we come down here and we scroll, look at all these other things, and it's telling us what type of items they are. Oops, I'll just keep the mouse off so we can see. But we can see, hey, we've got a lake house, or we've actually got a couple of lake houses in place. And where are they? Well, we've got a staging, a data flow. We've got some bronze. We've got some data flows in there. What else have we got? We've got that demo. We've got some pipelines, some notebooks, etc. Okay, so this is where you get to see all of those because they're on that capacity, which they could have, like we mentioned. How are we able to, stop something else consuming all of the resources that our database was needing? So if we come back here to the performance monitor and we come back to our graph, so if we come back to our dashboard and where we saw these graphs, right? If this was our regular utilization that we needed for our Fabric SQL database to be running, okay? And we're going, why aren't we getting it? It's running slow. That's where with the capacity app, we could see we haven't got it because we've explicitly been targeting the database, but we would be able to explicitly see in here which one of these items running on that capacity is consuming all of that capacity, therefore impacting our database. Same as if you've got those multiple databases, how are they going and interacting or competing with each other? We don't have any throttling occurring in our environment, but you're able to go and see what that looks like. If you wanted to change and not be on your CPU, we've got our duration that we're able to go and have a look at. We can go to our operations. So what are we running in the environment for us to be able to look at? Okay, it does take a little bit of time. What we did do is that I didn't have this running like the really bad procs running in the background right now, because then that has an impact on the reports on what they are generating and giving you. Okay, so which is great. If you're running it in your production environment and it's slightly delayed, then you're going to be able to look at that and go, this is where we need to target.
And this is a really good way of taking into consideration your entire environment, because there is no way of reserving any kind of capacity. What I've been telling a lot of clients recently is you probably want to do a split capacity. It used to be people didn't want to do a split capacity because then they lost out on Copilot functionality because that was only available on an F64, but that's not the case. So if you've got the budget for an F64, split it up, and then you can have the different capacities dedicated to different environments. That's going to keep you running, not having to worry so much about people like me who play around with Spark and run out of capacity in production, which I did do that. But if you've got split capacity, then you can dedicate to production. You don't have to worry about it. And that's something that more and more people are doing, and which is why you'll notice that this has got a capacity name, so that if you have multiple capacities, you can see what's going on in each of them. Because Microsoft is anticipating that a lot of people are going to go with this multiple capacity model when they are looking at Fabric. So keep that in mind as well.
And if you've got access, and this is where you can really get caught out, but if you've got access to multiple, like Ginger was saying with your capacities, right? So we've got our drop down. I've only got one, but it can get you into trouble when you try and come in here and you're like, why isn't this showing me what I was looking for? So yes, and I've got 12 days left on my trial, so hopefully next week it rolls over again for us. So that's all good.
One thing also I wanted to bring up, because I have a client now and they are to economize their SKU cost, they do turn it off when they're not using it. And yeah, if your Fabric capacity is not running, that will impact your data, your backups. And I just wanted to bring that up as well. So if you are playing around with, oh, well, I turned that off because we're not using it, it will impact the number of backups that you receive as well. So, which is kind of what you would think. And you don't really need to back it up when it's not on anyway. So that's not really a problem, but just keep that in mind if you're looking at why you see weird counts, but you may not have had the capacity on at that time.
Okay, so we'll come back here. We'll keep this up. We've got a couple of minutes left. So happy to take any questions on anything that we've covered off today in the session. I'd like to say thank you to Charlie for having us, and thank everybody for coming along and joining us for today's Data Bash.
It was great having you on.
We had 15 minutes.
Yeah, we do have a few minutes. So thank you very much, Ginger and Warwick. Definitely great having the differentiation between what's happening between Azure SQL and also SQL in Fabric, Azure SQL DB in Fabric. Very, very good tooling as well in there. So a lot of very good information that we're going to be able to take away. A reminder that, as you can see at the bottom of the screen there, there's a form you can fill out to give our wonderful speakers some feedback. Also feedback for the live conference itself. I would recommend that you also come back to our YouTube channel, because all these sessions are recorded and they're going to be posted individually to our YouTube channel. Warwick and Ginger will let you know as well when that happens, so that you can also post and let everyone know when that's aboard. But definitely take a look at the individual websites and LinkedIn profiles for Warwick and Ginger. They're doing some great work, both of them, all the time, when it's focused on SQL and on Fabric as well, which is unusual to have such a good cross-platform capability. So definitely thank you very, very much. And we are about to go into the next session. So what I'll do is I'll take this one off the screen and back onto here so that we can see what is on next. And right now we're getting ready to prepare to welcome Edward Pollock to the screen, where we were going to be talking very soon about T-SQL features in SQL Server 2025. I'll just quickly add Edward to the screen there. Hello. We'll have a hello wave and a goodbye wave, I guess, at the same time. So thank you very much, Ginger and Warwick, and we'll talk to you again soon.
Hey, for those of you who are attending Data Bash and you, I'd love to be able to see you in person. And I am with Charlie. I'm going to be in Switzerland for the conference there in October. So check out your calendars and see if you can make that. It'd be lovely to see you in person.
Great plug there. Yes, Data Conference Switzerland in Zurich, happening on the 22nd of October. Definitely worthwhile coming to. Thanks, Ginger, for the reminder.
Absolutely.
There. I want to go to Zurich now. It's a good idea.
I recommend.
I'll
let you know how it is.
Beautiful.
All right. So let's go and focus a little bit more now on Edward. Hello, Edward, and thank you very much for joining.
Hi, happy to be here.
Screen shared. I think it might be possibly the wrong screen. Let's try that.
It is
shared. A lot of stuff on this, so let's make sure.
Well, and you can't see right now?
I can see a screen with.
Sorry. Yeah, you're seeing that. Let's. Do you see a presentation now? And
now I can see a presentation. Excellent.
Do you see some SQL?
Yep, it's gone off now. I think you need to. Oh, yeah, it's right there. Perfect. Right. So I will then come back here.
I think we're good. You can hear me. You can see me. Everything seems to be working the way it should be working.
And you can feel free to start. Thank you very much for joining, Edward. And let us know.
Excellent. Thanks for having me. This is you get the pleasure of a brand new presentation, because SQL Server 2025 is now, in RC status. It's almost ready to come out one of these days soon, so we can actually talk about it and see all the new things that are in it. So thank you very much for having me. I love having fun. So this should be great. Something new, lots of demos to mess up along the way. So let's get right into it. This is me. I'm Ed Pollock. I'm a Microsoft Data Platform MVP. I do a whole lot in the data space. I have a upcoming second edition of my Column Store book, writing all the time, speaking, sharing, having a lot of fun organized events. So I'm from Eastern US, from New York, in case anybody ever is out that way. But I'll be out that way occasionally too. So hopefully we all run into each other and have a good time. This is really a straightforward presentation. It may not even take an hour. And if not, we'll have time for a few questions, which is great. I don't know if there are questions. I don't think there are, actually, but you can always find me later and ask. That's always great. So really, very quick review of how new features work, compatibility levels, versions, and how SQL Server has been handling new features for about 9 years now. And then we're going to demo all of it, because demos are awesome, they're fun, they're risky. And then we'll have a wrap up at the end, and that's it. So very straightforward. I'm currently using SQL Server 2025 RC0. I do know that RC1 just came out. There are no major differences, though, between what I'm presenting here and what would happen if I upgraded right now. And I will not upgrade right now because that's a very bad idea. So dive right into it. New features. Every version of SQL Server has new stuff, right? New features, new T-SQL changes, enhancements, performance-related stuff, intelligent query processing, and sometimes they sneak it into minor releases too. They'll poke into like a, just a random cumulative update. Here, have some cool new stuff. If you're on Azure SQL Database, you're already getting this, which is great for you. But even though you're already getting it, it's very easy to miss new features. They come in, you hear about the big stuff, right? It's 2025. It has AI-ready capabilities and all this new vector search and amazing stuff. And you hear about the top like 3 new features, but there's actually a lot of new T-SQL that came in with this version. Some is big, but also some are kind of subtle, little things that I just kind of appreciate them adding in. And so we're going to dive through a lot of it, not all of it, but a lot. And hopefully it's helpful. Hopefully a couple of these things you say, hey, I didn't know about that. That's really cool. One note, though, before we begin on compatibility level. The primary purpose of compatibility level is to guide upgrades and make them easier. They're meant to guide performance primarily. So if you're in compatibility level 2017, for example, then your SQL Server is going to behave performance-wise kind of like 2017. If you change it up to 2019, 2022, 2025, then it will behave performance-wise like those versions. Most features are not gated by compatibility level, and the ones that are usually performance-related. A lot of IQP features, intelligent query processing, gets tied to it because it's very performance-tune related. But otherwise, most T-SQL is just available. Not all, but most. Just worth noting it. And I will just demo too how this works. So I'm just in random database. I set my compatibility level back to 170, which is 2025, the new compatibility level. Yay. I go in and I use some new syntax like, hey, give me the product of a tax rate in a table and do some cool math for me. And then I can go back and I can bring down my compatibility level to a bunch of versions ago, long before product ever existed. And then I can go ahead and I can run this again and it still works. Same result, of course. And then I can put things back. So it's really just a very quick note on compatibility level that its purpose is not to gatekeep features. It's not meant to keep you out of the new stuff. Yeah, it's really just meant to be there to handle performance so you can upgrade smoothly and not break stuff when you jump versions. And again, if you're in Azure SQL Database, this matters there too, potentially. But getting all the latest and greatest is nice. And not having an upgrade for it is also nice. So with that, let's jump right in. I already mentioned this one. This is probably honestly one of the coolest new ones that I like because I love SQL that's usable everywhere. And product is one of those things. Product is just an aggregate function, just like sum, min, count, whatever, except that instead of adding all of the values for a column in a range, it multiplies them. And at first you may ask, why would I ever want to do that? It just sounds like I'm going to get some big numeric round error message when I overflow and enter something. But it's used a lot in stats. It's used a lot in metrics. And if you do any financial calculations, especially like interest, things like that, if you're working in the financial sector, this will come in handy for you. And it will make your SQL smaller. And I will show you how it'll make your SQL smaller. Lots of demo today, by the way. Did I mention lots of demo? I love demo. So let's create a table here. We're just going to call this table bank balance. This is a very simple table. I want to keep it straightforward. I also want to select the right text. I'm just going to put some rows in. This is just a bunch of months worth of interest data. I have a starting amount, ending amount, and then the interest rate annualized for that period. Simple so far. You get a bank statement in the mail. It tells you how much money you have, right? And there's our data. We'll push this up a little bit. Great. So now, if I wanted to calculate interest over a period of time in interest rate prior to 2025, how would I do it? And the answer is there's a couple ways to do it. The simplest way is you iterate. You do it one by one, month by month, just like this. And it works. You get a result. I see my annualized interest rate for 2024 is about 4.34%. Cool. But iteration, as we know, is slow. In my little demo here, it's fast. But if you're working in a big database with lots of rows and lots of, just big data, it's going to be slow and it's going to perform poorly. And if people run this code all the time, you're going to feel it. And so iteration is not really an ideal solution for something being run all the time in a transactional application. There are step-based approaches based on math. For example, we can do something like this to get the result, or something like this to get the result. And yes, there is math behind this. You can read all about it. How do you calculate an annual interest rate, annualized interest rate, or interest in general? And you can read all about the formulas behind it. This isn't a math lesson today, but this is how I would have used to do it. Now, if you were any kind of developer and you saw this code, you would just say, that looks genius. I'm sure it works. I will ignore it because it's complicated and it's very hard to understand what it does. I know what I want to do here. I want to get an annual interest rate. So in 2025, all we have to do is use product. And this is a lot simpler now. 1 plus the interest rate over 12 done. That makes sense. I see that and I understand what I'm doing. And I run that and I get my result. And there are differences, by the way, here. You may be noticing some of the round offs are a little different. And that's all just due to I didn't cast anything as a decimal, whatever. I'm just kind of letting it do all the rounding for me. That's the only reason that's happening here. If you added it, if you were displaying this into an application, you'd tell it, give me a decimal 18.2 or something, you get what you want, or 6.4, whatever you need. You can also use product as a window function. So what it did here is it multiplied every value for all 12 of these rows to get my interest rate. 1 plus annual interest rate over 12, and I did it 12 times and multiplied them all. You can also use product as a window function, which can be kind of cool too. I can get a running interest rate over time for each month. And I can see that my interest rate is going down, it's going back up again, going back down. And this is pretty cool. And I can use, the necessary syntax to get what I want. Between unbounded preceding and current row ensures I'm getting a running total up to my current row. So product can be used just like any other aggregate function over a set as a window function. It's up to you. And we'll drop that and return to the presentation. That's our first one. There's a lot more though. This is just the beginning. They added regex. This is actually really cool, and people have been asking for this for a long time in SQL Server, just in general, is where's the real regex? If I have to compare strings, I've got to use like or not like, or something like or not like that. Haha, I'm funny, right? But there was no native support. You couldn't actually do regex. You had to basically hack it and force it to work, and it never did what you wanted it to do, and it was glitchy. Finally, after I don't even know how many years, they've added regex, native regex to SQL Server. And so you can use regex just like you would anywhere else here. Every regex pattern is supported. It's native regex. You can do whatever you want. A small number of them require compatibility level 170. Most do not. So think about all the code you've written over the years to do regex and how ugly it is and how messy it is and how it didn't quite work the way you wanted it to work. Now we have it. And this is why I have a lot of demos for this one because it's big. If you do any kind of string comparisons in SQL Server, this requires a lot of demo because this has never existed before and it's always been a hassle. The addition of regex is wonderful. So I'm going to go through function by function, all of them. It's worth it. It's worth 10 minutes because this is really huge. A lot of people are going to use this because regex is used everywhere. It really is. So first function is regexp like. This basically just asks, is a regex pattern found or not? And there's lots of ways to write these queries. If you don't like the ways that I write them, you can write them your way. This is really just for demo purposes to show how it works. So I'm going to select from the table. I'm going to do it only when I find a specific pattern inside of it. And this pattern here is looking for NY with the parenthesis afterwards. So I'm clearly trying to pull out anybody from New York here. That's where I'm from. Cool. Though I'm not in New York right now. I'm actually in Massachusetts. I'm actually at SQL Saturday Boston. I'll be speaking twice later today. So this is a fun day for me. I'll be really tired later. But for right now, you get me first thing in the morning. So you're very lucky. You can do really any kind of regex pattern you want here. I can go in and do something like this, which will give me ones that where the contact begins in a capital A, ends in a lowercase a. Yeah, this is kind of silly, but you can do it. Again, this is regex, and I want to show that any regex is supported. And again, this is only going to return the rows where it matches. I can get a little sillier and say, give me all the strings that return the letter S twice consecutively. Again, this is just regex. It looks complicated, but you can look it all up. There's guides all over the internet in regex if you need to review for any reason. This is very, very well hashed out knowledge. And this tells me all of the ones that have a double S in the customer name, and I can see that right here. So I can check very easily if it is there, or I can just put it in the select and return a 1 or a 0, whatever works. Again, this is just a function. You may notice it's not pink yet. It's new, so SSMS, I don't have the newest version here probably. It doesn't have it all nice and highlighted yet. Similar is regexp count. This returns the number of times a string is found, with a pattern is found within a string. I'm going to go back to my example a second ago of all those cases where a city has the letter S twice in a row. I'm going to run this. It's going to tell me how many times is that sequence found anywhere it exists. So I'm only grabbing the rows where it has double S, and it's telling me how many times it's there. So for a very small number here, like Mississippi or possession, it has it twice. Otherwise, it has it once. Hey, Rensselaer, I live really close to there. That's funny. I scrolled right to that out of all these rows. That is crazy. I need to get rid of, where's my taskbar there? I don't know. Anyway, now you can see a little better. What else can we do? I can add a parameter to tell it what character to begin with. So this searches through and searches the entire string and tells me how many times the pattern was there. If I add the extra parameter here, 6, it will tell me where to start at. So don't start until character 6 and then begin searching. And if I do that, I get less rows back, well, a little bit less back, but I don't get the ones that had 2 S's because I started character 6. So anywhere the double S's were before character 6, they're not there. I can also go in and I can grab all the ones that are new followed by a space. Again, I'm just having some fun here with regex. I really couldn't do this before easily. It was a hassle. And now it is very precise in what it does. You can see I got all the cities that begin with the word new. There's like 1,000 of them. Cool. So that's regexp count. Just finds the pattern and tells you how many times it is in the string, anywhere from 0 to whatever. Now, regexp instr. This will give you some more information, which is really useful. For example, let me go back and just find all the strings that have new in them. Let's keep this simple. And this tells me the location, which is kind of cool. The start location or the end location, you specify which. If you default start. So if I just go ahead and run this, it's telling me, oh, in this word, Newville, it begins at character 1. In South New Berlin, it begins at character 7. So again, you can see the parallels between these functions and existing ones, pat index, char index, like, not like, things you've used in the past. This does all that same kind of functionality, but with regex. And in many cases, this is actually better. And you may want to replace a lot of your existing code, if it's convenient, with this because it is more precise, it's simpler, there's less code involved, and it's really nice. I can go ahead and, again, use that extra parameter here to tell me what character to begin searching with. And so I'm going to look for new, but only starting in character 2. So all the ones that begin in new aren't going to come up anymore. If I do that, I can see that South New Berlin, North Newton, East Newark, things like that come up. So again, very straightforward, very helpful. There's a third parameter you can use too, which asks me which occurrence to locate. Because we're finding the starting location for a string. Therefore, there could be value in finding out the second or third location intentionally. So let's say I want to find new, but not the first occurrence of it, the second occurrence, and give me the character for that. There it is. So the only ones that have new later on, and it's a second occurrence, are Newport News. That's the only one actually, has the word new twice in it. And I'm grabbing the second one. It begins at character location 9. There's one final parameter in this one that tells you to return the start or ending position, because there are a lot of times I can think of in code where I've wanted the second, the end of the character string. Give me the end of it, the ending location for that pattern. And normally do that, it's annoying. I have to like get the length of the string, find the char index, get the length of the string fragment, subtract it, and do a bunch of stuff, and or add it, however you want to do it. I don't want to do that. You don't want to do that. That code is disgusting. This code is simpler. So this just simply says, give me all the cases where I have the word new twice. For the second occurrence, I want to know the ending string location, and that's character 12. Woo! That's pretty cool. And we can have fun. We can get really silly and fun. And again, regex can get wild, right? I can go ahead and run something like this and give me the starting position for any city where the second word starts with N and is followed by a lowercase w later in the string. And I did have these flags too. I'm going to not mention them too much. There's a couple of additional flags you can add in as well that can make it, case sensitive, case insensitive, things like that. In this case, makes it case insensitive. But I got silly here for fun just to show that whatever regex you can dream up, you can use it here just like you always have used elsewhere in other apps. It's now in SQL Server, and it works. Regex replace, it's just like replace, except that it's for regex. So go in and replace new with old. You can do something like that. There we go. Newville becomes Oldville. Haha, haha. That was fun. Or I can go start a character 5 and replace new or old with mid, because now I'm just being silly. I can do that, and now it goes and it'll find any occurrence of new or old and change to mid. So it didn't matter what it was. So I can use the or operator in regex, and it'll let me switch between anything and have multiple strings to match. And I can go further and just get more and more complicated here. Only start at the second character and then replace. Do it case insensitive, so I maintain my new at the beginning, but I do change the one later on. And again, this is starting to look a little silly, but I just wanted to show that this really does work for all regex. It really, really does. Regexp sub str, that returns basically a pattern substring, and that's it. So think substring from the good old days of strings. It does that. So here I'm trying to pull out the contents of parentheses. This is the sort of thing people do a lot, right? I want to grab the contents of brackets or a chunk of JSON or whatever, and I just want to grab a hunk of string between two characters. This thing I wrote here, happy to copy it. I'll send this all out tomorrow. Feel free to just steal my code, but let's look at everything between parentheses. Common use case for regex is pulling out the contents of a section of a string. You can get prefixes doing this as well. I can get a substring and just grab a letter code at the beginning of some reference number, right? Some reference number has letters in front, maybe, numbers, and this just pulls out the code. To notice if it's not found, it returns null. These functions behave based on ANSI standards, very similar to the existing string functions you already know. If you send in null, you get out null. And if something isn't found, you get null back. If a count of something is not found, it'll return 0. So counts give you 0, otherwise you get nulls. It's kind of expected behavior. I can also get rid of the nulls as well by just kind of adjusting slightly in there and putting from a plus to the multiply, the asterisk, and then I can get back a space instead. So you don't have to return null if you don't want it, so you don't have to go is nulling the world away. The regex already has ways of dealing with that. Can also use regexp matches. This one is kind of fun. I run this one with my double S's from earlier, and this returns a bunch of information. This is kind of cool. So regexp matches is basically returns a table with metadata about what you're searching for. And so you notice I'm only returning 3 columns, city, key, city, and state. This function returns Which match ID is it? It gives me a unique key for each match, the start position, the end position, the value match, plus a little bit of JSON over here that I can use that describes this metadata. And so if you want to get a whole bunch of information back about a regex match, this is wonderful. This gives you back a ton of information automatically without you doing anything. And that's pretty nice. So if you need lots of information, this does it all for you, so you don't have to do it. You don't have to return 4 different columns worth of stuff. Or if you want to port this over to a different app, the results, it gives you a nice little JSON object you can just go ahead and use. Done. So this is useful. It may be more information than you need, but if you need the more information, here it is. And you don't have to return every column. I return star here. You can pick the column names out of it: match ID, start position, end position, match value, or substring matches. It's very much like string split, where you just get your bonus information back. Split to table is just like string split. Same. Remember, string split was added not too long ago, and now you have string split for regex. And so I say here, split this up, take the string, split it up by spaces. And so I get one row with an ordinal attached. Again, the ordinal is beautiful. I have a little PK in here, and I get each word out. Split to table is kind of cool. I could similarly split up my cities from earlier if I want to have fun and create a separate string for each fragment of it, just like this. I'm removing the SS, of course. Remember, string split takes out the split character. It's very often really going to be a comma or a semicolon or something like that, maybe. But it could be a space. It could be something weirder. And I just had some fun here and split things up here in strings. You can try it. Is one thing you can't do by default. Just like string split, you can't split on more than one character. I tried to split here on the classic quote, comma, space, quote. It gives me an error message because it's just like string split. I can go to regexp split to table and do it. And it does work for split to table. So string split doesn't work. Split to table works almost. I do have the leading and trailing characters. It's a classic problem when you're splitting stuff, right? But I can filter it out and get rid of it. So regexp split to table is just like string split. You can put in whatever you want, and it will split on the regex pattern. Just keep in mind that it removes the regex pattern, just like string split. If you split on commas, the commas get taken out. It's the same here. If you split on any kind of string pattern, it's going to remove that string pattern. There are some flags. I just mentioned them here for fun. I'll just run through them fast and then go back to the presentation and move on. This is not a regex presentation, but it's worth spending 10 minutes on it because this is really useful. I is case insensitive. You put it in and everything it does will be case insensitive, meaning caps, lowercase don't matter. That's not the default. Regex itself, not in SQL Server, is case sensitive. So the default's case sensitive. If you want it to be case sensitive explicitly, you can put this in. This is not based on your correlation. Regex is not based on your correlation. It operates separately. Just keep that in mind. Multi-line versus new line character matching modes. They're just how are different characters handled. I'm not really going to jump into it right now. Let's go on back. All right, so I mentioned a lot of stuff on regex because this is new, and for anybody that works with strings, this is going to make your life a lot easier. So if you have code out there already, this will help you simplify it. If you need to write code with regex, it's in SQL Server now. Yay, thank you, Microsoft, for adding this. I appreciate it. I don't have a demo for this one, but it's worth mentioning it because it's a biggie. If you're an administrator out there and you work with SQL servers and you're watching TempDB space as part of your monitoring and alerting, you can manage TempDB data space using Resource Governor now. We've been asking for this since the beginning of time, since TempDB was a thought, an idea. We've been asking for a way to manage it in SQL Server, and now you can, and it's actually easy. Resource Governor is not necessarily simple, but how you manage it for this is. Because it's really just one thing, right? It's just TempDB and it's data space. And so basically you create your workload groups, you create your resource pools, you do all the stuff you do for Resource Governor. Once you're done and everything's the way you want it, you simply use one of these two pieces of SQL. One sets a max TempDB data megabyte for a workload group. You set an amount, and if queries in that workload group exceed the amount, they get killed. and tempdb is saved. Or you can do a percent. That was added in one of the last preview versions before they went. It may have even been RC0 it was added, but they added percent near the end. And so you can set a percent as well and say, hey, if any queries in this workload group exceed 50% of the max tempdb data space, kill it. This is a lot of the stuff that we tried to code in our own, and I know from personal experience that trying to manage tempdb can be hard. Having automated processes that monitor it and check for free space, and when it gets low, do things, that's hard. This is not as complicated as Resource Governor can be, and so I highly recommend if you're somebody who manages tempdb, you're an administrator, an engineer, a DevOps person, you're working in SQL Server, and you deal with this stuff, check it out. Trust me, this really makes your life a lot easier. And if you've written code to do this stuff before, this is a lot simpler. There's a lot of documentation on it as well. So if you're wondering about the caveats, if you're ready to raise your hand and ask 100 questions, they're probably already answered. I kept this simple here. I'm not going to demo Resource Governor. That's a pretty involved demo, but it is worth mentioning that you can now do Resource Governor for tempdb. Woohoo! Another big new add in 2025, along with all the AI stuff, are vector functions. But it's worth mentioning that when vectors are added to SQL Server here, this isn't just for AI. These are actual vectors, the vectors you learned in math class years ago, the vectors you may use in stats or calculus or computational analysis. And so you're probably going to use them for AI applications, for vector embeddings, but there's a lot of uses for these. And this is native support for vectors with a whole bunch of functions. So let's dive right into the demos because I love demos. I'm going to create a demo table here called books. I'm going to create a vector index in here using the cosine method. It actually supports 3 different methods for finding vector calculations. There's the dot, the cosine, and then Euclidean. And I'm just going to create a vector index here. You don't have to create a vector index for most of this. I think one feature at the end you do need it for. I'm going to put some data in here. These are not exact vectorizations. What? This is really an example of what happens when you do live demos for the first time. And I did test this, by the way, and I added the vector index in later. So this is now in video for everyone to see forever that I made a mistake. Woohoo! But that's okay. We're all human, right? Okay, let's create our table again. And now I'll do it the right way. I will put my data in. There's my books. I will add my vector index. Great. Now let's go into the demos. So I'm going to go through a bunch of new functions that exist here. I'm not going to use the table for all of them, but I will use them for some of them. Vector distance is probably the most straightforward function and probably the one you will use the most. It calculates the similarity of 2 vectors. You choose the algorithm. It calculates the distance. The bigger the distance, the less similar they are. And this is at its core how you go checking to see are things similar or not for AI purposes. You want to see are vector embeddings similar or not. Here's how you do it. You're writing your code to figure out how similar things are. You're going to order results based on distance, very common usage. Here we go. So I just have 2 vectors here, and I'm going to go ahead and just show how this works. You go ahead and just calculate the vector distance. You tell it what to use. Most algorithms you're using probably use cosine, but you may use the other ones as well for other purposes. If you want to learn how these work, feel free to go on and search for it. There's lots of articles and the math behind these and how it works. The Euclidean is probably the one you kind of ran into in math class years ago. You may have run into other ones as well, depending on how much math you've done in life. If you've done a lot of math in life, you may have encountered all of these. If you've not, no problem. And so you'll notice the distances are completely different because using different algorithms used for different purposes. If I go ahead and I find the vector distance, just testing myself here, by the way. If I do the same vector and I find the distance between it, I get 0. They're the same, no distance, identical. If I were to go ahead and say, go to my table books and get the distance between the book title and The Hobbit, I can go ahead and do that. And so I'm searching for a book. I put in Hobbit. I didn't put the whole title in. I put Hobbit in. I can see that The Hobbit comes up first because that has the closest vector embedding to Hobbit, The Hobbit. It's almost the same. Great. And it does all the calculations for you here. And I can see that the least similar to the Hobbit is the Old Man in the Sea. I don't know why, but hey, that's what happened here. So vector distance is very straightforward. It gives you the distance between two vectors, which is used for similarity. I can order by that cosine vector distance, and now I can have the top one come up. So if I'm recommending books to somebody, I can now do that right through SQL without having to return all this data to the app first. And that really is the convenience behind this, by the way, is that I can work on the data here and return to an application what it needs, as opposed to here's 100,000 books, all the vector embeddings, you figure it out. Or here's 100,000 books and their vectors, figure it out. Apps don't really enjoy doing that. Vector search takes that existing functionality of vector distance and it returns more. It actually expands on it. So let's say I have a sample book title and a sample vector. I basically can search now. So I'm going in and I'm saying search the table books. This is a table valued function. And then search this column. I have a sample vector coming in, right? This is the one I'm passing in from my application maybe. And then I want to do cosine similarity and then go. So this is one of those, let me select everything. There it is. And so I'm going in and I'm saying, give me the top 3 rows from this table, this column, using the cosine method, where the vector embedding is most similar to my search string here. And by the way, this vector is just for Hobbit in this case. And so it returns top 3, The Hobbit, The Great Gatsby, and Lord of the Flies. I don't have a lot of books here, so similarity, I have 1 very similar and then 2 not so similar. But there we go. This is great. If you want to search a table for stuff, this will do all the work for you. So you don't have to go writing crazy where clauses and tops and fetch next, whatever, only, blah, 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 blah. You give this function how many and what, and it will return it for you. Really, really nice. Back to math. That was getting a little bit away from math. We're going to talk about math some more now. Vector norm returns the norm of the vector. It's just math. It's stats. If you know how to do this stuff in math or you need it, it's there for you. If you don't, we'll be away from this in like 20 seconds. There's 3 different calculations for norm based on what you're doing. The kind of infinity norm, norm IMF, is the one you probably is most familiar to you, where you do a calculation you can actually do by hand. The other ones are more complicated. But again, this is just math here. If you have any need to do vector math, it's supported. If you don't, let's keep scrolling. Vector normalized might be useful to you. This is essentially a scenario where it takes one of the sides of a vector and scales it to 1. So it scales the norm to 1. I'm trying to explain something early in the morning here. It's going to basically scale the norm to 1 and then take the vector components and adjust them. So it's not changing the proportions of the vector. It's changing the magnitude for you. So if I go into here, and again, if you need this, it's here for you. If you don't need it, we'll keep scrolling shortly. This goes in here and you can calculate the norm, which I have here. And then I can normalize it here. And just to prove that it works, I can do the norm of the normalized, and I should get 1. And you'll note it's not quite 1 because these results are all floats. All this AI stuff runs on floats, the vector math, which actually makes sense. It should be a float for these purposes because the calculations are complicated. If you don't want to get back the oddball rounding, you're more than welcome to cast or convert to whatever you want and get back what you want. And if you rounded it, you'd obviously get 1 for all of these. There's no question there. So there's no real issues with rounding here. Just keep in mind that if you reuse a lot of math here, you may eventually see the impact of rounding because we're working with floats. And you can specify now in the newest RC between float 16 and float 32, by the way, for any vector data types you define. I'm not doing that here. The default is float 32. But if you do float 16, it's half the size. It'll be smaller, take up less space. It might be something you want. All right. Vector property tells us about a vector. I guess you could have guessed that, right? There's only a couple right now. There might be more in the future. Number of dimensions, 1, 2, 3. I get 3. Base type, float 32. I just mentioned that a moment ago. There might be more of these in the future. If not, cool. If so, great. But these are some of the new vector properties you can pull out really fast from a vector if you need to know them. Again, You may use a lot of this because you're working heavily in math and stats, or you're working with AI and vector embeddings, in which case this is new, amazing stuff that will make your life a billion times easier. If you're not working with any of this, just be familiar with the fact that it's here now and you might need it in the future. And now I'll clean up our table. And I'll Control S because I actually made changes to the demos. It's fun like that. All right, JSON was introduced. And the vector stuff is huge, by the way. And I didn't do any demonstrations of embedding models. You can actually set up models, connect them directly to SQL Server, and you can send data off to your models and get it back. So I can go off and send data off, get embeddings, apply to them, return it to SQL Server, and store it. I didn't demo that. It gets very involved. It's not a presentation on AI. There's lots of those out there, though, right now, in case you're interested in one. So just throwing that out there. 2022, SQL Server 2022 added a whole bunch of native JSON functionality. Is having JSON in SQL Server fun? Not always. But for many applications, it is the right thing to do. It is the best thing to do, and you may just be stuck with it potentially. So if you work with JSON and SQL Server, they added a few more functions in 2025. And these essentially are just like string ag. They give you the ability to create objects from a bunch of rows for columns in SQL. I'm going to demo it quickly here. Not everybody uses JSON and SQL Server, but you may. And if you do, this will matter to you. So we'll start off with JSON object ag. This creates basically JSON object right out of SQL. And so I'm just using systables, syscolumns, systypes as kind of my example. Return a column name and a type name, and then put that into a JSON object for me. And so I go ahead and I do that. And notice this is an aggregate function. So you got to have your group by. You can't, have other columns thrown in there by accident. It is an aggregate, just like sum, min, max, whatever. And you can see that I go ahead and for each column in here, I'm going on and getting that column information. So for each table, I'm getting all the column metadata for that table in a JSON object. This is really useful. If you need to take data out of SQL Server, pack that up into JSON and send it off to an app, which is a pretty common thing to do, here you go. So you don't have to go creating the JSON from scratch if you don't want to. And if the application truly just wants JSON, it doesn't want a bunch of data, this will be the easier thing to do as opposed to send a data set back to the app and then have it package it up into JSON for you. This is going to be a little cleaner. You can see it did it for all the columns, int, int, nvarchar, whatever. There's an additional parameter you can pass in, null on null, or you can also pass in absent on null. And so null on null, sounds funny, means that if a value is null, if for whatever reason the underlying property I was looking for that I'm returning is null, it will actually say explicitly null here. You can see that here, here, here. There's nulls for a bunch of these. Cool. If there's a null, it'll return null because this is correlation. I'm showing the correlation here for fun. So if the correlation is not set, it's the default, I get null. You can also use absent on null because not everybody wants null in their JSON. And so for this one, it basically says for any column that has a null for correlation, it gets omitted. So you can see for some of these here, they're empty or they only have like one column. So null and null or absent on null simply are functions, functional kind of extensions here that tell it what to do if a property has null, and either you include it or you don't. But that's useful. So object ag will create you a nice object right out of SQL, right out of your data, and you can manage null if you need to, which is pretty cool. And once you have this, you can just send this off to your app or store it or whatever you're going to do with it. Lots of uses for JSON these days, and this makes it easy. Array ag is kind of similar, but in creating an object, instead of creating an object, it creates an array. And so we can see that here. It's not quite the same. It's not the object with the squiggly brackets. It's an array where you basically just have the open square brackets, your big blob of stuff, and your closed square brackets. So this is really a matter of do you want the full object or do you want a component of a JSON object or you just want it in this format? It looks just like before. The only difference is really just the formatting of it. That's all. I can go back and kind of show what we did before. And you can see it has just a little different syntax, but otherwise very, very similar. And so there we go. There's our array right out of SQL. You can also put an order by in there. I haven't demonstrated that yet. I can put an order in there, and now it's going to go ahead and order the column names within the object. So I can see it starts with B, C, L, P, and so on. Everything's in alphabetical order. Beautiful. So those are two cool new functions. Again, if you need them, you need them. If you don't need them, you don't. If you don't use JSON, more power to you. String similarity functions. These are kind of cool. These do mathematical calculations to find out how similar or different strings are. This is not vector embedding stuff. These use well-known algorithms. You can learn all about them if you want and read about them. If you go up to Microsoft documentation on either of these, or you just look up Jarrow-Winkler, you can have a fun time and learn about how these are done. So there's no secrets here. None of this is proprietary. It's using open source algorithms. So did I not have demos for that one? I thought I did. No demos? No demos? I have no demos in that one. Oh, I do have demos in that one. There they are. This is a new presentation. This is what happens. So these calculations here for distance tell me how different or similar things are. And they're not complication. So edit distance tells me how many transformations are required to get from A to B. So how many additions, subtractions, or substitutions. So to go from grandeur to grander is 1. To go from Edward to Eduardo, 2. Very, very straightforward. There is an algorithm. I put a link here for it. When I share this later, you can check out the link and learn how this is done. If you send in null, you get back null. That's all. What's the difference between SQL Server and Postgres? A whole lot. I'm just being silly. It's not that different necessarily. But for the edit distance between the words, they are. So this is a very straightforward calculation. You can learn all about it, but it tells you how different or similar words are. So if you want to find out similarity of strings and you want to use one of these algorithms, if you want it to be simple, you're not throwing this at some LLM, you can do it right here without any vector embeddings at all. And it's good. These are deterministic algorithms. They're not going to return different amounts, different times of the day, which is something you may want as well. So if I run this next week, next year, I get the same result because these are known algorithms. Edit distance similarity is kind of similar to this, but instead of returning a distance as a whole number, it returns a percentage. So for this one, how similar are grandeur and grander? 88%. How similar are Edward and Eduardo? 71%. And how about SQL Server and Postgres? 20%. And keep in mind, this percentage is just calculated using that edit distance from before. You can do it yourself if you want to. 1 minus the edit distance over the greatest of the length of the string, greatest of the two lengths of strings times 100. That's how it calculates it. It's not a big deal. It's just math. It does the math for you, though, and gives you a percentage. So if you want to order by a percentage, because string lengths can vary, a very long string could differ by more places when compared to a very long string than two short strings. This gives you a percentage, which is more universal. The Jarrow-Winkler distance basically does the same exact thing using a different algorithm. This algorithm has a preference for the prefix of characters. So if the first characters match, you get a higher percentage. So in this case, this is a distance, by the way. So 0 means the same, and the bigger the number is, the more different it is. So now I get a distance between grandeur and grander of 0.025, which is very similar. Edward and Eduardo, 0.12, not quite as similar because less characters match in the beginning, but still very similar. SQL Server and Postgres, kind of different. Again, all the letters are very different. There's also a Jarrow-Winkler similarity, same exact calculation as before, but done as a percentage instead of a distance. Oops. And if I run that, we can see that I have grandeur and grander 98% similar, and it's that similar now because it's putting a leaning preference in the fact that the first 5-6 letters are the same, because a lot of string searching puts preference in those first characters. Edward and Eduardo a little less similar. SQL Server and Postgres a lot less similar. So these are really cool and worth looking into if comparing strings is something you want to do and you don't want to use regex, you want to use an algorithm like this, you don't want to use AI. This works, and it works deterministically, which is something that is very important for a lot of string comparisons. There's more, and I have some demos in this too. There are a lot of little changes and additions made that are a little more minor in my mind, but they're still useful. Substring now has a length parameter being optional, which is nice actually, because what happens if you don't supply it? It will default to going to the end of the string. And this simplifies your code a lot. Date add will take in a big int now, as opposed to taking in an error message and giving it back to you. Yay! Current date is a new function that returns the current date. I guess that was obvious, huh? But it's nice because it didn't exist before. You used to have to say cast the get UTC date as date, or cast current timestamp, or cast date time offset. You had to do things like that. You had to put a cast or convert in there, and now I don't have to. And two more functions that are kind of useful that I'll show as well are base64 encode and base64 decode, which does the thing that we've always hated to do, which is converting varchar to var binary back and forth. If you've done that before by hand, you've probably been frustrated at some point. This does it for you, and it's really nice. So let's jump back in and look at some of that new stuff. Do I have it? Do I have it? Here we go. I got to reorder my stuff later. No big deal. So the way I used to have to do it with substring is I used to say something like, get me the length of the string minus the char index for the thing in the string I want to find, and add 1. So I can get the substring of, and this is a common use case, right? I have a file name. I just want to get the extension off the end. That's all I want to do. Just give me .sql. Please give me .sql. But to do it, I have to do a little bit of complicated string stuff. And there are other ways to do this that may not take much text. But whatever I do to get this is annoying. And yes, the regex functions will do this too. But if you already have a substring out there, it now to get simpler. I can substring for the .sql, and I can get the last 4 characters, and I'm done. And so this is really nice. Substring from the period, and give me 4 characters, done. And I don't have to do anything else. That's really nice. It defaults to go right to the end. Really, really nice. But not as nice as this. Here I have nothing. Now I just say substring.sql, and it gives me the .sql. And it doesn't care that the string ends here. It just stops at the end for me, and it counts and does the thing. That's really nice. So my SQL went from this to a little simpler to the simplest way possible using substring. So the default now in substring is to go right to the end of the string, which is really, really nice. The data add function here is very similar. I threw in a giant number. This would have thrown me an error a while back, error message 8115, which everyone loves and knows and hates, right? And now it just gives me a result. If I want to add that many milliseconds to 1/1/2025, I can, and I get a result that's meaningful. So if you want to use data add and you want to add a whole lot to it, it'll work. And I have actually done this before. I've actually added milliseconds before and broken data add and been sad. So this won't break anymore, which makes me happy. What did I used to do? Cast get UTC date as date, and it will return 9/27/2025. Yay! But if I just want the current date, here it is. And it's returned as a date format too. So it's actually date data type. Simpler, simpler. So again, this is taking your code and simplifying it, and that's wonderful. Simpler is better. My last demos for the day are in the base64 encode and decode. If you deal with this kind of encoding stuff, var binary and varchar, this has been a hassle. If you don't deal with this, you're lucky. You're so lucky. But if you deal with this, these are annoying things to have to do. These can be difficult to convert and difficult to make safe for transmission for web URLs or for other purposes or for just sending off places where I don't want to have SQL injection or whatever. It's a hassle. So here's the way it works. I have a string, and I do base64 decode, and I run this, and I get back a var binary output. There it is, var binary. And if I go ahead and I put that back in, I get my data encoded back again. Cool. I didn't escape my spaces, so my spaces vanished. That happens. I wasn't being too precise here, but you can see I got back basically what I put in. I didn't make this up, really. This is not made up stuff. It even highlights pink now, which is really nice. Base64 encode, I can do it like this one, for example. And now there is an optional flag that's useful. This is the sort of thing that if you use this, it's going to be really handy. If you don't, no big deal. There's an optional flag, just a 1, if you add it on, that makes this web URL safe. So basically, if you're going to be taking this output and sending it back as part of URL as form results or something like that, this ensures that it won't break your URL. It'll also ensure that you can't like SQL inject it, URL inject it, You can't have security problems or broken stuff as a result. So note the result I got a second ago has some equal signs on the end. Well, if I run this version here, the equal signs are removed. So I get my encoded value correctly as a varchar to send off somewhere, but there's nothing in here that will break a URL, and that's really important. That can be dealt with later on if you needed. When the data has been transmitted to wherever it's going, you can deal with it later if you want or not. But this is actually really nice. So if you deal with anything that goes over the web, this may be a huge time saver for you if you're pulling your strings out of SQL. Whew, that's a lot of stuff. So these are new or slightly different things that will make your life easier. Honestly, current date sounds so simple, but I'm already using it in my RC instances because it's just simpler and I can have less text. And really, at the end of the day, anything that can simplify your code, make it shorter, make it simpler, which the regex stuff definitely can, and some of these can too, it's wonderful. So I'm going to wrap it up here, give us lots and lots of time to kind of wind down, get feedback, and get ready for our next session. There's a lot of new stuff in 2025. And I know that the vector embeddings and the AI get a lot of the headlines right now, but a lot of other functionality here will make your life easier, whether it's TempDB monitoring as a database administrator or regex making your string searching less horrifying. There's a lot of new stuff here that will really, really help you. Even just the edit distances can have a lot of use in your code if you want to compare strings quickly. The kind of the crux of this whole thing here is going to be that every new version of SQL Server has new T-SQL, new syntax that you can use immediately. You don't have to get a new edition. You don't have to pay more money. You do have to upgrade. Or if you're in Azure SQL Database, you can just kind of have it, which is nice. But it's there for you. And so this functionality is here for you. You don't have to do anything to get a hold of it aside from use 2025 or be an Azure SQL Database, and it's there for you. So use new functions when you can. Make it a part of your life. Use native functionality when it's available because it will make things simpler, faster. And that's a huge piece, by the way. You saw that when I was playing with vector embeddings earlier, I created a vector index. You can create vector indexes now and make vector searches fast. So there's a lot of things here that not only make your code simpler and cleaner and easier to read and happier for developers, but will improve performance. So this is an incentive for you to, when you're ready, upgrade, test new features, and have fun with new features. Enjoy the new features because they're out there for you. Use them. There's no point in using SQL Server if you don't use the functionality available in SQL Server. There's no point of using any platform if you don't use the things available, and there's a lot available here. So I mentioned questions. There are no questions here, but do find me for questions. If you use any of this new functionality, if you love it, if you're interested in it, if it doesn't work quite the way you think it should work for you, find me. I'm available. I'll share this later. Find me on LinkedIn or wherever. Contact me. Find me on Sessionize. I have a GitHub. Feel free to find me, connect with me, and ask questions. Questions don't have to end when a conference ends. They can go on forever. They can become chats. I've had people meet me after conferences, and we've chatted about hobbies. Oh, you run as well. You bake. You do things like that I do. Wow, that's awesome. And we chat, and it's fun. So find me later. And last but not least, there is a feedback form. They're going to bring that up in between sessions, but there is feedback. So please provide feedback. Feedback is very important. It tells everyone how I did. It tells them how the event is going. And so please provide feedback. And with that, I'm ready to kind of hand it back and give our next speaker 5 minutes to transition on in and let the fun continue. It is very quiet here right now.
Looks like I'm muted.
Oh, phew. For a little moment there, all right, you just scared the snot out of me because for a moment I thought that maybe I cut out, my internet connection went, and I was presenting to nobody for the past hour.
Okay, no. It's been great. I've been listening in the whole time. A lot of great information there. Thank you very much, Edward.
Well, that was good for a laugh. Thank you. I do love a good laugh. I do appreciate it.
Brilliant. Well, we're actually heading into a lunchtime break at the moment. So a lot of great content in there, actually, a lot of functions, a lot of capabilities within T-SQL. And I'm sure that when people review your deck and the examples there, it's going to be really informative. you had a slide in there, I think, with the a link to the scripts and things that you used, correct?
Yeah, I'm going to put them on GitHub now. It's not there yet. I will put it there now. I can put my GitHub link here. I'll just GitHub. There we are. That goes there. Oops. Presentations. We're going to a break right now. And for you, it's lunch. But guess what? For me, it's breakfast. I'll be having breakfast shortly. So here we are. Let me just go ahead and grab my... I'll drop everything in a moment once I'm done. But yeah,
No,
I will drop right into the
We've got some
StreamYard here.
time anyway.
I will drop in. Oop, there we go.
Well,
there's my GitHub. I will post it to GitHub in a few minutes. And then anybody who feels like downloading it can. This is a brand new presentation. I will fix the SQL I'll take 1 minute, and the SQL is not ordered correctly. There are a couple little fun things in there that came up because it's new. And I just chuckle because it's part of life, right? But it's cool. I don't mind.
no worries. So that's great. And I think overall we're pretty much heading into time. And I would actually encourage everyone to actually connect with you, like you said, offline, and to see any questions, since you've done a lot of testing out on the RC from the new SQL, T-SQL features. Really, really good and informative stuff. So thank you very much for speaking and presenting at our conference, and wish you a good continuation to your day. You've got the whole day ahead of you now. So have a great one.
True. I'm an early bird, by the way, so this is not an inconvenience. I love this. And I do have some Simple Talk articles as well that cover in depth, like regex and resource governance, too, if anyone's interested.
Great.
But you can find all that by connecting. Anyway, enjoy lunch. Have a wonderful lunch, and I look forward to seeing you soon.
Thank you very much.
All right.
So thank you
Take
very
care.
much, Edward, and talk to you soon. Cheers.
Yeah.
Bye-bye. So on that note, everyone, we are heading into lunchtime. Before we head into lunch, I will quickly show some videos from our sponsors. Thank you very much for the sponsors for sponsoring this this conference. We are going into that now on our media assets here. And I think it starts with this one here.
Hello, DataBash. I'm Arthur from the DatenWG core team, and we are a bunch of dedicated Power BI, Fabric, and Copilot experts who are really enthusiastic about Microsoft Data Platform and all the community stuff. This is B5. Humbly, we call us the Avengers of Power BI, and this is how we really look like if you want to see. Yeah, just feel free to contact us on anything about the Microsoft Data Platform, and have fun at DataBash.
And we're starting now with our break. So enjoy lunch, everyone, and see you soon.
Timișoara este un oraș cu peste 350.000 de locuitori. Suntem o primărie destul de mare, în jur de 500 de angajați și încă câțiva mii în subordinea noastră.
Ne ocupăm cu digitalizare de documente. Primăria va fi la fel ca și o companie multinațională care are sisteme foarte avansate.
Aș fi luat aceiași furnizori. Dacă am fi putut începe de la început cu ei, bineînțeles că eram 2 ani mai avansați.
Acum forțăm tot ecosistemul să vină după noi. Această eficientizare ne lasă să ne focusăm pe ce este important, adică pe partea creativă, pe partea empatică.
99% din primărie, din procedurile ei sunt digitalizate.
N-ai nevoie de studii bine imaginabil de multe tehnice ca să poți lucra cu un program atât de simplu. Vă doresc cât mai multă răbdare. E un proces anevoios câteodată, dar excepțional în momentul în care este finalizat și implementat cu succes.
Hello, DataBash. I'm Arthur from the DatenWG core team, and we are a bunch of dedicated Power BI, Fabric, and Copilot experts who are really enthusiastic about Microsoft Data Platform and all the community stuff. This is B5. Humbly, we call us the Avengers of Power BI, and this is how we really look like if you want to see. Just feel free to contact us on anything about the Microsoft Data Platform and have fun at DataBash.
Technical issues. Let me see if I can get the assets off. Okay, great. I am back online. Hello. Welcome back after the break. We are about to go into our next session after lunch. I have here in front of us as well Maya. Hello, Maya. How are you doing? Can we hear you?
Hello.
Is your mic on?
Great. Hello.
Hello. Yes, good to hear.
Great.
So we're about to start on the second part of the day. So right now we are going into the part after lunch, as you can see on the screen here. And Maya will be talking to us about using neuroscience knowledge to unlock visualization and data storytelling potential. So we hope you're all ready after lunch. Hopefully you've had some caffeine as well. You're well caffeinated after the lunch as well. So let's let Maya get right into it, and hope you're sharing your presentation, Maya, and we can get going from there.
Hope you see my presentation.
It's actually, I can see your PowerPoint, but not the presentation side. I don't know if you need to press F5 or something like that.
Can you see my second slide?
There's only one screen that I can see.
It's
maybe you can see it there too.
Can you see it, or?
I can see your PowerPoint deck. I don't know if you're if you've pressed F5 or if you've.
Yes, I press F5. So
maybe another screen.
I have only one screen today, so I apologize for that.
Okay.
So
then
if you have, can you see my second slide? Okay, I see it. Okay, and so we will start. Welcome again to my session. My name is Maja Spani-Kezan, and I'm in data space more than 20 years, and I still enjoy and passionately love playing with the data, extract values from it, and learn and teach others. And when you passionately love something, no matter how experienced you are constantly try to improve yourself. And that's how I discover neuroscience, which explains more about how our brain function, and cognitive psychology, which explains mental processes like memory, attention, problem solving. And wow, it explains a lot and helps a lot. And I want to share with you some of my findings. And hope you see the second slide. Our brain is an amazing organ. It weighted only 2% of our body weight, approximately, and to feed more than 100 billion of brain cells called neurons, we need 20% of our blood. And yes, it's a huge amount. And yes, we have survival security mechanism. It's situated in our limbic part of the brain, which is responsible. Hello? Yes.
Right, so I'll just come in again. It looks like we're sharing again the PowerPoint deck rather than the second screen. Maybe you need to reshare.
I will immediately do so.
Maybe share screen instead of app. That might be the way forward.
We will share entire screen. So
okay.
We will have. Is it better?
Perfect. That's perfect. Thank you.
Thank you. And so we need to have the system that can decide how much blood will be pumped to upper part of the brain, to more cognitive function and human part of the brain, and how much will stay in brainstem, in reptile part of the brain, responsible for survival and rest of our body. And hope you see on my third slide and this green dot, which represent amygdala. And it's responsible for figuring out how we feel. Do we feel fear or joy, and what we need to do, fight or flight. And to do that, we have very small amount of time, and we use skimming process. And we need to, during this process, find what is going on, and key elements and key performance indicators, result indicators is widely used. And our brain likes to connecting dots, and like to connecting dots also with existing memory and existing knowledge. We have in our limbic brain also one part responsible for evoking memories by index. And to do so, we need to have context, and for business users, this means that you provide them context in their business terms. They are used and they immediately can understand, not to translate to something else and then understand. So far, I've worked for 8 different telecom operators around the world, and they have different business terms for the same part of the business process. And they have even used a subscriber definition differently, no matter they are operating on the same market or have the same owner. So we need to adapt this to their everyday lives and everyday terminology. And of course, to feel the joy, we need to have compelling visuals. And pretty much soon, when I started to work as consultant for clients worldwide on 5 different continents, I realized that what function for one team and one group does not mean it function for others. Extreme example, if we have green color in most of parts of the world, it means it's okay, we are good, and we are on the track. But in some culture, it means quite opposite, and it also represents death and even exorcism, and is forbidden for use. So what we can do, we can use Gestalt principles, which describes how our brain perceive things what we saw. One of most common used principles is similarity, which describes how our brain elements which are alike perceived as similar and related to each other. Usually these principles is represented by the same shape, but also work perfectly with the same color. In this example, I have red color for crimes, and it's also used in card, in chart, and in table. And for resolved crimes, we have another color, and it's constantly represented in the report. And also our eyes love to have continuous path and try to follow this, so provided alignment and nature pattern for layout helped. And the common region describes how our brain thinks that elements that are on the same background and share the same boundaries are also observed together as similar, as we have approximately put all these things at very close to each other. We have other principles as well, and we don't have so much time, so I provided you follow-up links so we can explore it even a bit more. And we need to provide clear and simple as we can, and eliminate what is duplicate and what is not necessary in our reports. And in this example, you see the context twice, and it's obviously it's duplicate. And why we need to have it clear and simple to avoid cognitive overload. And what does this mean? We all have working memory, and as we all know, working memory has limited capacity. What does this mean? If we put all information at once, at one place, our brain will be confused and could not process all of this. And our amygdala might find out that we are in the fear, and we need to run away from that report. So what we can do, George Miller, one of the founder of cognitive psychology, discovered that we can process 7 ± 2 items, and it was almost 50 years ago. Later on, he discovered that this number is a little bit increased if we use number and a little bit decreased if we use text. Recently, researchers found out that this number is 3 to 4 items. And of course, we have limited amount of time to do this, up to 30 seconds. So what we can do, Schneiderman almost 30 years ago introduced visual information seeking mantra, and which can help us by dividing these into 3 main parts: overview, highlight what is important, what are key elements, and what are the answers to key questions that our audience expected. And it's perfectly fit what we saw already in this scanning and screening process. Find out what is important and what is happening. And then we need to zoom in to see what is the most important and filter out the rest, where we need to focus. And sometimes we need more information to get the action and make decisions, and we need to get details on demand. How it works: provide the overview, maybe provide the trends, and you can also provide the benchmark, either internal targets or external one like market share and stuff like that. And then provide zoom and filter, and we can see on this example where we need to focus our limited resources on which time slot in which areas. And if we need more information, provide through navigation more details on demand. And Kurt Buller, data goblin from SQL BI, go even further with his 3-30-300 rule and provide more information, more examples, and give time frame for this. So our users need to be able to find high overview within 3 seconds, zoom and filter within 30 seconds, and detail on demand within 300 seconds. And also you can find this in your follow-up links. But can we do more? Chip Heath, Stanford professor, discovered that students, after hearing different speeches, 63% remember the story, and only 5% remember individual facts. And why are story more memorable than facts alone is because our brain loves to connecting dots, either to existing memory and to existing knowledge, but also to find the new one. Like to discover things, like to figure out things, and like to search and find the patterns. And during the storytelling, within the story, we flow them through this process and help them easy to understand and easy to remember. Story evokes us intellectually, but also emotionally, and our amygdala is happy, and we get more blood to our brain, and more brain parts are in function, and it's more likely to be converted into long-term memory. I also want to present the work of Demécio, Portuguese neuroscientist, who discovered in his study a patient with prefrontal lobe that they perform very well intellectually, but they have a lack of emotional reactions, and they have difficulties with decision making. Yes, facts are important, but things evoke us emotionally, and stories do that, but also evokes neurochemicals. Paul Zak, a neuroscientist who did more than 50,000 researchers for his book Immersion, discovered that our body released oxytocin when he heard a good story, and it's connected with the empathy and the bonds. And during the storytelling, that provide us collaboration and provide us trust. And that, with this figuring out what's happening and understanding, releases dopamine, pleasure hormone, which help us with the memory and focus. And our stress hormone, cortisol, decreased, and we get more attention and open to negative messages. To summarize, we have data in different shapes, and we can have the visuals based on the data. Don't forget, we have two types of visuals. We can explore the data and find the story, or we can explain, help story to be told. And don't forget that visuals have three main parts that have overview, zoom and filter, and details on demand. And if you want to audience even be more engaged, provide the story. And the parts of the story are introduction to context, introduction to characters and the scene. And we can see from today that all different characters can be set up. Even our amygdala can be one of the character. And then confront all these things, all the scene, when, where, who, into the why this happened, and when the things change. Describe root cause, make users understand this, make that dopamine released in our body, and we get more focus and memory, and then provide a solution in our last resolution part, and then help call for action and what we need to do next. My time is up. I provide you a bunch of follow-up links. I also have other references as well, as if you want and need more, please contact me via LinkedIn. Thank you for attention, and hope you will join the rest of this wonderful conference. Thank you.
Thank you very much, Maya. That was great. Thanks for it was a very quick overview. 15 minutes isn't that long, actually, to be presenting so much content. So very good. Thank you very much for doing that. We are now going to move on quickly onto the next speaker and the next presentation. We will be, as we said before, we will be all this is recorded, and we're going to be putting all of these different videos into our YouTube channel separately so that you can reference them and see the content that you need. So what we have up next is Gilda. Hello there, Gilda. Gilda will be talking to us about Azure Arc for SQL Server. And so we're looking forward to hearing from you, Gilda, on that. And I will find your presentation screen, which isn't up yet. So you need to reshare that. And then we can start looking into Azure Arc for SQL Server. And of course, make sure you introduce yourself once we get to that time as well.
Can you hear me?
I can hear you, yes.
Okay. 1 second. Are you able to see my screen?
Not yet, no.
About now?
Not yet.
Okay, so looks like I'm not sharing. Okay, where do I go? Share screen. Windows. Share. Okay. About now.
And yes, we can see that now. Great.
All right.
Here we go.
Hello, everybody. So today we're going to talk about Azure Arc Enabled SQL Server Guide. We're going to do this in 20 minutes, and it's a lot of material, so let's get started.
Make sure that you're sharing the other screen there, not just the deck, if you've got the other screen up as well. The PowerPoint show. We can see the slides and the outline as well.
How do I stop that? Because I don't have that option. Let's see. Because when I go here, I say it's a share screen.
Yeah, the full screen or the desktop or just the PowerPoint? Try the desktop.
Okay. Entire screen?
Yep.
Okay. Perfect. There we go. Now.
Coming up.
There we go.
And perfect. Good on you.
All right. So sorry. Thank you, everybody. We have a lot of material to cover, so let's get started. We're going to talk about Azure Arc Enabled SQL Server Guide. A little bit about me. My name is Jodan Alvarez. I graduated from UCF here in the United States, MIS in computer science. I have over 2 decades of experience in SQL Server, and I am an architect that works for LTMindtree. We're going to dive into what is Arc. So Arc is the way we are now able to manage, secure, and govern all of our hybrid cloud environments. So we can use one single view to manage all of our SQL servers. We can capture all the metrics. We can do best practices assessments. We can secure our environment from a click of one single view. And that is, in a nutshell, what Azure Arc is. And what I'm going to show you here is the part of enabling Arc on SQL Server. So really, what capabilities do we gain through this single view of all of our SQL servers in a hybrid cloud? We're going to be able to manage our compliance, security. We're going to be able to patch. We're going to be able to do disaster recovery, assessment management. All this is wonderful. In reality, it's very complex, but we're able to do it by extending our arms from the cloud all the way to all of your hybrid environments, either on your AWSs, your Googles, your OCIs, all of the clouds, all of it can be controlled in Azure. Just like we have here, all of our different governance, security, all of the options of a hybrid cloud available through Arc. This is a little example of how Azure Arc Enabled architecture looks like. So we have here the policy, the Arc server, the Arc Enable, everything is going to be communicating to your machines on-prem or in any of your clouds. things we need to consider is we are communicating through HTTPS 443 outbound, something to keep in mind. We're going to go over the prerequisites in a minute, but these are some of the things that we need to consider. You should have a subscription, you have a resource group. You know, we're going to go over those requirements in a minute. Okay, so we can do this connectivity either to individual machines, or we can do scale out implementations of Azure Arc. We connect through public, proxy, private link. The resource providers need to have all of these permissions, and we can use server principal to connect to the machines. So how do we do this, right? We can use the portal to manually create a script and install it in each of your machines. And we're gonna go over a demo on that. We can use PowerShell, we can connect with Windows Admin Center, we can do GPO, we can do multiple ways of scaling out all of your environments and be able to enable Arc for both your Windows and your Linux boxes. What are the permissions you need? Make sure this is very important. You need to have user permissions such as contributor, user access administrator, and resource policy contributor. So what does this look like from a network point of view, right? So we have the first option, which is you're going to enable Arc through the internet, through a public endpoint. You get to do it through proxy, or if you want to do it through a private link, you can go through Azure Express Route or VPN and connect and be able to connect to your endpoints, which are going to be your private endpoints here. Okay. This is what it looks like when you're running it in Azure, right? It says select your method of connectivity. We should either do public, proxy, private link, and here's you can set up your proxy. This is how we would do if we enable private link through Arc, right? And it's possible. So we can go through this VPN or Express Route and enable all of your environments. Not everybody wants to use public, although it's easily available. It's not something many companies want to do. So we have this alternative. How do we onboard these SQL servers? So we're going to go through a demo, but the most important thing is you need to have your resource group and your subscription ready, your region and the operating system. And right here where it says SQL Server, we will connect to the SQL and get all of what we need through this checkbox, okay? So we're going to go through a demo. So this is Gilda creating her Arc-enabled server. We're going to go machines. We're going to add and create, add a machine. And we're going to generate a script. And here, of course, we're going to need that resource group that I mentioned, RG Gilda. And we are going to select the region. I'm in East US. And it's a Windows and it's connected. Automatic SQL Server. We're going to use public. And we're going to go next. Okay. You can add your tags here as well. Next. And this will generate a script. Okay. So once we generate the script, we can then run the script on your environment. So sorry. You can run your script in your environment. We copy that script that's generated. We open PowerShell on the machine that you're going to install the agent of your Arc. And we just copy and paste the script. And we run it. think the screen is not very visible. Let me see if I can. So what is happening in the back, this is going out to the internet, downloading an MSI file, installing it in your Windows machine, and voila, it makes connectivity. Of course, we're going to go through some of the requirements from the network. We are going to have some URLs that need to be open in order to authenticate. And that's it. You should be ARC enabled. It is that simple. Things you want to keep in mind is because we're installing an agent on your workstation or your VM or your SQL or whatever, you have to understand that there's going to be a service account called HIMDS that needs to have log on as service permissions. And that is critical. If you have any policies that block this, it will not allow this to connect. So we need to make sure that that's not blocking us. All right. So what are the supported configurations? SQL Server 2012 and later versions. Windows include Windows 10, 11, or later versions. And we have Linux operating system, including Ubuntu 20.04, Red Hat, and all of these. I have a list of them as well here. These are all your Windows and your Linux. Some of them are not. So how do we manage this? This is the beauty of ARC. You can, many companies have many tools to be able to see and do inventories and things of your SQL Server. With ARC, you can see it all from here, from your screen. How many SQL servers you have, what are the compatibilities, all that information right here. And it gives you a little bit of performance as well from all of the different dynamic views that we have in SQL Server. We can generate all of this performance in dashboards, okay? And these dashboards are free. You can just go into, I'll send you the link, and you can just download these dashboards for free. This is just a little example of my ARC enabled server that I have created, so that you can see that I now have the extension created on my SQL Server and everything is completed and connected. One of the things that it gives you also is the opportunity to have best practices. I don't know how many people enjoy using Brent Ozar's Blitz, Well, this is kind of like a little bit of everything best practice from Microsoft that is generated through a workspace. And this is how you start generating the assessment through this, running the assessment. Keep in mind that this assessment is going to require to have log analytics and some data. So there's only a 5 gig for free. So if you need to use more than that, it will charge you. So this is how you run your best practices. We will look at a picture next of what the best practices look like. So best practices will give you kind of like, okay, you didn't do a backup. We are, we can do multiple temp.db file. It gives you just many options that are best practice in Microsoft of things you can change and update on your SQL Server. It's always good to have another set of eyes. And you have also a way to deploy these dashboards that I was mentioning to you. These dashboards here are freely on GitHub, and I'll show you the link right here. SQL Server samples, and it's just JSON files that get loaded into your SQL Server. And here we go. We have now graphs of all your 2012, 2008, 2000, all of these nice features for graphing all your inventory into a visible environment.
Thank you very much. Thank you, Gilda, for that. How are we going in terms of the presentation? Are you close to the end? We're running a bit over time, it seems now.
Okay. That's it. Thank you so much for your time.
No worries. Do you want to wrap up? Do you have a wrap-up slide or anything that you'd like to present for that? Or shall we wrap it up this way? Okay, well, we'll do it that way. So thank you very much, Gilda, for the presentation, talking through Azure Arc, a lot of the features and capabilities and how it's set up. And that's great news. Thank you so much for that. As I've mentioned before, all of these sessions and the demos that were in the presentation will be uploaded to the YouTube channel. They'll be separated there so that you can actually view them at your leisure and find them at however you need them. We're going to thank you so much, Gilda, for that, and we will move on probably to the next session. We next have Marcel and Frank speaking to us. I'll put them up on screen here as well. Ciao, Gilda, thank you very much. And we'll move on to the next ones here. So,
awesome.
Hey,
hello, how are you doing?
Very well, thanks. Good to see you both. Sorry, we're running a little bit over time. It's only a few minutes, I guess, from the presentation. We're talking to you both today, and you're both presenting to us about releasing the potential of Microsoft Real-Time Intelligence through AI agents. That should be quite the session, so I'm looking forward to handing it over to you. If you could both introduce yourselves and then start going through the content, I'll add you to the stage.
All right. Happy Saturday. Frank, are you there? Hello, Frank.
I can see you both. It looks like Frank might be frozen. Oh. Yep, Frank's frozen.
Okay, so then I'm gonna start. So maybe he has some challenges with the internet. Yeah, I can hear you.
Can you hear me now?
Yes. All right. So Frank, introductions. Oh.
Yes. Yes. Can you hear me?
Yes, I can hear you.
So yeah, well, my name is Frank Geisler, and yeah, perfect. So my name is Frank Geisler. I'm CEO of GDS Business Intelligence GmbH, and I'm over 25 years in IT, and I'm a long-term Microsoft Data Platform MVP and dealing with topics real-time intelligence and and AI as well now, right, Marcel?
Yeah. So then I continue. So first of all, welcome everyone who joined. Happy Saturday, and we all thank you for all your interest in the topic. And so I introduce myself as well very quickly. So I'm Marcel. I work for Microsoft. I'm leading a solution engineer team here in Germany. I'm based close to Cologne, with plenty of years of experience in that regards. And I'm working with several customers from small to big across all industries. And you can find me as well as Frank on LinkedIn or our GitHub repo, and we will share all the content also afterwards with you. And with that, I would say we got to start. So this is our agenda. So first of all, we want to give you a short introduction about the use case that we built it and what we basically the business model. So like we have a kind of a real-time customer architecture that we built, and so we want to explain you a little bit like what is the background of this effective customer, and then we will introduce you to the architecture. We will also explain a little bit on Fabric and RTI, so real-time intelligence, and then we go a little bit on the data streams and the dashboards, and then also we will look into the agents and MCP servers. So our business model. So what you will see and what we built it here is so we are basically a bike rental company. So this means like on the one hand side we have bikes that you can rent for sharing, and we are in the city of London. So basically we have different bike stations that are all across London. And on the left hand side you can see our beautiful bikes that we offer for rent, and then in the middle you have all the bike stations, and then on the right hand side you can see that there are also events happening in London. And so the challenge for us is like, how do we best distribute the bikes across the city, across the bike station, depending on the demand? And so there are different factors that are relevant. It could be the weather, it could be people, it could be events. And this distribution problem we want to solve with the help of an agent. And so the idea here is that we say, okay, we have different data sets that we get, different data streams that we have, but how do we best distribute the bike? And so currently it's a manual work, as you can see here on our flow, but we want to automate it with agents. So like on the left-hand side, you have data streams that are flowing into our data platform, which is Fabric. Then you will see some nice dashboards on top of it. And then we have a data agent that can interact with our data sets. And then we want to build a bike dispatch agent. And the bike dispatch agent has the responsibility to help us and support us optimizing the dispatch of our bikes. So where do we distribute the bikes best regarding to events and where bikes are probably needed. And then we have a bike dispatch system that is basically automating the dispatch. So in our case, we don't have a real dispatch system, so we will simulate it by sending basically an email to the dispatch system.
Exactly, but the idea on this is that you would have like a system which could be accessed through a web API or something like this, and then it will actually do the bike dispatch. And not the email. Email, as Marcel already said, is just like a fake or something, so we can just execute something.
Mm-hmm. So Frank, how does our architecture look like?
Okay, our architecture looks like this. So on the one hand, we have the Fabric part. Most of the Fabric part are these yellow boxes. So we have, first of all, we have the stream of data about the bikes, and we have a stream of data about weather data. So the weather data is also dependent on the several boroughs in London, right? So we get exact weather data for whether it is West End or if it is London Central or whatever. And from the bike stream, we get events whenever someone is renting a bike or whenever someone is returning a bike. And this data is streaming data, which is fed into our event house. So the event house is a part of KQL, of real-time intelligence, which is used for storing event data. We will come to this a little bit later. The other thing is we probably have things who don't change so much, like the bikes and the weather. These are events. So in this case, usually if there are big events like Metallica is playing at Wembley Stadium or something like this, then these events don't change so quickly. So what we have here is we have a batch ingestion of events into a lakehouse. And the lakehouse is, in the lakehouse, data, the more static data is stored. And because we need this data for our planning, this data is also through a shortcut connected to the event house. So we can get the data from the lakehouse in the event house as well. And then there is one more thing in Fabric which is used, which is the data agent. Marcel, can you tell us a little bit about the data agent in Fabric?
Yes. So data agent was introduced, very new into Fabric, and the idea is that you have an agent where you can talk and basically chat with your data. And so we will see it also in an example. So you can basically create a new data agent. You can define which data sources, which tables the data agent has access to. And then you can also give the instructions, what the data agent is allowed to do and what he should do, etc. So like, you define basically the agent based on text, and then you connect it to your data sets, and then you can talk to your data. And so we will see it in an example how this is going to look like. And I think it's a very good and easy way also in case of these service scenarios where people just maybe have a question and just want to get an answer, and not that somebody is building a report just for answering a question.
And the good thing about this is, as you know, from all of these chatbots, all of the LLMs and all of these agents, is you can just put in your query in plain language, right? And it will be, and you don't have to, not only have to do not reporting stuff like this, you also don't have to write some query languages like SQL or KQL or stuff like this, right?
Yes. So very easy to access without knowing exactly query and data structures and all those things.
Exactly. You would ask the data agent exactly the same way you would ask Copilot or ChatGPT or some other thing, and it will just retrieve data from the data sources which is connected to. But Marcel, there are also boxes which are not in Fabric. What is this?
Yeah, so on the one hand side, on the top right side, you see, and we will introduce it a little bit later, we also have an MCP server in our architecture, which gives us the possibility to also connect external tools with our data sets and our events house. In this case, we have an example with Claude Desktop. It can be any other kind of chat tool that you probably want to use, or any other application. So like it represents an application that also wants to access our data in the event house. And in order to do this, you can connect this also through an MCP server. And then on the right-hand side, on the bottom, you will see that we will also create a bike dispatch agent. And the reason is that the data agent is basically just a chat agent, but it cannot do something. So but we want the dispatch agent, that the dispatch agent is calling the dispatching system and is creating a request. So we want the agent actually do something for us and not just chat. And for that, we will use AI Foundry in order to build an agent that is connected to our data agent, so that we can leverage the data. But then this will also do some activities in order to create and connect to the dispatch system.
Exactly.
So I think with that, we introduced the whole architecture. We will now dive into all the puzzle pieces. We will also show some demos for you. And I think we first start to give an overview quickly about what is Fabric for the ones of you who probably not have used Fabric yet. So Frank will guide us a little bit through what is Fabric all about and what is the big thing about Fabric.
Okay, so if you think about normal or about former solutions for data analytics, right? If you build them from scratch, from all these different components like ingestion pipelines, like probably Databricks, like something like Informatica, all of this, it was a very cumbersome and very, very hard task, because you have all these moving pieces and everything, and you have to be an expert in all of these technologies, right, Marcel? And to just change this, Microsoft thought about a solution where they are building analytical platform as a software as a service approach. As you might know, software as a service approach is that you are not concerned too much with the technical foundation. The only thing you are concerned with is your how to analyze your data. And whenever you are building stuff in Microsoft Fabric, you will see that that exactly this software as a service approach is carried out, because all the heavy lifting, how everything is connected to each other and stuff like this, all of this is done behind the covers. So the most complicated thing to put in if you create a Fabric item is to put in a name. So there are not, in comparison, for example, with the Azure SQL database or something like this, if you create an Azure SQL database, you have so many options like the size and all of this. Maybe you all know of this, right? And in Fabric, if you create an item, you just put in the name. So Fabric, under one roof, has all of the different tools you need in an analytical platform. And a very, very important thing as well is it also has a common foundation for everything. So you can see this at the bottom of the slide, where we see the Fabric platform. There are 3 or more or less 4 things Fabric is dependent on. First of all, Fabric is dependent on the OneLake. The idea behind this is you have a common data lake for all the workloads where the data is stored only once, because you know that there could be some problems, right? If you store data more than one copy, because the data gets stalled and maybe you don't know which is the current version of the data, stuff like this, right? And so the idea is to store data only once in the OneLake, and the OneLake is the foundation on all of the Fabric workloads where the data is. Then there is an integration to Microsoft Purview, right? And Microsoft Purview is used for compliance and for governance. And as you know, if you store information about, or if you store data, company data within an analytical platform, there might be some confidential data, and there are certain rules for this data. And this all can be, on the one hand, enforced, and on the other hand, also monitored with Microsoft Purview. You might know Microsoft Purview from M365, where you could use Purview for all of these compliance things with all the files you have in SharePoint and you have in Teams, right? The other thing is, as in these days, is this AI thing, right? So, oh, can you still hear me?
Yes, I can still hear you.
Okay, yeah, well, my headphones died for some reason. Anyway, so so the other thing is that in Microsoft Fabric, there's one thing Microsoft Fabric is also dependent on, which is Entra ID, right? Everything, all the permissions and everything is dependent on Entra ID, which is the security foundation for this. And there is AI built into this as well on different things. So there are some AIs which are more like helper AIs who help you to write queries, to write KQL stuff or SQL stuff like this. And on the other hand, and this is what Marcel already said, is there is also AI like data agents who help you to make sense of your data which is in your database. And a little bit on the symbols at the top. So first of all, we have Data Factory, which is all the tooling you need to ingest data into this platform. Because if you want to analyze data, first of all, what you have to do is you have to bring the data into the platform, right? Then we have analytics. Analytics is about making sense of the data. And in this case, analytics is more like for example, notebooks, where you have some Python code or Scala or SQL code in a notebook, and this notebook then is used to just process the data. Then we have another thing which was announced and published last year, which is databases. So databases in Fabric is that you can run your relational workload, maybe your SQL Server or something, in Fabric, in a database. And the big advantage on this against running SQL Server as Azure SQL Database, for example, is that all of the data which is in the database and all of the changes will be directly reflected to the OneLake. So if you run your SQL Server database as a backend for a website or CM system or something like this directly in Fabric, then all of the data will automatically be pushed down to the OneLake, which is pretty cool. The other thing is, and this is one thing we will talk a little bit more about, is real-time intelligence. This is about data streaming. And I think, Marcel, I will not tell too much about this because we have a slide on this anyway. Yes. And the last thing you have in Fabric is Power BI. And I don't think that Power BI is the most common thing on this slide. So I don't think we have to spend too much on Power BI. Maybe for everyone who never has heard about Power BI is a very good visualization tool that Microsoft was publishing 10 years ago, and that was really much developed and much involved from there on, right? So let's go to the slide and let's see what real-time intelligence is all about. So real-time intelligence is a low-code, no-code solution which you can use for data streaming. So what you do is, in real-time intelligence, your data stream will be modeled as an event stream. You can see this exactly on the left, where Marcel is pointing with the laser pointer. This is an event stream, and the event stream, you can connect a streaming data source to this event stream, and then you can process the data in the event stream. For example, what you can do is you can do filtering, you can do aggregation, stuff like this. And then what you can do then is you can send this data either directly to the activator, which is on the very right side, right? The activator is a tool which is able to detect patterns in your data and then is able to act on this. So, for example, if it detects that some temperature is surpassing a certain value or is lower than a certain value, it can do things like send an email, send a Teams message, and what is really cool, and this is where all the power in this is, you could just use it for a Power Automate flow. right? Which is really pretty cool because, you know, Power Automate is a very, very versatile tool. And so you can, most of the things you can do with Power Automate and can build very complex solutions. The other thing, if you go the upper pass, then the data is not persisted. The data is not stored. The data will be sent to the activator. Activator will evaluate it, will do some actions or will do no actions depending on what the data is. And then the data will be gone. If you want to persist the data, then we have the lower pass. In the lower pass there is a thing which is called event house. Event house is like a container for KQL databases. KQL databases are time series databases who were invented by Microsoft. They are very capable because they were invented in the context of Azure log files, right? To store Azure log files, so they can cope with a really, really big amount of data. And data from the event stream, if I stream it into the event house, then data can be persisted in the KQL databases which are in there. There are two more things on this. One thing are the KQL query sets on the left. The KQL query sets is like a collection of queries which are stored within a KQL database and which can be used for collaboration, right? So people can collaborate on this. And the other thing, and this is something we will show you a little bit further down the road as well, is there are real-time dashboards. Real-time dashboards are dashboards which are used for showing the real-time data, which is the streaming data live. You can think about maybe a real-time dashboard, think about a factory floor. And on this factory floor, there are these big screens, and the big screens show how the data is or how the plant is processing right now at the moment. And this is something you can do with real-time dashboards, and you can do this much better than with Power BI because the real-time dashboard is a different technology. It's not Power BI, and it is and the purpose how it was developed was exactly for this case to show real-time data, right? Okay, so let's move on and let's see. Exactly. Data streams and dashboards. So what you could do in Fabric is you can model your data flow, and this is how our data flows. And maybe we explain a little bit about this. So going, starting on the left and going to the right. So what we do on the very left is we extract the weather data. So there is the Open Meteo API, which is an open API for weather data. And we just get some weather data every 15 minutes from this. And the data there is data in there about current weather status and historical weather status, and there is also forecast in it because we need the forecast to see, okay, maybe even if there is a big concert, right, and probably if it is raining, then maybe not so many people go by bike, but maybe more go by Uber or something like this. And this is streamed through our streaming event stream for the weather data. This is streamed into the event house, which you can see in the middle, right? Then we have our bike data on the top, which is also streamed to our event house and which is then also analyzed, right? What we have at the bottom is the load event data. This is data, this is actual data from Ticketmaster. Ticketmaster is an API as well. And we get from this Ticketmaster API, we get current events which are happening in London. And this, because this data is not as volatile as the streaming data, this data is just stored in a lakehouse. Because usually, if we're thinking about streaming data solutions, usually it is that you have some streaming data. And on the other end, you have more static data, like think about streaming data from devices. In the streaming data, there will be something like a device ID. And in the more static data, like a lakehouse or a warehouse, there is more information about the devices, because if you have a device with device ID 123, then this device is not very likely to change, for example, X vendor or something like this. So this information is not delivered through the data stream. This information is more or less stored as master data or something in a more static database like a lakehouse. And then from the we have two things we use here. One thing is a real-time dashboard. So this is where we visualize the data, where you can see, okay, this is how the temperature was, these are the events, and this is where the bikes are. And the other thing is the event planning agent. So because this is the main point of the whole structure, is that we send this real-time data to the event planning agent, so the event planning agent can then distribute the bikes through the bike dispatch system. Okay.
All right. So then I will do a short demo in order to show you how this gonna looks like in reality.
This will be awesome.
Here you can see the overview of what Frank already explained, and I will quickly also jump into some pieces so you have an understanding how this is going to look like. So for example, this is here how the event stream is getting the bike events and stream it to our event house. So on the one hand side, we have the data sources, and so you can see here we have the different bike point IDs, the streets where the bike points are, then the area in London, and then longitude, latitude, number of bikes, number of empty stocks. So all the information that are necessary that we get from the bike points. And then this is then streamed. And here we also can add some additional fields. So this is what Frank explained, where we can also do some manipulations on top of our data stream. And then we store it back in our lakehouse. And then you also have here some data insights where you can look and say, okay, how many events are streamed over time? And so you see here that we have a very constant stream running through the whole day. So, and then the other one is what Frank said, is that we have here the weather data. The weather data is more a Python notebook where we are querying then all the information, and then we send it to an event house. And then here in the weather data, so we are getting this data from the event hub where this data is sent to, and then so we're connecting here to our event hub, and then we are taking the data, we manipulate it a bit, and then we store it also in our event house. And so when we go back to our overview here, so these are the different streams, and then this is our event house. And when you go to the event house, what you can see here is then some statistics. Yeah, so how many days are streamed, so how many events are streamed over the time, how many events are ingested, what are the top users of the event house, how many storage is consumed, how many how's the compression rate, how's the query usage, etc. And we can also dig into and open one of our databases where we store our events, and there you can see here how events are ingested over time. You get statistics so that you really can monitor the whole thing that is real time and live. And then we have the different tables.
The thing is, you see some gaps in this, because this is only in the demo environment. This is not running constantly. So this is why you see sometimes some spikes where data is ingested. This is when the demo environment is online, right? And otherwise, when we don't do talks, when we don't do demos, then this demo environment is off. So then we don't ingest any data.
Yes, very, very true. So we don't run it the whole weeks. So we just turned it on here, as you see, on Thursday, and so we did something on Friday, and then it's also running today. So in the last 3 days, we were loading some data for you. And I think what's more interesting here also is then when we look into our dashboards. So let me open up one of those. So we have here the real-time dashboard. So for example, I can open up here the one for our bikes. And so you can build this reports on your own as well. And so what we do here is now we can build filters here into our dashboards. Like currently we have here a filter on the different neighborhoods. So for example, I'm interested into West End, for example, and then you see that the map is also filtered into the area of West End. You see here the stations, so like pointed into the map. So this is then Little Argyle Street, where we have the station number 116, and there are 16 bikes available. And here we have a different station with 17 bikes available. So I think very interactive here. You can also change the time frame. So currently we're looking at the availabilities in the last hours. And here you also have a detailed view on the different bike points. So like how how are the availabilities here as a table over the different bike points and stations, and also like what was the maximum of bikes that were available in each street. So a lot of analytics that you can do here on those dashboards. And additionally, that is the last thing here, that is what Frank was talking about, is the query set, where you can also run some queries on top of your data. So for example, here we can say, okay, what is the number of available bikes currently in West End? And it's 18.9.
Exactly.
So, and then I think we went through most of the topics here, so that you have an understanding how this demo environment is structured, the different data streams we showed you, how we also querying the weather data, how it's then stored in the event house, how you can do analytics on top, and then you have the real-time dashboard. And so this is basically how we defined and set up the environment. And now we want to go more into the understanding of like, what is that with those agents, and how can you build agents? What are they actually, and how do I use them? Which will bring us to our next section, talking about agents. So what do we want to achieve with agents? So as we put here the picture again, so like this is our whole basically flow, our process, how we want to do bike dispatching. And we are now looking in the middle box. So like on the one hand side, we want to look on those data agents. How can I create a data agent? How can I use a data agent? And then how can I build a dispatch agent on top that is building basically a dispatch plan? And I will show you also the difference between the possibilities of an agent that can do activities and the normal data agent. So first of all, what is an agent? So on the one hand side, an agent has three different capabilities. The agent can reason. So this means like if you are asking the agent or typing or talking basically to your agent, and talking can be really in these days a voice. It can be text. So it can be any kind of input that you can give to an agent, which is basically has an underlying large language model underneath, so that it can understand basically the context and also what you want the agent to do. And then additionally, and I think that's the difference also between an agent and a large language model, an agent can act. So it can actually do something. And normally in a large language model, you give some input in and you get some input out, but it doesn't actually do something. And what we want from an agent is, for example, that we give an agent a task, and then the agent is acting in our interest and also fulfill the task. And then also agents can learn. So like they can learn on the context. They understand that from the history, from the context window. They can also learn what you are giving the agent. So for example, if you're getting some results and you're not happy with the results, and then you refine how the agent, for example, should act with your data, then the agent will learn those instructions and then use it over time. So also agents, as we humans, can get smarter. So how this going to look like? So on the one hand side, we have this reasoning. So you basically say you want, so for example, approve a condition. And then so the agent need to understand like, what is the context here? It needs to understand like, okay, are the conditions met? And then the agent can approve or deny certain things. An agent can act, for example. So like you give a phone call to an agent and then you say, okay, create a support ticket for me. And then at the end, the agent is opening a support ticket and creates the support ticket in the system. And the learning part, as I said, like you can also say, I want to increase the volume. So then the agent needs to understand what to do. So for example, you can say, create a dashboard for me, and then it creates a dashboard for you. Or it can also learn the context where you say, oh, what do you really mean by creating a dashboard? How should the dashboard look like? What kind of structure you want? What kind of style you want to use? So when you're asking for the next dashboard, then this is already pre-known. And so the agent will create the next dashboard in the same style as the previous dashboard. Okay, so how is then an agent structured? So as I said, like an agent is more than just a large language model. So an agent has a large language model underneath because this is the basis and the foundation how we can talk basically and interact with agents. So this is how agents also understand the context. So they use large language models. And so on the left-hand side, you can see that the agent, make a pointer here. So you can provide different kind of input. It can be events, it can be messages, it can be messages from other agents. So it doesn't need to be only users, so humans talking to agents. They can be also agents talking to agents. So you can really build a chain of agents. I will explain this in a little moment. And then you give agents instructions, so what agents really can do. And agents have context and can use tools. So in order to do an activity, an agent needs to have access to the tools. And you basically, when you create an agent, you define what kind of access agents have to data. So tools can be also data sources, it can be databases or whatever. And tools can be also tools like a calculator. So like you can say, okay, you can, if somebody is asking you to solve a problem, you are allowed a mathematical problem, you are allowed to use a calculator in order to solve that problem. And then the agent has access to those tools, and then it will use also those tools in context of the instructions to fulfill the task. And at the end, you get an output. So the output can be a message or some voice, or it can be also a tools result. So in our case, what we will create as an output is an email message that is simulated as the API call to our dispatching system. So, and with that, I quickly go back to our architecture so that we understand where we are currently are and what we will look into. So as we did before, we explained you the Fabric environment with all the data sources, the event house and the lake house. And now we will look into those data agents, how I can define an agent, and how I can use those agents. So with that, I go back to our demo environment, and I have here bike planning agent. And so the first thing when you create an agent, so you basically go into Fabric and say I create an agent, and then you have two aspects. So like on the right hand side, you can give the agent instructions. So what you can do here is, for example, you define what the agent is basically, what the agent should do. So in my case, I zoom in a bit. In my case, I said you are an agent supporting me in bike distribution. You find live data in the following tables. Additionally, you can find weather data in other tables. So, and then event data and the silver event. So I basically tell the agent what the agent should do and which kind of tables and data the agent should use in his context. And because sometimes your tables have strange column names and other information, you can further describe also the tables. So for example, here, and this then helps the agent to understand if I just talk in the normal language. So for example, when I say, okay, what are the number of bikes? The agent need to understand that the information of number of bikes is stored in a column no_bikes. And when I ask for empty docking stations, so the agent need to understand that this information can be found in that column. And in order to help the agent finding the right information, I can give introduction about the data sources that I connected to my agent. And this is what I do here. So I do here introduction about the event hub database, so the bike information, the bike event table, and then the weather forecast table. And in my lakehouse, I have the events stored. And so I also give the agent some introduction about the lakehouse table. And on the right-hand side, you can see that the agent is only allowed to connect to certain tables. So in this case, in my event house, the agent is only allowed to connect to the transformed tables of the events and to the silver weather forecast. So it should not access all the other tables. And in my lakehouse, the agent is only allowed to talk and query the silver event table. So this is basically how I build the agent. Yeah. So I can connect the agent to data sources. I choose the data sources. I describe the agent, and I give some instructions about the data sources, so it's easier for the agent to find the correct information for me. And that's basically it. And then I can use that agent. So for example, I can say, hello, what can you do for me? And then the agent say, okay, I can support you with related tasks to bike distributions here in London. That's where I can help you with providing live data about bike rentals, availabilities, usage trends, etc. And say, okay, that's great. So for example, I can say how many bikes are currently available in West End. So, and the interesting thing is that here the agent needs to understand that West End is a neighborhood, and then how many bikes, that it needs to query a certain table structure. And this is what you see here. So it understands that, aha, Marcel is asking for bike availabilities. So it will look to my event house, and it says there are currently 72 bikes available in West End. And here it automatically breaks it down by bike station and bike points. And you can also check what the agent basically did. And when we open up this command here, you can see this is the query that the agent basically created in order to fulfill and answer that question. And then you can also check from your side, so like, is the query correct? Does it make sense at all? You can also run the query on the database, but you always have the control about how the agent came to that information and what has been used. So you also always see the query, but on the other side, if you are not able to query KQL, then it's a very easy way for you, because you can just talk and the agent will answer. So what else can we ask the agent? So I prepared some other queries, so I can just copy them from the here. So for example, I can say, what is the weather forecast in West End for today? And then the agent, again, it connects to my event house. It will query my weather forecast table, and then I will get an information about temperature and rain. So you will see, like, starting around 11 degrees early in the morning, and then it goes up today until 16 degrees by midday. There is no rain expected, and so there's light wind. And what we can also do is, what is the weather forecast for West End for, let's say, 3 p.m. So in 15 minutes, and then the agent also understands, aha, now I need to query a very specific event in the table. And again, here also I get a very specific information, like how is the weather forecast exactly at 3 p.m. So a very easy way. Yeah.
The cool thing on
you can
this
see
that it
the
is
complex query. Go ahead, Frank.
The cool thing is that it is working on the streaming data, because the thing is that the agent, what the agent needs for his reasoning and also for his for its decision making is it needs current data, because if the agent wants to do this bike dispatchal, right, there is no use if the agent knows the weather from a week ago or something like this, right? And this is a cool thing about this whole demo.
Yes, and so let's come to the point where we say, okay, now we want the agent to plan something. So what we ask the agent to say, okay, there is a big live concert tomorrow in West End, and we are expecting more than 50,000 visitors. We expect that 10% of the attendees want to use a bike after that event. And now the question is, like, how should we best distribute the bikes to be prepared for the event? So I can ask the agent, and then the agent will basically check, okay, what bike stations are around West End, what is the availability of bikes, and then it will make a suggestion how we should distribute the bikes, basically. So here's the answer with more than 50,000 visitors, etc., etc. And then I get a suggestion about the availabilities of the stations around, and then also I get some recommendations. So like, the forecast is demanding 5,000 bikes, but there are currently only 74 available. So and so I get some hints about how I should do this and how I should distribute it, but it doesn't basically does not the distribution for me. So I basically get some help and some hints, and now I still have to manually do it. Yeah, and so go into the system and do some plannings. So and that is also then the limitation of this data agent. It cannot do something. And now let's have a look like how we can use agents that also do something. And what we also want to do is like how we can use, for example, external applications to talk to our data. So that's why I will quickly introduce MCP servers. So MCP server, and what does MCP mean? MCP means a model context protocol. So that is basically becoming more or less the standard for integrating tools with agents. And tools can be, as I said, like external data sources or any kind of tool, API, application, or whatever. And so the MCP server is a very lightweight program, and it exposes capabilities. So basically, when I write an MCP server for my system, I define the capabilities that the MCP server is offering and the clients can use. And there are two ways how you can communicate with MCP servers. So you can use it with standard input-output that runs on a client server on the same machine, or you can host it somewhere and then you have a conversation or you have a connection over HTTP. So these are the two possibilities, and how you can imagine MCP server is like this. It's like the docking stations that you also see, for example, in laptops. So like on the one hand side, you have different applications like Gmail or Google Calendars or Slack, and now you want to access those, and so they are basically represented here as USB cables. And how can I connect to certain USB cables? I have a hub in between that I connect to my laptop, and then I can talk to all those applications via my MCP server. And so all those applications there can offer the MCP servers, and then I can connect to different MCP servers and then offer my agent different possibilities. So like all the agents that I build, I connect them to the MCP server. I want them to be connected, and then they can leverage the possibilities, which is a very easy way to build different agents for different capabilities. And in order to showcase this, we have an example here where we want to use the Fabric RTI server that is available via GitHub. So you can go to the GitHub repo and try it out yourself. And what it can actually do, it has 12 tools available that are provided by the server currently. So you can basically say, I want to list all my tables. You can run queries, you can run command, you can list databases. So things like get the databases in my event house, sample the top 10 rows, etc. pp. So there's a lot of things how you can explore your data also outside of Fabric. And this is what we want to quickly show you in a short demo where we have our RTI server running, and then we have Claude Desktop connected, and you will see that you can also interact with your data in a different way instead of using data agents. But at the end, it's the same result.
Exactly, and we use Claude Desktop because Claude Desktop is very easily to be connected to a local MCP server. So this is the only reason why we use it.
Yes, so we currently have the MCP server here running locally, and then I have a config file in Claude Desktop, and I connect the Claude Desktop with my local MCP server. And then also here, I can do some queries. So for example, it's okay, list all my tables in my event house. So, and then here also there, Claude Desktop tries to understand the context. So it understands, aha, Marcel wants to have event house tables. So I probably connect to the Fabric toolbox. So it's basically integrated here as a toolbox. And then it uses the Fabric MCP server. And so you can also always see what basically the chatbot is doing. So at the one hand side, it reads the services from the MCP server. then it will list the databases from the MCP server, and then it will list the tables. So these are basically the functions that the MCP server is offering. And so within a minute, I get the results that these are currently the tables that are in my event house database. And then what I can do here, for example, I can say, okay, how many rows are stored in, let's say, Bronx weather? So, and then again, it runs a query. Also there, I can open the query and always see like, okay, what kind of query is loaded against which server. And then you see, okay, currently I have 24,800 rows of data in the table. And also here I can say how many bikes are available in West End. And also there, then it understands the schema, it understands the context that West End is a neighborhood, and it will also get then the information for me. So you can see like, I can see that this information I can get from the bike event transformed. It has a column neighborhood and a column number of bikes, and then these are used in a query. And so you can also here see like this is the query that the agent sends to my backend. And so you always have that context of understanding. And then you see, okay, give him a second. We will get the total number of bikes. And currently there are 81 bikes available, and you get a breakdown here by stations. And for example, what we do, already prepared here, but I will definitely still want to show it. We did basically the same. And then at the end we say, okay, we want a visualization of that information. And what those chatbots also can do is it can create some nice charts for me. So I just say, okay, I want the visualization, and then here I get a nice breakdown for West End with the available bikes. So these are just 40 because I won it some days ago. And so these are the total stations, the capacity, utilization rate. I get here a graph chart, etc. So very nice and easy way. If I want to do quickly some ad hoc queries or have some ad hoc questions, and so there is no need for an IT department, just for some queries to build reports or dashboards for business users. So it's a very good way also to utilize those for ad hoc queries or ad hoc requests to data.
What's cool about this MCP server is the MCP server, you can imagine like the glue between, on the one hand, the versatility of a large language model and the precision of a database.
Mm-hmm.
Because it will, if you do it like this, it will not make up numbers.
Right. And so you always have the power and control to check those numbers.
Yes, exactly.
Some people are concerned about that agents make up certain things. And so you're always in control and can double check what is really running behind this. So now I think we have 5 minutes left. And what is left to do is that we say, okay, we want to build our agent that is really doing some actions. So first, we just saw 2 agents that connect to our data sets and where we can chat with our data. But now we want to additionally create an agent that is basically connected to our bike distribution system. And it's not just giving a plan, but it's actually connecting to the system and sends API requests or whatever. So automating the whole thing of distribution. And the way we can build agents in Azure are 3 ways. So on the one hand side, we have this infrastructure as a service, so where you basically just, Microsoft will provide the AI infrastructure for you, so GPUs, LLMs, all those things, but then you build it on your own frameworks. So you can use open source frameworks, but you have to do all the heavy lifting with scalability, VMs, hosting, all that stuff. Then in the middle side, we have platform as a service. So we have a product called AI Foundry that you can leverage, and AI Foundry has an agent service, and I will quickly show you how easy it is to also build agents in there. And then additionally, we have also a software as a service offering that is more easier for business users, where you can have a drag and drop possibility with Copilot Studio, very easy way how you can also build agents in the no-code environment. So how is that built in AI Foundry? So on the one hand side, AI Foundry offers a model catalog. So we have more than 11,000 models that you can leverage in AI Foundry. So all different models that are state of the art today. Then there is this Foundry agent service. This is what we will have a look today. And there are other services that I skip for now that you can use additionally. So like all the AI search, other AI services for vision, for speech, for language recognition, all those things, as well as machine learning and the whole aspects of content safety, responsible AI, all those stuffs. So what we will do in this case, there are two different kind of agents that you can build. So like on the one hand side, these are connected agents, and this is what we will exactly do. We will connect, we will build an agent on top of our data agent, because the data agent already understands our data. So it's connected to our data, it's connected to our tables, and we also already introduced a lot of things that this agent already knows. So it has a very well understanding of our data structures, and we want to reuse that. Of course, you can also build agents of other agents that are connected to, for example, MCP servers, or you can also build these multi-agent workflows. And there are specific frameworks like semantic kernel that you can use for that, so that you can really have also chain of control or chain of activities where agents will talk to agents, and then where you can really build complex workflows behind. So we will go to this connected agent, and in order to do this, let's have a look. So what we will do is like we will create this bike dispatch agent that will talk to the data agent and then send out a request to the bike dispatch system. So how do we do this? So what we have here is AI Foundry, and in AI Foundry, we have something called agents. And what we do here is we already have a predefined agent called My Bike Agent, and I can quickly open that up. And it's the same kind of experience as you already had in the data agent. So like you basically give an introduction, not an introduction, an instruction to that agent. You can also choose the model that you want to use. In our case, we use GPT-4o. So like all the input that I get or that I give to the agent will use that model in order to understand the context and what I want from that agent. And what I also tell the agent is when I ask the agent to send the plan, then it will actually create, it will send an email. And so what we have in our agent is, on the one hand side, we have our connected data agent that is used as knowledge for that agent. And we have two actions. So like in our case, we have the create bike dispatch request. And so in that case, this is Logic app, and this Logic app will send an email to our system. So, and now we can try it in a playground. So I open up here, and then again, I can say, hello, what can you do for me? And also here, like the agent tells me that it helps me in bike distribution, analyzing information about distribution data, etc. And what we now want to do is we basically give the agent the same task as we did before to our data agent. So we say tomorrow is a big live event in Westin. There are 50,000 people, 10% want to use a bike. So how should we distribute it for the event? And then I can send that information again to the agent. And also here you will see that it will create a strategy, and then it will connect to the Fabric agent in order to collect the real-time information from our database, so that the agent understands how many bikes are currently available in the different bike stations over here. And it generates then the response. Give them 1 or 2 minutes. Okay. So, and here is, for example, the distribution of the different bikes and how it will distribute it to the system. And it does do the bike allocation plan for me and some observations. And at the next step, it can also send the information to the bike distribution system. So I can say, okay, send the plan, send the allocation plan to my bike distribution system. And then the agent will trigger the logic app in order to whether call my API for my distribution system, or in our case, the logic app sends an email. So, and what you always can see here in the thread log is also what is happening, what is basically the agent doing. So you see here, for example, the different steps and the different tools that are called. So for example, here you see, okay, it runs a step and then it creates the data agent. And then you also can say what is the input that this agent is giving the data agent. And then you can see the output of the data agent, etc. So you can really step by step step through the whole chain of process here in order to understand what is the agent basically doing, how is the agent calling other agents, what is the result. So you always have the understanding and control what's happening behind the scenes. And then when we go to our email system, then you see, okay, we got the new email, and this is the distribution plan that the agent has sent to us. As Frank said, in our case, it's just an email where we simulate it, but it could be also an API call, and then it sends this as a JSON to our system. So I think with that, we are really on time with our presentation. So thank you for all your interest. And if you have further questions, you have all our contact details. And I don't know, Frank, you have some final words?
No, thank you very much for attending this talk. Have a nice rest of the conference. And as Marcel already said, if you have any questions, please just feel free to reach out to us on LinkedIn. I think we are really easy to find there. And on the other hand, thanks, Charlie, for hosting us, right?
Well, thank you very much, gentlemen. That was a great session. Such actually a well-rounded demo environment, actually, with all of the bikes and the different things interacting together. Very, very well presented and well done. Thank you very much to the both of you. Well coordinated between you two as well. So hats off and a round of applause to you both. That was very presented very, very well. I will actually mention in this case that if you have any additional points you would like to make, feel free, because we are running a little bit late in terms of our next speaker. So I don't know, maybe give us some other experiences or things that maybe you've seen within using RTI or MCP server and these sorts of things that maybe you think could be of benefit.
Yeah, so
are there any other points?
Yeah, well, maybe one point, and maybe I will teaser something that Marcel and I was talking about, is because if you think of all of this things and of all of these moving parts and of all this technology which was combined, we are at the moment heavily thinking about maybe offering this as a pre-con at some conference or something like this, where people actually can build this, because you know, Charlie, that there are so many moving parts and so many things we stitch together. Because what we, for example, were not talking about is how the data is processed within the within the KQL database, right? Because within the KQL database we have this medallion architecture where streaming data is then augmented through some other data, through the data from the data lake, for example, stuff like this, right? There is so much in this, but on the other hand, and this is something when Marcel and me sat down, I don't know, Marcel, we did this in spring somehow, right? When we were talking about this, right? And we were thinking about this, and we were thinking, okay, we have these two different things. Like on the one hand, the real-time intelligence for really giving us on demand or current data. On the other hand, we have these agents, and agents to do good reasoning, they need current data, because as said before, if you have data from last week, then what is the reason for this for the agent? Because the agent will act now, and as Marcel already said, it is about that the agent will execute stuff. right? And the agent cannot execute or cannot do good execution or can execute good stuff if it has stored data, right? So I think this is a very interesting combination on this. And Marcel and me, we will definitely be more on this topic again, because I think this is a very emerging topic at the moment.
Fair enough.
Right.
That would be I think I'd be happy to register for a pre-con on that sort of thing myself.
Yes. And I think also maybe last thing from my side, what we announced last week at the FabCon is also a hosted MCP server in Fabric.
Yes.
So there is no need anymore to do it on your own, because we know like hosting it in Visual Studio Code is one thing, but really, I don't know, building it in a container, security, or the thing is hard work. And so this setup here is nice for demos, but you would not probably do this for production workloads. But this heavy lifting is now done by the product group. So we have now a preview of MCP server hosted in Fabric already.
Exactly. So as Marcel said, so this is only for demoing. And I think if you think about an enterprise environment, there is no way that you run an MCP server locally or something like this, right? But it's all so the point we wanted to make in this talk was to show, okay, this is possible, like a proof of concept, right? Where we have all this technology, and where we, as Marcel already said, where we say, okay, but if we want to bring this into production, we have to think about other things like security and stuff.
Okay.
But at least it can be done.
Okay, cool. I mean, that Git repository that you showed earlier as well, but also something that could be leveraged for, sort of trying out the different capabilities.
Yeah, what do you mean, Charlie?
I think you showed a Git repository earlier on with some of the content that you were using for this in this case. Is that also something that could be leveraged? Just to get a handle on things, because you said that the MCP server is in preview and these sorts of things. Are there other Git repositories which help from that perspective?
Yes, so like there is in the slide deck that we shared afterwards, there is the Git repository of the Fabric MCP server that is running outside of Fabric. So like basically give you also an understanding, like maybe. So I think that the interesting part with Agent is this is now, I think, the way that you want to communicate. Oh, no, he's gone. Are we still live? I think so. So hopefully, so
we are probably will.
When you want to connect certain applications, then the agent also needs to talk to applications. And I think that is the other challenges of many companies, that they say, okay, I have great backend systems, but how can I make backend systems available to agents? And so like they probably don't have an API. They are legacy code, and so they are not web-based. And so like the MCP service, I think, is a great way to also open up applications to agents, so that you are able within companies to talk to backend systems. And I think that's a very interesting way. As always, like in the agent space, everything is new, and then but MCP is now widely adopted. So you can basically say it's the de facto standard now to doing that. So I think it's a very interesting concept, not only for Fabric, but also for all other backend applications that you want to open up to agents.
So this is like as an alternative to using shortcuts and mirroring sort of capabilities in your current data sets that are in maybe Azure or different clouds, for example.
Yes, for example.
Or similar, are you saying that it's a similar approach in terms of connecting those data sets or repositories to the MCP server?
Yeah, I think it goes even further. So like basically, as I said, like when you have a full backend system, like, I don't know, your HR system or your booking system or whatever, your marketing system, and then you want agents, I don't know, sending out emails for you, like a marketing event or some announcements, etc. So like, how can you do the automation? And so in that regards, the agent needs to somehow connect to your backend system. Normally you're using REST APIs, but what if your backend system is not offering any REST APIs? And so like there is the possibility to use MCP servers in between as basically a connector to your backend system, and now everyone can basically build those connectors and then open up systems so that they are connectable and that they can connect to each other, and that you can do automation in a more better and easier way. And so that's why I think we have this guidance there, but there are plenty of other guidance, like GitHub has MCP servers, Azure has MCP servers, so you can also talk to Azure basically and say, okay, do the automation for me, create a database for me. So like all the Azure automation, you can now talk to an MCP server, so you can use GitHub Copilot and just chat with GitHub Copilot, and GitHub Copilot will use the MCP server of Azure in order to deploy things for you.
Exactly. And the other thing is, what's also important is that if you do it this way, so you could say, okay, why wouldn't we do some automation on this, right? With PowerShell, something like this. The thing is, what this agent technology brings us is it not only brings reasoning, but also decision making. So usually if you have a straight programming, right, you have to think about all the different things or all the different status that can happen, right? And then you have to just program this yourself. And I think you know what I'm talking about, Charlie, right? But on the other hand, if you have an agent who is doing reasoning and who is doing decision making, right, the agent can also handle unknown situations, right? Because you cannot in the real world, you cannot have built an algorithm which will cope everything, right? Because there will always be something which is happening which you didn't foresight, right? And this is a big advantage of this technology.
So it's able to find the gaps and help you plug them even if you don't have the experience yourself at the moment. Very interesting. Great. Well, thank you very much, gents. You gave so much more information actually as well.
Thank you for having us and hosting us. And
thanks for having us. Exactly.
Thank you very much.
Wishing everyone a great conference, and so then we give it to the next presenter. And so have a great day. Have a great Saturday. Thank you, Charlie, and then welcome, John. And so having a good next one. See you.
Thank you very much. Thank you both for all the great presenting. Ciao. As you can see here, we've actually got John on the line now here too. Welcome, John.
I didn't get a link. I'm sorry.
Oh no, all good, all good.
I was pinging like Frank. I'm like, Frank, let me link, and you finally showed up. I'm like, oh, I need to talk to Charlie. So I'm all sweaty because I'm nervous.
Thank
like,
God.
Oh my God, I can't get in.
Thank God for LinkedIn messaging. So that actually caught us in the end, helping us to get through.
I appreciate it. Thank you.
So
okay, I know I'm late. So do you want me to get right into it?
Yes, I can. I think, are you sharing the right screen? How many screens do you have?
This is the screen, and I will start with the slides.
Okay, great. I'll share that to you now. Here we go. And onto the right one. Nope, not the one. It is this one.
Yes, and I will be doing some demos, so I'll be swapping. But for now, good morning, everyone. My name's John Miner. I am a data architect at Insight. I've been there almost 8 years. I'm also a 10-time MVP. And I'd like to thank DataBash for having me talk today. And I'll be talking about file formats for the Fabric Lakehouse. Charlie, did you want to say any words before I get into the presentation?
Yeah, just that I think you're sharing a different screen to what you might be wanting to share. It's not the presentation, it's the preview.
You're not seeing the slide deck? Hang on.
That's right. Maybe it's the other screen you should be sharing.
Okay, so what are you seeing? Right there is everything, right? Yep. And then what I was going to do is I was sharing this screen right here. Do you see that screen?
That's the PowerPoint deck.
Yep, PowerPoint. Yep, that's what I was doing.
The outline in there instead of and that's now the preview screen of the PowerPoint.
Okay, so I will hide the presenter view.
Yeah.
And is that good? Awesome.
That's perfect. Perfect.
That's what I was going to say. So I'll start again. That way we'll cut out the bloopers and you'll have it. So thank you, DataBash, for having me talk today. My name's John Miner. I'm a data architect at Insight. I've been here 8 years. My email's below. I've been fortunate enough to have the MVP award awarded to me 10 times. And with that said, I'm going to be talking about file formats for the Fabric Lakehouse. The Fabric Lakehouse is just basically Apache Spark. And I've been doing that for the last 7 years. And so we're going to get into a bunch of different file formats. Purpose. Is Fabric really old? And I would say not really. Like if you look at SQL Server, it's 25 years old. I've been doing, basic programming since the 80s, right? But it went to availability in November of 2023. So they're still making changes. We're going to talk about how we can leverage this new service to solve business problems, right? And we don't always get data in a nice format. Sometimes we get it in a CSV, sometimes we get it in a zip file. So how do we do that, right? we're going to go quickly over, the architectural designs, Lakehouse, data warehouse, data science in real time, and then we'll dive deep right into the Fabric Lakehouse and file formats, okay? So here's the topics. We want an overview of the Spark system, right? And what can we do with it, right? We also want to know what's a medallion architecture. Everyone's using medallion. You say, well, what's that? It's like kind of like the Olympics. You got gold, bronze, and silver, and it represents quality, right? Bronze, or your royal layer, is data as is. You got it in from the vendor. You copied it over using a data pipeline or ADF, whatever you use in the mechanism, Fivetran into the lake, right? And guess what? We want to take it and we look at it and we say, hey, there's duplicates or there's a bad address. We're going to fix it. That just Silva. So you're going to do some transition, and that's called refining the data, right? So we find the address, but we might not need everything in the address to actually make a model to report, right? The semantic layer. And so that's your goal layer, okay? We're also going to talk about the difference between weak and strong file formats, okay? We're also going to talk about when transferring stuff, right? If you got a gigabyte and you have to transfer it up, that's a gigabyte moving across the wire, right? But if it's, say, a big text file, right, or a JSON file, and we zip it up and we get 80% compression, guess what? It's a lot less to move to the cloud, okay? Last but not least, we'll talk about the file formats, and if we have time, we'll talk about how to work with RDBMS. Charlie, do I have the full 55 minutes, or do you want me to end on time? If so, I'll throw out some demos. Okay, so what is Spark? Spark is a unified processing engine that can analyze big data using SQL. Okay, it can also do machine learning. It can do graph processing and real-time streaming analytics, okay? So this screen I'm showing you right here, okay, is a diagram that came from Databricks, okay? So Databricks actually came up the Delta file format. We'll talk about that shortly. So what's in the left-hand corner, this is where I live, SQL and data frames. This is data engineering, right? Machine learning, what can you do with that? You can predict the future. Like, hey, in the future, if I want to do a regression, right, analysis, maybe I would say, hey, given cut, clarity, and color of a diamond, how much is going to cost me, right? Or anomaly detection. So that's all the stuff. We're not talking about augmented, okay, agentic AI. We're talking about traditional AI. Also streaming, what is that? Well, a lot of times we had things like a message queue from IBM. That was back in 2000, right? And a lot of people did that. And now we have Kafka compliant, right? So you have Event Hub, it gets messages and JSON that's streaming. How do we land those in the data lake and consume them? And last but not least, solving graph problems, which is totally out of scope for today. So let's talk about the Spark cluster. This is going to be obfuscated. So I probably should stop removing these slides from my presentation, but it's good to know what's behind the scenes, okay? Even with Databricks is going serverless, Fabric is serverless, okay? You don't get to pick the size. It's like you got a couple pre-sizes that you can set in maybe the Spark settings, okay? But other than that, that's it, okay? So behind the scenes, Fabric's going to worry about how to execute it, but if you want to get into details of Apache Spark and how does it work, well, there's something called the driver node. It's a JVM. And it has some memory. And what it does is it takes your program, parses it, and from that parsing of the program, it has to run it. And what it does is it gets Java bytecode and it puts it on executors, okay? So the main thing is partitioning. See right here, there's 8 slots for tasks, okay? And if I partition by 8 and I ran it, it would take 1 rep to run through the files, right? Now, if I had 10 and I partition it by 8, would run 8 at one time. That would be 1 task. And then we'd have to run another 2, right? So you can see it's really important to try to fill up your executors when executing. Otherwise, you might be wasting time, okay? Let's talk about Data Hub and what it was in the past and what it is now. So Apache Spark's not nothing, it's not a brand new product or a concept, right? The data lake, right? In the past, what we used to do is we used to create something called an operational data source. And what is that? Or a data warehouse. And basically, an ODS was we took different sources and put it into one database. We cleaned it up. Your staging might be your raw, your refine might be your active tables, right? Maybe you have a mart, which is your model. That's that dimensional model. But again, this is all the same thing. And then we'd have consumers, different ones, like maybe Cognos or Power BI come and read it. That's the past, right? Nowadays, the same things with the data lake. The main thing I want to tell you is garbage in, garbage out, right? So if you want it to be the single source of truth, you have to clean up the garbage. How do you do that? Do data quality checks when you do data engineering. And the question is, you have to come up with a pattern of how you're going to fix the data. Do I go back to the source and fix it, or do I clean it up in the hub? I would say go back to the source, because then eventually both systems will be in sync, okay? So medallion architecture, this is a picture from Microsoft. And how does a medallion architecture work? Well, we have to get the data into that bronze/raw, okay? And there's two ways to do it. We can use pipelines, okay? Pipeline's a data pipeline, and the copy activity is the main one, or shortcuts. Shortcuts is this new way in which we put information, okay, of where the file will live. So it could be in S3 Amazon bucket, it could be a GCP bucket, it could be an Amazon storage. That is awesome, right? Once we have that, okay, information, what it does is when we say, hey, select star from all the files or a given file on that shortcut, it goes and reaches out and grabs it. Now, you'd say, well, John, that's kind of inefficient, because, what happened if I need the data all the time? Well, if it's less than a gigabyte, you can turn on caching and it'll be cached all the time. So once you get into bronze, right, there's different ways to get it across, right? We'll probably be using Spark jobs, okay, notebooks, or data flows, okay? And again, silver's your refine, gold's your final. And there's a new thing out there, and we're not going to talk about it. I'm just going to mention it. Direct Lake. What is Direct Lake? In the past, we had to import data into our semantic model. Direct Lake is one of those things in which the Parquet sits in the medallion architecture and kind of just trickle loads the memory, okay? And a lot of people are doing a combination of Direct Lake and import. So you import, okay, your dimensions, and then you trickle in your facts, because the facts are always changing. That's why you want that real-time update. There's some rules about how to use Direct Lake too. So look at the Microsoft documentation. There's some limitations, like for instance, you can't do calculated columns. You have to do that through data engineering, not in Power BI, like Power Query or the DAX. Okay. Let's talk about file types. There's two types of files: a weak file and a strong file. What is a weak file? It's something that can be broken, right? So CSV, I can open it up. Maybe it's confidential data. I don't want someone to see it, right? It's really easy. You got a notepad, you're in, right? I can add an extra column that suddenly breaks. Can I petition it? Yeah, I can, but it's not really giving me much, right? And is there any compression? Does it make it smaller? Well, CSV is one of the formats I call bloat format. It just bloats up, right? Because you got all these commas and quotes and all that stuff you don't need. And the data is not binary, right? So it's just text, okay? What is a strong file? It's just the opposite. Like, for instance, Apache file, which is the basis for Delta tables, okay, is stored as a binary file. And another thing is, I forgot to mention, is with the CSV, what is the header? It might not have headers, so we have to give it a schema. If it does have headers, right, how do I know what the data type is? SSN. Well, okay, I search through SSN, and this is how Excel does it. It goes through the CSV file, goes from top to bottom, and it searches it and says, oh yeah, guess what? It's a number. But maybe I'm in a foreign country and it's a national number and it uses characters, alphanumerics, right? Then guess what? It's a combination of both. You can't store it as that. So I'd guess at the wrong data file, okay? So basically, strong data types fix all the problems that weak data types have. They're usually binary, like Apache is. It uses a column store, so it's compressed. It can be petitioned. It also has column names and column types that are set in stone, okay? Okay, you know what I'm going to do is, since I know I'm late to this, I'm going to go through all the different formats and maybe 3 or 4, and then we'll switch to demo time, okay? So one of the things we talked about is zipping up something before transporting, right? So the One Lake storage, what is it? It's still based upon Azure Data Lake Storage Gen 2, okay? There's a no-code solution to zip up the files locally. You can do that manually. and upload it, or you can use data pipelines, right? You can, on the other side, make sure it's up there and do a binary copy once you did this. That's one way to solve it, okay? Delimited files. This is the one that, there's so much of it out there. We're not going to get away from delimited files. I see it all the time. I talk to clients and they're like, oh yeah, we got our whole system based on Excel files and CSV. I'm like, oh, great. Again, the header is optional. If it's not supplied, you should define a schema regardless, because you don't want to infer. Inferring means it has to go through the whole file. If it's a gigabyte file, it has to read everything before it gives you the data types, okay? We're going to talk about two ways to ingest them. There's a shortcut notation when writing to Spark, and there's also the spark.read, okay? And that has a lot more to it, okay? You can have string quotation, you can have a choice delimiter, you can give it a header, you can give it a schema. And there's two ways to create tables. There's something called a managed table and an unmanaged table. Unmanaged table means that you're basically giving Apache Hive, which is your table, okay, saying here's the schema on read. When you read the Apache, say a Parquet file, here's the schema, or a CSV file. Managed table says, hey, guess what? We're going to read it in and save it as a Delta file format. Now, what's the big difference? When you drop, okay, an unmanaged table, the data is still there. When you drop a managed table, because we read it in and saved it as a different format, it goes away. Managed tables are the only ones that can be used by the SQL Analytic Endpoint and Semantic Model, so I suggest that's what you use in Fabric. Okay, I'll do one more slide deck and we'll do some demos. Okay, text files, and again, this is the fallback. Some files are just unstructured or semi-structured or weird structured. For instance, we're looking at a pipe delimited file that might be rag-ended, meaning like for NASA, right? This has the NASA website data, okay? So how can we extract the data from the file? By parsing each row, okay? And during parsing, unwanted rows are tossed and rows with interesting data are consumed. So this is basically finding the needle in a haystack, okay? So let's do some demos. Okay, and I'm gonna go here. Nope. Okay, get rid of this. Get rid of that. I'm going to go here. Go portal. Okay, so when we log in, we have to pick account to log in. Okay, why am I going to Azure? I just want to show you something really quickly before we go into Fabric. Every Fabric has to have some type of capacity, okay? So I turned mine on. It's a SKU of F16, okay? Remember, okay, if it's a test environment, you can turn it off. If I left it on a whole month, it's going to cost me $2 grand, okay? That's a lot of money. But if I only use it a few hours, or, I have a logic app that turns it off in the dev environment after 8 hours, guess what? I save a lot of money, right? It's one third of this, okay? So less than $1,000. About 600 and change, right? Okay, so how do we get in Fabric? app.fabric.com. There's different experiences. It defaulted to Power BI, so I'm going to change that once I get in. I'll show you what that means. Okay, so I'm in. See this Power BI? That's not experience I want to do. I want to do the Fabric experience, okay? And I want to look through workspaces, and there should be a workspace called file types, okay? What is a workspace? This is like Power BI on premise. A workspace basically is a container, okay? And if you see this, diamond here, this means it's backed by that compute. So if we go to settings, okay, we can see if we go to license information, we can see that capacity at F16 that's backing. What is it? The capacity. The capacity is just some compute and memory for Fabric to work. Remember, it's shared. So if I ran a report and at the same time doing data engineering, that capacity is shared, okay? So that's important. I'm not going to talk about how to monitor that, but it's something that you should look in the future at if you're going to go into Fabric, because you might overwhelm your capacity, okay? And then you have problems. Remember I also said there's Spark settings? Well, if we go to Spark configuration, there you go. See, it's a medium-sized node, and you can look up what that means, right? And there's the number of cores, so we can customize it. Just remember, we can also do something called endpoints. When you do an endpoint, then we can't use starter pools. Starter pools are awesome because they're they're hot. They just come up like this, okay? If you don't use a starter pool, then you have to spin it up, and that may take 2 or 3 minutes, okay? We can also create environments. There's a couple environments here, one for a connection to Postgres, another connection to SQL Server. And, you know, we can do high concurrency and so on. So you can look at all these settings. I just wanted to show you where it is, okay? So we can clear the Hive tables. All this is, again, working on this lakehouse right here. So if we click the lakehouse, and you can see breadcrumbs start showing down here. You know, what's funny is that always constantly change an interface. I noticed that the interface changed again. We have all these ones right here, right? We got some Postgres, we got some text files, we got some CSV files, we got some JSON files, right? So what I can do is I can go to that first notebook, and I'm going to go to my workspace. Whoops. I think it's here. Okay, they're changing the interface again. Okay, so Fabric, go back to the workspace. We can see it. And we're going to go to clear Hive tables. So what this is going to do is going to drop those tables I built in the past, right? So I'm going to say if it's not equal to server and it's not equal to PGP, we're just going to go through and get a list. And again, what is a notebook? It's just, you can have different types of notebooks, okay? This happens to be a PySpark notebook. If you want to really save money, you could do Python and use products like DuckDB or Delta Table Framework to write to a Delta file, and you could use anything to read it up. Any of the Spark libraries like OS library, CSV library, Excel library. Why would you want to do a Python library? If it's a very small data, a lot of people think they have big data, and it can fit into 2 vCores and 16 I think it's megabytes or gigabytes of memory. No one uses megabytes nowadays. You can use this, and it's really small. It'll save you a lot of money. For instance, the F16, right? I have 16 cores. So if I went ahead and ran, say, like a data flow, then that would chew up 8. But if I used a Python notebook, it might only chew up 2. This cluster, starter cluster, it might chew up 8 again. Again, we can look at it. It says it's not connected yet, okay? So now the first thing is once we get into the notebook, we need to start it. So we're going to say new high concurrency can be shared between 2. I'm going to use just a standard session to show you how it starts up. See the bottom, it's starting up, and we can see session ready. And the session ready is, oh yeah, it's Delta runtime. And you can see this is the notebook, and that's the controller, and it's idle, okay? So it's already sitting there waiting for me. Since this code is just comments, it runs, sends it to the Spark cluster, says, hey, go do something. And the cluster is going to come back and say, hey, yeah, I don't really need to do anything because it's a comment. This one says, hey, show me the tables, collect the tables into a list. And for each table in the list, if it's not equal to SQL Server or PGP, right? And again, we have to always tie this to this. All these ones other than that, like JSON, the Parquet, all that's going to go away. So let's run this and see what happens. Now, because I'm doing print statements here, it's going to show here. Anytime we do something that could fail, like for instance, a drop table or a drop view. So I first try to drop a view table. If it's not a table, I try to drop the view because tables and views are anonymous. Okay, that's a bug they haven't fixed. You can create a view in, you know, the Fabric warehouse. I'm at Lakehouse, but the problem is it will not show up in a SQL endpoint, as well as it won't show up in Explorer, which was one of my pet peeves. Because back in Synapse, you could see it in Explorer. So right now it's dropping everything. So now if we come back here, we always, this is almost like, you know, Explorer and SSMS. You hit refresh. You know, it's going to do, hey, I saved the PGP files, right? So this is PostgreSQL, and this is the pubs database. You can see DBO authors to titles. It's been saved. Okay, so now we cleared out our workspace. We can go ahead and do some examples. So we go back to the workspace. They changed the interface again. I'm going to have to get used to it. Okay, so manage zip files. I am going to skip this one, but I'm going to go into showing you what it does, right? So we can see, hey, if there is any all data or Parquet data for, you know, stock data, then remove it. So you can see file/lakehouse/default. That is files here. even the tables of files, and you can look at them, right? Because they added this new feature. You can look at the locations, right? This is used to, I don't know if it's this view that you can see. It might be the warehouse. These are basically locations to files, right? And you can see it through the CLI. But we can see this is going to stocks, right? And under stocks, if we click on this, we can see we create Avro, CSV, an ARC file, a Parquet file, and a zip file, okay? Like I said, we don't have not enough time to do this one. This demo takes about 3 minutes every time I execute it, and I have to execute it a couple times. But I'm going to go over the code because you probably want to work with zip files. Like I said, they're easy to copy up. If you on-premise have a database, you're dumping data, say into CSV, it's a lot of file data or JSON, and you want to bring it up, you zip it up, and then guess what? You can unzip it. So what's the easiest way to unzip? The zip file format is compatible with the Lakehouse. So we just go ahead and put the path in, tell it's archive, and say what zip file, extract all. And suddenly, if we go back to this example and show you the file, it would suddenly take this zip file and open up the CSV. Now the Avro, the ARC, and the Parquet, I think the Parquet is in there too. I created, right? Okay, so we can see it came here, and this is a file execution. So you can see that I did execute the Parquet and zipped it in the CSV. Okay, so that works. It's easy enough. Here's your code. It's in. Oh yeah, the biggest thing I want to show you also is GitHub. If you go to my community work, all these examples are free of charge out there. So just go down and go to understanding file formats, right? And we go to code, and guess what? All those things I'm showing you, the IPython notebooks, okay? And they can be sucked right in this and say, you know, go into here and say import. When you import, it'll bring it right into Fabric, okay? So that's how you unzip. How do you zip up, okay? Well, first and foremost, we have to talk about mounts. Mounts, okay, there's a default mount, okay? So that's lakehouse.default, it's default. But in reality, behind the scenes, if we were actually curious, maybe we want to use Azure Storage Explorer, we would go over here and we can see this Storage Explorer. This is the fully qualified Azure Blob File Storage System, okay? DFS, okay? And we can see that would be the path we'd put right into Storage Explorer. If you're more interested about that, go look at MS SQL Tips. I put a bunch of articles out there. So how do we unzip or zip up, right? We did unzip, zip. It's a little more complicated. The problem is that by default, we're dealing with storage that's virtual, not real storage. So we have to kind of like read it up like we did, put it in memory, and do a single write out. We can't write and append like we would do normally, okay? So first thing we do is we need to write a function called get file list. And this basically takes a pattern and a path, uses the Spark utils, and it uses a filter on the FM match to return a list of files. Once we get the files, see, we can see, hey, get list files of CSV. We got 1, 2, 3, 4, 5 files in the stocks data. Okay, so if we go to stocks and move it out, I think it's this one, MFS, right? And we're going to make this archive. So how do we do that? We got the list. Okay, there's another function we're going to create, which is called zip up files. We give it a pattern, a folder, and an archive file. And what it's going to do is going to say files.folder and pattern. It's going to get that list initially. Then what it's going to do, it's going to create a memory buffer. Okay. And in that memory buffer, know what's going to do, it's going to deflate. And for each of the files we have, we're going to read and create it to IO bytes and then write to the buffer. Once we're done and have everything collated in memory, okay, we're just going to write out the file. So do you see a problem with this? Again, we said 16 gig. So if we get a zip that's bigger than 16 gigabytes, we're going to use up all our memory, right? But more than likely, most of them are not going to be that big. Last but not least, how do we test it? Pass it the folder. So I want to get everything from MSFT, anything that's a CSV, and create an archive in the same folder, okay? So that's how we do zip files. That's the one demo I'm not going to do because now you always want to stop and close. And the reason why in Monitor, if you didn't, okay, see, this says it's in progress. You're using up that memory. I only have so much, right? So this should be eventually canceling this. So I'll do cancel. This should be yes. They should have canceled. I don't know why. Maybe this one will come back as canceled in progress. So cancel. Yes, stop. Hopefully that goes away. Okay, so now I got all my memory back. If I didn't, and I had all these sessions still open, okay, it would be problematic on how far I could go without blowing up, okay? So going back to our workspaces, fabric types. Okay, let's talk about CSVs. We'll definitely do these demos because these are quick. So what's the quickest way? Well, we know stocks is there, and there's a shortcut. We can do select star from CSV file, stocks, all stock data, and voila, we can run that, okay? And it shows the column headers, but there's no name to those. Why is that? Because it doesn't know what it is. We didn't pass a schema, okay? We can also do the similar thing. We can go file is equal to all stock data, do spark.read, print schema, and again, I'm going to start a connection while we're talking about this. And again, it has no name because we didn't pass the schema. So let's talk about creating a managed table. The first one we want to do is create this managed table. So we're going to drop if exist. And again, I'm switching between different types of code. This is a Python notebook. We didn't use a markdown. If we do %% SQL, that means that we're doing Spark SQL. So I could put this all into a statement and do spark.sql, and it would run it. So that's what the %SQL does. It just replaces that command. And we can see now that we dropped the table. We're using the same thing, but for each one, we're taking the name and we're casting it to the data type that we want, and then we're saving it. And we can also say, hey, limit 1,000, right? And then this one right here, we say drop the table, create table using. So let's go back to this one. Let's use 1,000 because I don't have all day to do this. Let's see if that makes it go faster. Okay, and if you're curious, you click here, guess what? You can see everything that's going on with Spark, what it's doing and everything. And there's ways in which you can actually go to this monitor. We can see this, and if we click into it, right, we can view details, and then application, we can see this, right? And then run series, we can go into the application name. I don't know if this is going to bring us into Spark. We'll see. There's a back end that'll get you into the Spark, Apache Spark. Nope, it's bringing me back to the notebook. Oh, yeah, it is. So we can see how it ran. Like this is in progress right now. And we can see each of the Scala program. Because remember, unless you're using a native compile engine, which was recompiled using like C++, this is going ahead and running in traditional Apache Spark, which is in Scala. So we can see Scala is running. We can see, remember I told you there's tasks and jobs. We can see, 0, 1 task succeeded. There's 29 and it's running it, right? And if we click into the actual one and we keep on delving, again, this is all internal stuff. You don't need to know it. This is your typical Apache Spark. We can see, oh yeah, guess what? I got a pool, right? And then guess what? I have 2 nodes, right? Stage 1, stage 2, 0, 27, right? Succeeded. We can hit refresh again, see if this comes up. So it's still working. We can look at the DAG. What did it come up with the code? Remember I said I had to do bytecode? It's going to scan the CSV. Then it's going to collect the limit. It's going to exchange it, and it's going to do a delta write. Okay, so that's what it's working behind the scenes. Let's close all this. And again, this is the URL. If you're curious, I will go here and put it in comments so you can grab the code. Apologize for the messed up screen. Don't need to know about the turtles. We can go back to, this is, it should be, Nope, it's not this one because I got rid of that one, right? Okay, this is where I was doing. Okay, so this guy's there. Okay, so we're back, and it took 58 seconds. So that's good, because initially it said 1:42 if I had to run the whole job. I only, oops, it's running again. Sorry. Okay, so, oh crap. 1 minute. Hit the wrong button. So again, let's talk about the next one. Once we have it, we can describe it. Okay. So remember, we underscored everything, right? And we created, like, for instance, the first one's a date, the next two are integers. So we can see, oh yeah, it's a date, integers, and a nullable. We can also see details in the catalog, for instance, the location. This is all Hive data, okay? But again, you know, it's built upon, Fabric's built upon Apache Spark, which is built upon Hadoop's way back when, which is Hive, right? So we can, once this finishes, we'll select and we can see that the data is there, right? So it looks good. Got some data, got some volume, right? So let's do limit 1,000. And let's see if this comes back. I think it just finished. Nope, almost. Okay, it's back. So now we can select from here. And we can look, we created a table, right? We wrote. So now if we go ahead and hit refresh, we should have our first table. We do. So example 1. Okay, different way. We can do something called using CSV. Well, you think one last thing to talk about, I almost forgot. See, this is managed. That means I drop it, goes away, the data's gone. This one's going to, you can, anytime you see using, it's going to create an unmanaged one. Okay. And we're saying infer schema and telling it, hey, there's a header line. Okay. How do we get rid of that header line here? We basically said where the first line is not equal to date for cell because we know date is the first item. Okay. So that's how we get rid of the header line. We did example 1, we're on example 2. So let's go back down. One of the things I want to show you is this, is that if there's no close here, I don't see any that will match. There's no volume of close. It could be a dividend, and those things we might want to throw out, right? We talked about cleaning up stuff in Silvit, right? So this one's still running. So instead of going all the details, we can just look, oh, just finished 27-7. How many rows? That's how many rows it read in. We took a look at it. It's 34 million. That's a lot. Look at the first 5, and we can look at the first 5, and we'll get the same details we had before. We look at the table, show the data. Okay, so it's there, trusted service, and now we can see it's external. Okay, last thing, what we can do is we can create a custom schema. We can say, hey, files.stock, all files.stock, and then we can load it up, read it using this schema. And again, I'm using a DLL schema, and then write it as a table, okay? And then if we show the metadata, we can show it's managed. I'm going to skip this example because that example took like almost, if you saw what it took, it's 4 minutes. I don't know if it'll take that long, but I will skip that. This one, what does this one do? Takes examples 1 and 2, and what I'm going to do is I'm just going to modify it real quickly because I don't want any issues with the missing table that I didn't recreate this time. I don't have enough time to run the whole examples, so I'm skipping a few. And we can see, regardless if it's a managed or unmanaged table, right, we should have the same record count. Oops, we don't, because guess what? I only did 100,000, okay, or what was it, 10,000. Okay, so let's go on to the next example. So we're going to close this one, stop and close, and that should free up our monitor. Okay, we can go look in a minute. And now we can go here, and what we're going to do. See, this was, you always have to go back here. This is a new thing. Breadcrumbs the workspace, and then you go to the next one. So in that last one, we talked about 3 of them: the zip file, CSV, and now this is text. This one's going to work with the NASA, okay, and that's pretty small, so we should have no problems running them all. So we're going to drop it, and we're going to select from the NASA table. And what do we get? Well, when we get it, let's see, this one's running. Had to start the session. You can see it's pretty quick, right? And then let's see. Nope. Used to have a place down here to tell you how much it's running compute wise, but you can see here. Okay. So still thinking. Okay, this one's running a lot more because there's a bunch, it's a lot of different steps. We could go get the DAG if we were curious about how to optimize it. and we ran it, and we can see it's a managed table because we did drop exist and then create it, right? So now if we hit refresh, I did run that, right? 927, right? Let me hit refresh. Oh, down the bottom, text. Okay. Yep. So manage. So now we're going to create an unmanaged. Well, we're going to use text. Going to run this. Okay. And now we're going to describe it again. And this is going to say external, right? And this means it wouldn't show to the SQL endpoint or Fabric, which is not good. We can also say, hey, give me 10 rows, okay? Now, I love Spark SQL, okay? You can do a lot of different things with it, right? So we can see this pipe delimited, okay? But one of the things we can do is we can do a row number over a common table expression. So what we're going to do is we're going to take the NASA example 1, we're going to add a row number to it. We're going to split it on the pipe and grab the third one. So the third one, if we look at 1, 2, 3, is it a get? Is it a post? Okay, we're going to get the URL. So that's the 5th one. So that's over here is images/horizon.gif or horiz.gif. And then we'll get the response. Well, that one's a 200. Okay, we're going to look for ones that are not 200 and where row count is greater than 1. Okay, because we don't want the header. And let's run it. Okay, so now we can go back and we can see we got a bunch of different responses, right? We got response times, how long it took. We can see which row in the data set. I only grabbed the first 10, but it tells me the 17th row was an error, 302. Okay, and if we do an HTTPS error and then 302, we can find out what it is. And it says found. It says the redirect response code that the requested resource has been temporarily moved. So you got the wrong location, basically. Okay, so cool. So much for text files. Let's go to the demo again. Let me see if there's any questions. I'll put down, hey, John, 15 minutes left. That's it? Oh, man. Okay. I will go back to 45 minutes. Okay, have I been talking a half an hour already? Okay, so let me go write the slides and then we'll get through it. So all the demos of I showed you 3 of them. They're pretty much the same. Let's go through all the file formats and then maybe talk about something that's really interesting. JSON. JavaScript notation is an open standard file format. It uses human readable text to store and transmit data objects. Its name value peers. If you work with REST API, you'll see this. Like all text formats, bloat may occur due to redundant column names. Okay, so you can see these are the types you can use. Apache file. This file is the basis of Delta. It's binary. We talked about column store. You can do rows. It lends itself to partitioning well. So if you're curious, find out more details on this. Okay. Apache Avro. So there's 3 Apache files. Parquet that won out the battle. It's the middle of the road for speed and size. Avro, I think, is the one fastest for speed for reading. Okay. This one, we look at it, was designed for deserialization of remote procedure calls. Okay. So it does use some JSON for the metadata. We can see that here. And the contents are rows. So this is not a column store. This one up here was a column store. This is a row store. Okay. Guess what? Apache Arc files, the smallest format, was designed to fix problems with Hadoop. It's another column row store, okay? And you can do predicate pushdowns, lightweight indexes to keep track of min and maxes, so you can find things like, hey, is it in this column because you got the min and max? If not, guess what? Move on, right? And then this is the most important part, the Delta file format. So I'll go over Delta and then we'll do a bunch of ACID transactions. Make sure it's complete, right? ACID is atomic, consistent, independent, durable. Schema enforcements, you can allow the schema to drift or not. Delta, what is it? A bunch of Parquet files with transaction files. Time travel, what does that allow me to do? Because I'm adding these files, I know what it was 3 days ago. So I could say, show me what the table looked 3 days ago. Now, if you do something called vacuuming and optimization gets rid of anything that was deleted and vacuuming gets rid of files, then you can only go back as far as you vacuumed, okay? Last but not least, multiple readers. remember, writers can have conflicts, especially when updating. So I always want append in its open source format. That's how Microsoft was able to build OneLake, because Databricks had to open source it. Okay. And then a relational data bus. Basically, you want to keep the secrets in the key vault. You need a driver, and you can write functions to read and return a data frame, save the data frame to a new table, and metadata to move pubs to a lakehouse. Okay, and this is the summary. So let's know it really quick, but I'm going to do some examples of each, and hopefully you understand. Okay, so we're here, we got file types, right? So now we're going to click here. One of the things we talked about is explain JSON. So I'm going to do one example of each because I'm running out of time. So drop the table, create table if not exists from JSON, right? So we're going to do this, and we're going to run this. Going to do one of each. And then if we describe it, I'm going to skip over the Avro, the Awk, and the Parquet because they're all the same. We're going to jump right into Delta because it's the most interesting in format, and then we'll wrap up because I got about 4 minutes. I apologize not having a link and getting started late. Also, they were running late, so drop the table, try it exists, and then describe extended. And basically, we can see it's a managed file, and if we run from it, we can see, hey, yeah. Guess what? This is earthquake data and it's nested. So we'd have to explode this as explode command. Take a look at it. Okay. Okay. So we're going to stop this session. And again, like I said, if you don't stop sessions, standard session will keep on running. I suggest that you look up, Parquet, right? This makes the Apache Avro Awk because we didn't have any of those type. We're going to go right to Delta files. And I'm going to show you the main reason why it's really important to understand how Delta files work. Okay, so we're going to connect to a new standard, and then we'll wrap up. So with this, we're going to do pandas. Remember, I said you can do stuff in different notebooks. So we're going to read write the Iris, and Iris is really small. Right, it's only 150 rows, and it was Fisher's Iris data set. It's made for clustering data science. Okay. Okay, cool. So now we have the data. And what we're going to do is we're going to create a Delta table. We can create it by just using a crate. And it will create it as default. And we can select it, and there's not going to be any rows, okay? At this point, we're going to have an empty table, and then we're going to load it twice. I'm going to show you one way it takes forever. We'll cancel it or probably just let it go, and then I'll show you a quicker way to do it. And then we'll wrap up. Please take a look at the one for data engineering for relational databases. I'll also find a link. This has been done before. It's not my first time presenting it. It might be the first time presenting it for DataBash. And I'll definitely put it out there. So we basically created this blank table, right? And now we can see, oh, remember I told you history? It says create table. Okay, great. So we're going to write a function, process row, insert into. So we're going to do this iteratively. And then we're going to say, okay, process row, and then apply. So this is a function, right? And we're going to apply this to process row. So, okay, this is going to run it. Let's see how long this takes. This is going to take a while because what's happening now is for those 150 rows, well, see, we're running an actual row per each one. That's crazy, right? So we're creating a single Parquet file and a single JSON file. Okay, so this is why when you're using a warehouse or you're using a lake house, do not do things as singletons, right? It's the warehousing technique. It's always been out there. Always do things in big batches. We want to do a big update, want to do a big delete, want to do a big insert, right? You can see right now, this has to go through 150 times. Did I put the 3 minutes? So it's going to run 3 minutes, okay? Because it's going to run 3 minutes, let me see if I can cancel this because I'm going to run out of time and I want to show you something. So let's see. Can I cancel this? Cancel. Okay. So it ran. So what we're going to do is this would describe history. It's not gonna, it didn't run them all, but we can see it ran 23 versions. That was a long time to do that. Okay, let's redo this, but use a smarter technique. We're gonna import from Delta tables. Remember I said Delta table library, create a data frame. Okay, we're gonna read it in for path of the Delta, right? We're going to go ahead and if it's there, match all or insert all. Okay, that's it. So let's run it. The other one ran for what? Ran for, it was canceled. Doesn't tell me how long it ran, but it was like 10 to 15 seconds and it didn't finish, right? And this one, in the ultimate for 150 rows takes 3 minutes, right? This one, let's see how long it takes. This one said 4 seconds. I do not know why it's taken so long. It could be because I didn't truncate the table. Don't know. It says rerun step 2. Oh, yeah. See, I should have reran it. So cancel cell. Okay, rerun step 2. So rerun step 2 is this guy. So I'm an idiot. Can't read my own notes. And then we'll wrap up. And I apologize going over for 2 minutes, but this is a really important fact of Delta tables because you do not want to use, again, repeat singleton inserts, and we'll wrap up and I'll be done in 2 more minutes. Thank you, Charlie. Okay, so if we go down here and we run this now, again, hopefully it takes a couple seconds and then we'll wrap up.
You could take your time.
I'm going to let this run 9 seconds. So the other one took 3 minutes. It took 9 seconds. And guess what? We can run it and everything will be here. So to wrap up, summary. Again, I apologize being late. I will put the link to a full video out there so you can get the whole experience. Microsoft Fabric is the one-stop shop for all your data and analytical needs. As a developer, you can pick an architecture, Lakehouse, Warehouse, machine learning. Kusto is the real-time. What I didn't show you is Copilot. So you can do Copilot to help you code some of these things. In the past, you had to have an F64Q SKU, which is about $8K a month. They lowered that, but guess what? AI takes a lot, right? So you might run out of compute if you're trying to do your data engineering and doing Copilot at the same time, right? There's some bugs out there that still haven't fixed yet, but I'm hoping they do. In fact, if you know SQL, which I've been doing since 1989, Python since like the last 10 years, and Spark, you will be, your future is bright. There's always going to be employment. Last but not least, I'll share a link to my repo, and it has all these references. And thank you for your time. I appreciate DataBash for having me, and you have an awesome weekend.
Thank you very much there, John. Thanks for joining. Thanks for coping with those little technical issues, getting us to get you online as well. I appreciate all the content you went through and how hard it was to actually go through it so quickly. So
no problem. And I will put the link for the YouTube and the GitHub and the link, and you can take me off the panel. Thank you again, everyone, and have a wonderful Saturday.
Thank you. You too. Cheers. Bye. For now.
Cheers.
On the line now also we have Hugo Cornelius. You should see him now on the screen with us.
Hello.
Take John off there so that he can also relax. Hello there, Hugo. So we are hitting now the last session of the conference. So thank you very much for helping us wrap this up, Hugo, on a technical level, which is great. It's we've actually had a lot of good technical sessions today. So a message to everyone there: feel free to go through and look at our YouTube channel, where we're going to be posting all of these videos as well after the event. What I'll do right now is I'll add Hugo's screen to the slides to the screen. So Hugo, feel free to take it away. It's all yours.
Thank you, Charlie. And a small apology for the not exactly ideal sound quality right now. I have a perfect microphone that gives me perfect sound quality, but my USB ports seem to be a bit overburdened. When I plug in everything I need, it fails. So I'm now using the built-in microphone with my webcam.
Well, sounds good to me, Hugo, so no worries there at all.
I am a perfectionist. I'm sorry for that. Anyway, I think I still have 56 minutes left. Let's try to wrap up in time. I'm famous for going over time, but let's try not to today. Let's talk about execution plans. And just to make sure that everyone understands what we're going to do today, this is an absolute beginner level session. This is not advanced. This is not mind-blowing level 500 stuff. This is getting started, as the name suggests, an introduction to execution plans. Let me first introduce myself briefly. My name is Hugo Cornelis and I make SQLServerFast.com, which is a website I set up many years ago for one specific reason. I love execution plans and I'm completely enthusiastic about all the improvements Microsoft have been making for year after year after year to everything in execution plans. With every new major version, things get better. There's only one thing that Microsoft seems to have completely forgotten, and that is to document it. So instead of whining and bitching about it, I set out to do it myself. I bought the domain SQLServerFast.com and I set up the execution plan reference, where you can find all the details you want to know and probably a lot of things you rather wouldn't have known about all the operators in the execution plan and other relevant information. Everything about execution plans is collected there. Your ultimate resource. As a reference, it's not a good place to start learning. So when people ask me, can you do something to help me get along? Someone gave me the idea to videotape my pre-con. And I thought I can do even better than that. Instead of creating a video of my pre-con where I feel very time constrained, I'm going to create a long set of videos where I am not time constrained. At this time, it's somewhere between 9 and 10 hours of content. There's much more coming. It will probably be around 20 hours when I'm completely finished. And all those videos are available either for free or for a very moderate price for you to watch and learn from. If you think moderate price is too high, and honestly, who doesn't, then I can offer you a 10% discount if you use the code SEP2025, which despite its name is actually valid throughout October as well. Any purchase made in that period with this code will give you a 10% discount. Or if you ever attended or plan to attend one of my pre-cons, you can get a 20% discount code, and that code is not time constrained. It will remain valid always. On my website, you also will find a link to my YouTube channel where I have many recorded conference talks, such as previous deliveries of this session. So we're a bit short on time. I actually have like 75 minutes of material in my slide deck and demo code. We won't be able to cover everything. I know that, but that's why I have links to recorded conference talks, so you can watch the longer version later. I also have a lot of other stuff on my website. Not really important. What matters really to you is that if you want to see the slide deck of this presentation or use the demo code to play around for yourself, you can. Just go to SQLServerFast.com. In the menu, click Other Presentations, then Presentation Resources. You will find a list of all my conference talks. Just click one. You see a short description. You scroll down a bit. You will find a link to download an archive with the slide deck and all the demo code. And if I know of any recordings, either made by myself or made by others that are available, then you will also find links to those recordings. I do a lot of more stuff. I even try to make money nowadays, every now and then, but that's not what you're here for. That's not what you care about. So the only thing you really need to remember about me is this, my email and my Blue Sky. For the record, if you have any questions today while I'm talking, just drop them in chat. Charlie is online. He will watch chat for me. And Charlie, if there are questions, don't hold them until the end. Just interrupt me. I like to take questions as they are asked. So just interrupt me with any relevant questions. But perhaps you're watching the recording later. Or perhaps you're watching now, but your mind is already completely full and you need time to digest, and the question comes up later. That's why I have my email and my Blue Sky on the screen. Please drop me a message if you have a question that is in any way relevant to the things I do in the community. I am more than happy to help. Sometimes my mail gets a bit swamped. It happens. And I'm only human. I might overlook your mail in all the other mails that promise to sell me all kind of fantastic things. Not personal if I don't answer to you, just swamped email. So if you don't have a reply within a week or so, just send me a reminder. Okay? Can we agree on that? Then let's now jump into the actual presentation. Execution plans. Where do I start? But before we do that, the first question is, why should I care? Now, you're here, you're watching this, so you probably already have a hunch, but I'm going to go over it anyway, so we're all on the same page, and so you can also convince your co-workers and managers why execution plans are relevant. Once I have hopefully fully convinced you that execution plans are the best thing since sliced bread, you want to know where to find them, and once we have found them, you want to know how to read them. So we'll cover that. Then we'll also talk briefly about properties and why they are very relevant in the context of execution plans. And hopefully I will have left some time to run at least one of the two examples that I have at the end. But let's start at the start. Why are execution plans relevant? And to understand that, you have to understand that SQL Server, or rather the language SQL in general, is not a traditional third generation language like C#, C++, Visual Basic, and many more. All those third generations traditional languages are procedural. And you might want to compare that to how I see my morning routine. And that is like the alarm rings, I utter some phrases that I will not repeat on camera, I hit the snooze button, I try to go to sleep again, the alarm goes again, I utter more redacted phrases, I get out of bed, I go to the bathroom, I jump in the shower, I dry off, I brush my teeth, I go downstairs, I make breakfast, I eat breakfast, I get in the car, I go to the office, and I sit down at my desk and I start browsing. I start working through all the relevant tickets. That is my morning routine. And as you see, it's a step by step. Every step is spelled out what's to do in what order. And there are some choices to be made there. If you paid careful attention, you might have noticed that there is a bug. I never specified that I had to take off my pajamas before going in the shower. Not a good idea. There's also some optimization opportunities. I chose to brush my teeth after the shower. I can also do it before. Or I could take the toothbrush in the shower with me and brush my teeth while I'm showering to save a few seconds. If I want to save more time, I can prepare breakfast the day before and just grab the packed breakfast and eat it while I'm stuck in traffic in the car. Those are options I have to influence the order of things, and that can influence the correctness, but in the context of what we're doing today, can also influence how efficient my morning routine is. Now, in computer terminology, this is basically the same. We tell the computer, do this, and then do that, and then do that. And because we use computers to do repetitive work, we often do that with a loop, where we just do one element and then the next, and just keep repeating until everything is done. That is called an algorithm. The algorithm is how we order the actions to get to the correct results. And it's the developer who chooses the algorithm in a third generation language. And that means that if the code runs slow, we know who to blame, the developer. They wrote the code, they can change it so that it's fast. But SQL is not a third generation language. SQL is a fourth generation language which gives a description of the requested result. So going back to my morning routine, the SQL variant of that is how my boss thinks about my morning routine. She might send me a text message saying, "Hey Hugo, we have an important customer in the office tomorrow, so make sure you are there at 9 and please don't wear that offensive t-shirt again." That is all she tells me. She doesn't care whether I have a packed lunch in my car or whether I set my alarm 1 hour earlier so that I can have a long and romantic breakfast with my wife. She doesn't care whether I brush my teeth before or after or during the shower. It doesn't matter to her. The only thing that matters is that I am there at 9 and not in that offensive shirt. And that is how we work with SQL Server. We write queries that tell SQL Server, this is what we want you to do in a set-based way. But the computer still does things one thing at a time. So there is a thing called the query optimizer, which does all the hard work of looking at the query, my intended result, and working out all the steps to do to get to that result. That is the task of the query optimizer. So it's the query optimizer that chooses the algorithms in this case. And that means that if a query runs slow, we can blame the query optimizer. No, that's not how it works. We, the developer or DBA, still get the blame for slow code. And of course, we can say, hey, it's the query optimizer's fault. But that doesn't help us because we still need to fix it. It's what we are paid to do. And that means that perhaps we want some insight in the algorithms chosen by the query optimizer. But let's first take one small step back, because this slide is all about SQL in generic. This is not specifically for SQL Server. Every relational database that supports SQL has this logic. Specifically for SQL Server, where the T-SQL dialect is used, T-SQL supports a mix of set-based queries and procedural code. And that means that if code is slow, it might be because we are running procedural code where we, the developers, have picked a bad algorithm. Or perhaps the choice to use procedural code is already the problem, because SQL Server is heavily optimized towards set-based code at the expense of procedural code. So if slow code is caused by procedural code, you probably want to replace that procedural code with set-based code if at all possible. That's almost always going to be faster. But sometimes you run into a situation where a single query is slow. Perhaps the entire code is one query and it's slow. Perhaps the entire code is procedural code, but all of it is fast except that single query. Either way, you have one query, it is slow, you want it faster. Apparently, the optimizer picked a slow algorithm. I wanted to pick something else, but I can't if I don't even know what algorithm the optimizer chose. And that is why I care about execution plans, because the execution plan tells me what algorithm was chosen. It even gives me some insight into why that algorithm was chosen. And then I can inspect it and find out why the query was slow. And then I can start thinking about, okay, why did the optimizer pick this and what can I change on the input side for the optimizer so that it will create an execution plan with a faster algorithm. So that's why execution plans are very important. And I hope I have convinced all of you of that now. And now, of course, you want to know, where do I find them? Now, once more, this is a question that, depending on context, has two very different answers. If you are a production DBA on a heavily used server and you get complaints that everything is slow, or you see the CPU constantly at 100 or memory constantly at 100%, there are issues and you want to find who causes this, that is definitely a case of I want to find execution plans. I want to find the execution plans that cause my problems. There are many answers to this question, and I'm going to briefly call them out: Plan Cache, Query Store, Extended Events, Monitoring Tools, various DMVs. None of this is in scope for this session. This is not the side I want to talk about today. These are relevant questions, these are relevant tools, and if you want to know more about the list of tools on the screen right now, hang on until the end. I will show you a page full of resources. One of those resources is a book by Grant Fritchie that covers all of these tools and how you can use them to do your work. But it's not in scope for this session. The case I want to talk about today is you have a specific query. Perhaps you are a production DBA, you use those tools and you found the culprit. You know which query is the problem. Perhaps you are a developer and your DBA enters your office with an angry face and he slaps a printout of a query on your desk and he says, this query is causing problems, and he's angry at you. Or perhaps you're the kind of developer that I personally love. You wrote a query and you decide to look at its performance before even putting it in production. In all those cases, the situation is the same. You have a query, you want to look at its performance, you want to look at the algorithms used, you want to find the execution plan for that query. That's what we're going to talk about today. So let's jump into a demo. And I'm going to tell you, if all my production work, if all my clients ask me to optimize queries that literally call a function called delay, I would be very happy. This is, of course, a simple demo code. This is not intended to be representative. Keep that in mind. I'm just using a very smart, simple, blunt way to make a query run slow. So I am in the right database. I highlight the query, and then there is a button here on top of the screen that is called Display Estimated Execution Plan. Now, I don't like that term. I will come back to that in a bit. It's just the execution plan. If I click this button, I will get a result on the screen that is the execution plan. How to read that is the next step. For now, just trust me. What you see on the bottom side of the screen right now is the execution plan. We didn't run the query. We only got the execution plan. There's also a button here that's called Include Actual Execution Plan. If I click that, nothing happens. Well, except that the button is now highlighted. And if I click it again, it's not highlighted anymore. This button is a toggle. I can switch it on or off. And when it is switched on, if I now hit execute, the query will actually execute. And that will take a bit on my computer. Yes, you see the first results here, but the query is still running. On the bottom of the screen, you see executing query. You see the clock ticking in the bottom right of the screen because the query is still running. Eventually, it will finish. It is finished now. And once it finishes, you will see an extra tab appear on the bottom called Execution Plan. And if I click that, you once more see the execution plan. So this is the second way to get the execution plan. The downside is you have to wait until the query finishes. However, the benefit is you get additional information because this gives you the execution plan plus runtime statistics. So because we executed the query, SQL Server could add additional information in the execution plan about what actually happened when the query executed. And that can help me troubleshoot the slow performance. Now there's one more button I want to highlight, and that is Include Live Query Statistics. This button also is a toggle. I can switch it on and off. When it is switched on and I hit the execute button, you see the execution plan appear instantly, but you also see some runtime statistics that are constantly updated while the query is running. And the query will keep running until I stop it or until it finishes. And once it is finished, because I also had the actual execution plan button enabled, I also get the execution plan with the full runtime statistics. So these are 3 ways to access the execution plan. And if I talk a bit more about them, then it is important to realize how this works. So we have the execution plan. That is only the execution plan and nothing more. It's sometimes called the estimated execution plan, and that is a misleading term because there is nothing estimated about that plan. It is based on estimated row counts because that is how the optimizer works, but the plan itself is not estimated. What happens in this case is we tell the optimizer, hey, here's a query, we want to execute it. Give me an execution plan. The optimizer goes to work, does all it needs to do, collect the information it needs, goes through all the rules it has, and it comes up with what it thinks this is a good enough execution plan. Here is your execution plan. Now you can run the query. We fooled you. We didn't want to run the query at all. We only wanted to know how we would have run it. So the optimizer didn't even know that you're not going to execute the query. The optimizer just does its job to create the best or at least a good enough execution plan. And unless there are specific exceptions related to recompiles, this is how the query will be executed, always. But it wasn't executed. That's why we get this plan very fast. Now the execution plan plus runtime statistics, also called actual execution plan because those runtime statistics describe what actually happened, but the plan itself is the same. There's just more data in there. So the process is the same. Hey, optimizer, here's a query. Do your job. Doing my job. Here's your plan. But now we didn't fool the optimizer. We're actually going to execute that query. And while the query is running, we collect runtime statistics. We stuff that in the execution plan as additional data, and that is then returned to Management Studio. But only once the query has finished executing. And then there is the execution plan with live statistics, very much like my children in the back of the car when they were still young and we were driving to a grandma and granddad. Are we there yet? Are we there yet? Mom, Dad, are we there yet? That is what Management Studio is doing when you ask the execution plan with live statistics. Optimizer, give me a plan. The optimizer does its work. We put the plan on the screen and we start running. And while it's running, we constantly ask, how far are you? And we put that on the screen. This is not the full set of statistics. It's a limited set of statistics. So if you only use the execution plan with live statistics, you get a limited set of statistics. The execution plan plus runtime statistics gives you more and richer information. Why? And that's why for long-running query, I typically include both, because those live statistics give me a chance to already start looking at the execution plan and at what's happening while the query is running. And then once it's finished, I have the full set of runtime statistics available as well. Here is a chart that I'm not going to talk about. It is in the download. You can just look at it if you download the slide deck. A lot of differences between the execution plan only, the execution plan plus, and the live execution plan. Peruse at your own time. I just included it so you have it for the overview. What we want to talk about now is how do you read those execution plans? Because I told you why they're important. I told you where to find them. But so far, it's just a pretty picture. And to start reading this, you have to understand that in this picture, you see two different elements. So the icons, the pictures, represent operators. And an operator is effectively a small program that does one specific task. I'll get back to that later. Then the other element are the arrows, and they represent how data flows between operators. So what we see on the screen is a table scan does something, which results in data being sent to a filter operator, which does something, and then sends data to a select. we already have a start with reading execution plans. It's a very short start, but it's a start. So let's go a bit deeper at those operators, those small programs that do something. Let's look at what they do and rather how they are called. So each operator has 3 entry points or methods or whatever you want to call them, 3 ways in which they can be invoked. One of them is initialize. This call is used when the execution plan starts running, but it can also be used during execution to reinitialize and restart from the top. That might be useful in some specific cases. The most important call is get next. And get next simply is, hey operator, I want a row. That's why it's called get next. Give me the next row. First initialize, then get next, which gives me the first row, and then I do another get next to get the second row, and so on. How the operator produces that row, that depends on what operator is used. Often, that means that that operator also has to call get next on yet other operators because it needs to have its own data from somewhere. And then at the end of work, there's the close call, which is completely uninteresting. It's just, I'm just happy it exists because otherwise we would be leaking memory all the time. The word operator can sometimes be confusing because it's an overloaded term. It means 2 different but related things. So one is the operator as a generic type or class of operators. The text on your screen is a rather technical description taken from the execution plan reference, where I try to be very exact rather than easy to understand. But the easy version of this is the filter operator receives rows from another operator and only passes those that qualify for a specific test. And the rest of the rows are simply discarded. Okay, that's what the filter operator does. This doesn't talk about one specific operator in an execution plan. It talks about all filter operators. So here the word operator describes the class. But operator also describes the instance, a single operator within the class. So we have this class filter operator that describes all operators of the type filter, and then we have the type, this instance filter operator, which is one specific operator of that type. A coworker might ask me to look at her screen and say, hey Hugo, I'm looking at this execution plan and I see 3 filter operators here, here, and here. Now these 2, those are clear. I understand them, no problem with that. But this third one, I don't understand why it's there and what it does. Can you help me? And in this sentence, we were talking about 3 filter operators. Those are 3 instances of that class. Now, the term is operator for both the class and the instance. I can't change that. I'm not going to try to change that. So I'm going to use that term that way. Sometimes it can be confusing. Most of the time, the context makes it clear what is meant. Let's now look a bit deeper at the arrows. The arrows, they are not even actual elements of the plan. If you look at the XML that underpins the execution plan you see on the screen. Pro tip, do not look at that XML. Leave that to idiots like me who enjoy doing that. You won't enjoy it. But in the XML, you won't find anything that represents the arrows except the relative positioning of elements. But what those arrows represent is, I previously said, somewhat simplified how data flows. It actually represents which operators call which other operators using that get next call. But of course, the response of a get next is always, hey, here's the row you asked. So it's also represent how data flows, because if operator A calls operator B, then operator B returns a row to operator A. Now the rule is that every operator has to be called by and hence return rows to exactly one other operator. except the top left operator, which isn't actually a real operator. In that context, the calling operator is called the parent and the called operator is the child. So every operator has exactly one parent. The other way around, the rule is different because every parent has 0, 1, or more children, depending on the type of operator and what is needed in the execution plan. Combined, these two rules means that a mathematician looks at those rules and says, hey, this is a tree. That's a term from graph theory. Now, why do I put that on the screen? Because in graph theory, people talk about nodes, and there are sometimes places where you will encounter the term node as an alternative term for operators within a plan. And this term node never refers to the class of operators, always to an instant. A node is an instance of an operator class or a single operator. Let's work you through some common misunderstandings. I assume there are no questions yet, Charlie? Silence, so my assumption will be correct, or Charlie fell asleep. Anyway.
You're correct. There aren't any questions at the moment.
Good, good. So the cost percentages. If you look at an execution plan, you see numbers, and those numbers are very easy to parse and understand, and they can be very easy to use. At least that's what many people think. Again, this is demo code. This is not intended to be in any way representative of anything you should ever do for yourself. Please, in your head, assume that this is a large 5-page query that my client called me to optimize, and this is the new 4.5-page query that I wrote instead that does the same thing, but I will say it's going to be faster. I did my job well. I made it faster. And the client says, yeah, but can you improve it? So one thing I could do is highlight the entire text, both queries, and ask for the execution plan. Now, in an execution plan only, you also get an execution plan for assignments. We can just ignore that. So this is the first query. Whoa. This is the first query, and this is the second query. And if you look here, you will see that the first query has a cost relative to the batch of 99%, and the second just 1%. I made the query 99 times faster. I am awesome. I am a query tuning god. They should really give me a raise. Okay. But then some people who haven't paid attention when I talked through the first half hour will say, yeah, but Microsoft says it's an estimated plan. What if in reality it's different? Okay, I can now go on a complete diatribe about why those terms are confusing. But you know what? Let's humor you. This plan is called actual. Do you believe Microsoft when they call it actual? So let's include the actual execution plan. And let's highlight the text again and execute them both. And look at the execution plan. And now do you believe me that I actually made that second query a whole lot faster? Now will you give me my raise? Hopefully my client will fall for it. But if they are smart, they will say, what if we measure it in a different way? So they enable statistics.io and statistics time. And I will now disable the execution plan just because there's some overhead in generating and returning it. And I want to measure only the query. I run both queries. I look at the results. And the first query finished in 8 milliseconds and took 689 logical reads. But that was the slow one. And I made it, 99 times faster. I was going to say 100, but 99 times faster. So let's look at the second query, at how fantastic that run. It took, 54 milliseconds and, whoops, 94,000 logical reads. Looks like I didn't make it faster at all. It looks like I messed up. So what's going on here? So let's include the execution plan again. And I still have statistics.io and time enabled. So we still see those same logical reads. You also now see that the CPU time and elapsed time are different. That's the overhead I was talking about. So for very short queries, that overhead of the execution plan actually impacts these measurements. That's for 20-minute queries, you shouldn't need to bother about that. But in this case, it matters. But now you see that SQL Server itself has told me that the second query was slower than the first. So certainly when we go to the execution plan, the percentages now will tell me that the second query is still 99 times faster. So perhaps it's time to actually look at what these percentages represent. And I tell you, if you go in the XML, you will not find those percentages. They are computed by Management Studio, and they are computed from these numbers. So when I hover the select of the first query, you will see a value 0.584 here. And if I do the same for the second query, you will see a value 0.0065. And if you do the math with those two numbers, you will get to 99% and 1%. These are the numbers that SSMS uses to display this. Now, I want you to look very carefully when I highlight this number, how it's called. Estimated subquery cost. Estimated. I'm just going to highlight it a bit more because I want you to really see what it says here. Estimated. Even in a so-called actual execution plan, this is an estimate. The SQL Server estimates how expensive an execution plan will be as part of its process to select an execution plan for you. And it gives you that information. But it doesn't track the actual cost while the query is running, because Microsoft considered that to be not relevant, and they never figured that perhaps us consultants and employees might want to look at that. But this estimated subquery cost is based on the estimates that were used to generate this query, this execution plan, and those estimates might be wrong. In fact, if there is a performance issue in one of your queries, 9 out of 10 times at least, the root cause is a bad estimate somewhere. And now we are using measurements based on that incorrect data to tell us where the problem is. That's not going to work. And the problem is worse, is not just limited to this 99%, 1% I showed. What many people do is they look at an execution plan of a query that is slow, and they will say 50%, 50%, these are the two operators I need to look at, because those two are each equally responsible for this query being slow. But that 50% is once more based on a value here, which is an estimated value. And that value is based on the estimated number of rows of 1. Well, I've got a surprise for you. The actual number of rows was slightly more. So if you're looking at this value, you're looking at a value that has nothing to do with reality. And you're wasting your time in the wrong part of the execution plan. So those cost percentages, deceptively easy. But deceptive is the operative word here. Now, I'm not saying never look at them. You should know what they represent. They are based on the estimates. If the estimated row count is wrong, then the percentages will be wrong. And even if the estimated row count is correct, those percentages can still be misleading because they're based on certain hardware assumptions that are completely outdated and hopefully actually not your production server. I like to do a show of hands here, but I can't see your hands, so let's skip that and let's just instantly move to the answer. How do you read an execution plan? If you ever read the internet, and the internet is always right, we know that. If you ever read the internet, you know that you should read execution plans right to left. Well, if you religiously do that, you're doing it wrong. But left to right is also not the correct answer. So to understand what the real answer, let's look at what happens. And remember, select is not a real operator. Select represents the client that wants rows. Filter and table scan are the real operators here, and they respond to a get next call. So when we run this query, this execution plan on the screen, the client will say, hey, I want a row. And filter says, sure, but I don't have a row. Table scan, give me a row. Table scan will read a table, return a row. Filter will do its job. Look at the data in that row to see if it qualifies. No, this row is not good. I don't want it. Table scan, give me another row. Sure, here's your row. The filter will once more inspect the row, and this is a beautiful row. It's exactly what select will want, so we return that row to the select. The red arrows on your screen from left to right represent the flow of control. The blue arrows on your screen from right to left represent the flow of data. Often, when you try to understand an execution plan, it is helpful to follow the data, which is why we often read right to left. But the flow of control is also interesting. I have seen execution plans with a complete Christmas tree of operators, and then somewhere in the top left is an operator that sometimes doesn't call its child. If you always start at the right and work your way through that Christmas tree, you have just spent 2 hours analyzing something, and then you get to the operator that says, oh, for this execution where I was very slow, this entire subtree didn't run. 2 hours later, you find out that you wasted 2 hours of your life. That is not a good idea, and that's why you shouldn't strictly read right to left. But strictly left to right is bad as well, because that makes it insanely hard to understand what's going on, because you don't know yet what data you are working on. So it's a mixture. Sometimes left to right, sometimes right to left. And the most important skill in determining how to read an execution plan is experience. The more execution plans you have seen and looked at and analyzed in your life, the better you get at recognizing, oh, this substructure does this task in the query, and it does it in a good way. This is not the problem. This structure does that, and that might be the problem. And here is an area of the execution plan that I don't understand, so I should really dig into that first before drawing any conclusions. That is the level you will get at with several years of experience. It's not the level you will be at after attending this session today. This takes experience. Now, I promised to talk about properties. And if you think about execution plans, you should compare them to icebergs. It's well known, icebergs only I think 1/7 of the iceberg, if I remember correctly, is visible above the surface. That is the graphical execution plan you see in Management Studio. The properties are hidden beneath the surface, but they are far more information than just what you see on the screen. So let's look at the demo. We have 2 different queries here. They should return different results. If I ask for only the execution plan, then I get 2 identical execution plans. The pictures are the same. Trust me, the execution engine does not see the query. The execution engine only has the execution plan, nothing else. So if I have 2 identical execution plans, then when I execute them, you would expect the same results. But of course, the queries are different. And we know that SQL Server doesn't have bugs on queries this simple. So of course, the results are different, as they should be. But yet the execution plans do look the same. And again, that's because we're looking at the tip of the iceberg. So let's look under the surface. If I hover the clustered index scan icon in the first query, first execution plan, no, let's go to the second first. If I hover the clustered index scan of the second execution plan, then you will see this pop up and it says output list and 5 columns here. Exactly the 5 columns we wanted in the query. The 5 columns we get in the results. I also see a predicate here that it's hard to read with a lot of extra information, square brackets, parentheses, but what it actually says is modified date is larger than or equal to January 1st, 2013. And that matches exactly what we have in the query. So here you see the properties that tell this clustered index scan only read rows that match this and then only return the specified columns. When I look at the first query, you will see that there is no predicate here. So all rows are red. And the output list is much longer. So long, in fact, that it didn't all fit, as you can see by this ellipsis. Now, if I still want the full information, I can right-click and click Properties. And on my screen, you see nothing happen. But if I close this Properties pane here, it will reopen when I do this. I always leave it open because I use it all the time. Now, my mouse is on the left part of the screen, but I want you to focus on the right part when I click around, because every time I click somewhere, the contents of the properties window changes. The properties window always shows the properties of whatever is highlighted in the screen. So if you use the properties pane a lot, just leave it open and click somewhere to select, and you have the data available here. You see many more properties here that are not in this pop-up. And if you have a long output list, you can just click this ellipsis button and you get a window that shows it all. And you can resize this window. You can select and copy paste from it, whatever you want. So there you have the properties available. A short recap: hover over an operator, you get a quick pop-up that gives you a selection of properties, perhaps not always the best one selected by Microsoft. I don't always agree with their choices, but it's a convenient way to quickly access the properties. You can also hover over an arrow. I didn't show that in a demo. Then you get a subset of the properties only related to the data returned. And you can also right-click and select properties to get the full properties list. Now, there's also, like I said, the top left operator isn't the real operator, it represents the client, but it still has properties. These are properties that are about the plan as a whole. And at this point, you think this is a very limited list. Why are you even talking about it? Well, if I click it, and I will bring the properties window to the center of the screen and increase the size a bit, you will see that there's actually a rather long list of properties. And there's even several more that are missing from this very simple query. But there are useful things in there, like what weight statistics were happening while this query ran, what trace flags were active, what set options were active. This is the set statistics time option. I don't need it anymore. Information about the memory grant, much more. I'm not going to talk about all of it, but there's a lot of very relevant information hidden in the properties of the top left operator. Always look at it. So we have properties that change how an operator behaves. A clustered index scan that returns all rows or only those with a certain date. It returns all columns or only a subset of the columns. We have properties that describe information about the compilation process, like the estimated cost or the estimated number of rows. And we have the runtime statistics also stored in properties, such as the actual number of rows. All that information is there. Many operators have names that are fairly self-explanatory. Sometimes the names are misleading or unclear, and then you can always go to the execution plan reference, where you will find all the properties that I know of completely documented. We still have 5 minutes left, so I can quickly do a quick version of the first example, unless there are questions, because I always prioritize questions. But Charlie would have interrupted me, I assume, if he had. So I have a simple, well, slightly more complex than before, but still not that complex query. I filter on product ID equals 710 in the sales order detail table. I then join that to the sales order header table so that I can group by customer ID and then return that customer ID and a count of their orders and a sum of the order quantity. I order that by the total quantity and then only want the first 10 rows. That is my query. If I run this with the execution plan plus runtime statistics enabled, I get data, but I also get an execution plan. And you already see this execution plan is more complex than what we saw before. In this case, I will start reading at the right because in this case, it's safe to start reading from the right. I know that because I already looked at the complete execution plan. So at the top right, we have an index seek. An index seek is an operator that uses one of your indexes to efficiently access data in a table. Whoops. Let's do that again. And now not click in the wrong place. So what we see in this index seek is which index it seeks. The IX sales order detail product ID. If you know your database, or otherwise you can look it up, you know what how that index is defined. I know it's an index on the product ID column. That is also confirmed by the seek predicates, which tells us use this index to quickly find all the rows with product ID 710. And then once you found them, return these two columns, sales order ID and sales order detail ID. I expect that we will find 44 rows, and indeed the runtime statistics confirm, yep, there were 44 rows. Now, I want to return to sales order ID and sales order detail ID, the columns being returned. Because filtering on product ID 710, that makes sense. We understand why that's done because it's in the query. So that's a logical thing in this operator. But returning sales order ID and sales order detail ID is a bit weird. Sales order ID, okay, that is used here. So that makes sense. But why is sales order detail ID returned? The query doesn't ask for it. So why do we return it? Well, let's hold that thought for a bit. This nested loops is a join operator that says, you know what? I'm going to grab your sales order ID and sales order detail ID and then push it. Oops. Let's execute it again because I actually hit the wrong button. And then push those. I'm messing up today. I'm sorry. So I get sales order ID and sales order data ID from here, and I push them into the key lookup. So those values are then passed to the key lookup, and then the key lookup can use sales order detail ID and sales order ID. It's also somewhere here to find the rest of the data and return the order quantity column. And that's why we needed the sales order detail ID column. So by following the columns, things start to make more sense. So what you then see, I'm going to speed up a bit and not show everything. If you want a longer explanation, find a longer version of this on YouTube. Preferably the one I recorded at home without time constraints. But what you will see is that now this nested loops doesn't need the sales order detail ID anymore because we now have the sales order ID and the sales order quantity. Then the sales order ID is passed from this nested loops into a clustered index seek on sales order header. That is to do this join. And then we sort. This sort does not match this order by. This sort matches the group by. The reason for that is stream aggregate does grouping but needs the data to be sorted. So this combination of sort and stream aggregate does this grouping. And then we have the final sort. This sorts by total quantity, which is now computed by the stream aggregate, and then returns only the first 10 rows. Now the interesting thing, if I change product ID to 711, then I get a very different execution plan. And that is because in this case, a filter on product ID is 711 is estimated to return 3090 rows. In this case, also correct. With this estimate of 3090, all the choices made for the previous execution plans are not effective anymore. Now SQL Server says, I can better not do nested loops, but do a hash match and do a clustered index scan instead of an index seek plus a lookup and an index scan here. And instead of sorting and stream aggregate, I do a hash match aggregate. And the only thing that remained the same is the top n sort here. All because of this estimate was different. In this case, the estimates were correct. So it's very likely that the performance was optimal for both cases. Now, I promise you some resources. If you want to read more about execution plans, grab a copy of SQL Server Execution Plans 3rd edition. Make sure to get the 3rd edition. 1st and 2nd edition are still available in some places, but the 3rd edition is much, much better. So make sure to get it. You can download it for free from Redgate. I hope I think the tiny URL should still work, but otherwise just search on the Redgate site or send me an email and I'll help you find it. If you prefer a Dare3 copy, then you can order it from Amazon.com. That's not free. More information about specific operators, details, properties on the execution plan reference. Very extensive training on my website, sqlserverfast.com/video. 10% discount valid until the end of October. And on my website, you will also find an overview of all my future speaking, where you can find when there are new pre-cons planned. If you want to attend them, you can learn a lot about execution plans a full day, and you get a 20% discount on the video training. Are there any questions at this time? I know I have exactly -1 minute for them, but are there any questions, Charlie?
No, there are no questions actually on the stream at the moment, but I think you went pretty comprehensively through a lot of the different stuff, so it's understandable.
Yeah. And given that I started 4 minutes late and ended only 1 minute late, I'm happy with how I did for time. If you have questions, my email and my Blue Sky are on the screen again. Don't hesitate to reach out with questions about this presentation or other questions relevant to everything I do in the community. I'm happy to help you if you are stuck with something related to database design, to performance, to execution plans, to SQL Server coding in general. If it's a small question, I will just help you. If you want me to tune a 5,000 line query for you, I will send you my rates. Thank you, everyone, for attending. Thank you, Charlie, for hosting me and for monitoring. I think this concludes the day, so I hope everyone had a great day. Over to you, Charlie.
Thank you very much. Thank you, Hugo. That was great. And we hope you have a great evening. You've probably been preparing this morning as well. So thank you very much for all the time and the effort spent on our conference. And I hope that I see you soon, actually, hopefully this year or early next year when we go to the MVP Summit or to one of the other conferences. Oh, actually, you're going to be with us next month in the database conference in Zurich, right?
Yep, I will be in Zurich. I will also be at the MVP Summit. Like I said, well, the MVP Summit is not on my website because that's not speaking, but everywhere I speak, you can find on my website. I will be in Zurich. Yep.
Excellent. Well, I look forward to
not
seeing
with
you.
pre-con, but with a regular session.
Yes, that's right. Okay, but thank you very much, Hugo. Have a great afternoon, and
thank you.
I'll let you go so that you can get on with all the other things you've probably got planned for today. Say hi and have a good day.
Bye-bye.
Bye-bye. Thanks. And with that, everybody, we're going to wrap up our room. As you can see on the screen, these are the different things that we had planned and what has been delivered today as well. What we can see here is that there are lots of different types of sessions that were delivered in room 3. You'll also see here that in rooms 1 and 2 and 4, if I can get there, yep, there are loads of other sessions as well that were delivered, which you can actually find on our YouTube channel once we've actually split them up and put them into separate sessions. And I would encourage you to always take a look and see what you can find. The content that's being delivered here is excellent. The speakers that have been delivering this content are excellent, and we look forward to seeing you again next year. With that, we're going to close with the sponsor media. So some of the ads that were done from our 3 different sponsors. Thank you again to Etta, to you, to Darton, and Ubungi for
Timișoara este un oraș cu peste 350.000 de locuitori. Suntem o primărie destul de mare, în jur de angajați și încă mii în subordinea noastră.
Ne ocupăm cu digitalizare de documente. Primăria va fi la fel ca și o companie multinațională care are sisteme foarte avansate.
Aș fi luat aceiași furnizori. Dacă am fi putut începe de la început cu ei, bineînțeles că eram 2 ani mai avansați.
Acum forțăm tot ecosistemul să vină după noi. Această eficientizare ne lasă să ne focusăm pe ce este important, adică pe partea creativă, pe partea empatică.
99% din primărie, din procedurile ei sunt digitalizate.
N-ai nevoie de studii bine imaginabil de multe tehnice ca să poți lucra cu un program atât de simplu. Vă doresc cât mai multă răbdare. E un proces anevoios câteodată, dar excepțional în momentul în care este finalizat și implementat cu succes.
Hello, DataBash. I'm Arthur from the DatenWG core team, and we are a bunch of dedicated Power BI, Fabric, and Copilot experts who are really enthusiastic about Microsoft Data Platform and all the community stuff. This is B5. Humbly, we call us the Avengers of Power BI, and this is how we really look like if you want to see. Just feel free to contact us on anything about the Microsoft Data Platform and have fun at DataBash.